pressure continues to be normal.
RC chamber pressure looks good.
Doubling up. Roger roll, Atlantis.
Water towers can fly! Yes!
Tango Delta nominal.
Flight downside SC off. Bring in SC off.
Yikes. You bet. Concur. We don't need any more of these.
Good morning, everybody, and welcome to the Mojave Air and Spaceport. You are looking live at Stratolaunch's rock carrier aircraft, which is carrying for the first time the Talon-A hypersonic testbed. This is the first captive carry test flight of Talon-A's hypersonic testbed. Huge thank you to Stratolaunch for partnering with NASA Spaceflight and helping making this stream possible. We're bringing you live coverage of today's test flight from Mojave, California. And thank you all so much for tuning in. I'm going to go ahead and look in chat, and I'm sure I'm going to see a bunch of 5x5s in chat already. Yep, there they are. Thanks for letting us know that you can hear us. It won't be just me on commentary, though. My name is Thomas Burkhart, News Director here at NASA Spaceflight. I'll be offering some commentary and updates on today's test flight as we get going here. Got a couple other people on comms, though, as well. I believe we got Das here on comms with me. Das, you doing all right?
True, I'm here, Thomas, ready to see Rock fly today.
Looking forward to it for sure. Also got some folks from Stratolaunch on comms with us today. First of all, Grace Wang, you've been on comms with us before. How are you doing this morning?
I'm doing great. Thank you for having me on again.
It's always a pleasure to have you on here, Grace. I believe we have another Stratolaunch rep also on comms today, potentially a new voice to the NSF coverage. James, we got you here.
Hey, yeah, this is James Kelly. Glad to be here.
Thank you, James, for joining us, and Grace as well. So there's a couple of Stratolaunch people there, of course, be the most knowledgeable folks on what's going on. So we're definitely going to be listening into them so we can see what exactly the teams are working through the various points of today's test flight, which could be a couple hours. Out there in the field, I'm like 99% certain that Jack's on comms right now. So Jack Beyer is out there in the field at Mojave. Jack, you here with us?
Oh, I'm here, and it is an excellent day. It's been a beautiful morning, and it is even more beautiful right now that the sun is up. And of course, it's extra beautiful because why? Because it's a day where we're going to do some test flight, and we're going to learn new things, and we're going to fly new stuff. And it's the first time we've ever seen Rock fly with Talon under the wings. So, yay, new stuff, test flight, good day. That's my executive summary there.
As a wise person once said, test flight is, in fact, best flight. So thank you, Jack, for rolling out there, and definitely looking forward to it. Not on comms, but I believe we also have Pauline Acklin out there in the field for NASA Spaceflight. So Pauline, thanks for rolling out there as well, helping with the camera views and things like that. We got a whole bunch of cool cameras to show off today. Obviously, you're looking down the runway at Mojave Air and Spaceport right now. And if we get an up-close shot, you're going to start to see that there's something underneath the wing of Rock today, which is something new. We've seen previous flights where they were testing the pylon that would carry different vehicles underneath Rock, but now there's something there. This is a separation test article for Talon-A. Grace, want to walk us through exactly what this Talon vehicle we're seeing on the screen right now is and what it's going to do?
I would love to. So today is the first captive carry of TA-0. So our hypersonic test vehicle is called Talon-A. We've got a couple versions of it. So TA is an abbreviation for Talon. And so 0 is the first one, and that's the one mated today, and that's our separation test vehicle. TA-1 will be the first vehicle that goes hypersonic, and that will be dropped into the ocean. And TA-2 will be our first fully reusable hypersonic vehicle, and that's the eventual goal. So today's the first captive carry. Like you said, we've seen the pylon before, the like U-shaped thing beneath the center wing, but the thing underneath the U is TA-0, and hopefully we'll get a closer look at TA-0. And I'm super excited that we have James Kelly on here today because he works on the TA-0 program, and I'm mostly on Rock, so I can tell you like kind of some bare bones basics on TA-0, but if we get any like in-depth questions, I'm gonna throw them to James, let him do the heavy lifting.
Oh,
do we have
good.
Miata stats today? I hope we have more Miata stats.
You know what? I forgot about that until late yesterday and then was like, what vehicle should we use this time? And then I was thinking about blue whales, but then like the blue whales are like way too big actually to compare to Talon today. So we'll have to pick something else. I don't know, James. Did you have something in mind?
Maybe more like a Cadillac.
A Cadillac? Well, okay. So TA0 today, it weighs 2,400 pounds about, which is like 1.1 thousand kilograms. How much does a Cadillac weigh?
Probably pretty close to that, or maybe like a, I don't know, like a F-150 truck.
Sorry, we're gonna have to go do some Googling real quick. Thanks.
We got to make sure we get the units right on those comparisons, but we appreciate that for sure.
I'm sure some helpful commentary will kind of give us some assistance there.
All right, folks, also, as we get into, obviously, we're going to keep overviewing exactly what's being planned for today and also when we're going to expect things to kind of kick off here. You can see the Rock and Talon-A, or TA0, I guess to be specific, have been pushed out onto runway 30 at Mojave Air and Spaceport, and they're currently undergoing pre-flight checks and things like that. So, Grace, what are the teams going to be working on right now, and what's our timeline to get airborne here in the early morning?
First, let me retract some statements that we made in error. Apparently, a Cadillac weighs like 5,000 pounds, like twice a Talon-A. So we're going to pick something else.
We'll pick something else, all right?
Yeah, hold on, sorry.
Yeah, no worries. But also, while we get those updates and things, we'll obviously keep providing those throughout the test flight. We're also going to take some questions, though. So if you've got questions in chat, please tag us at NASA Spaceflight as per usual. And I'll try to bring as many of those in as we can. I'll pass most of them along to the Stratolaunch folks because they know what's going on here. But I'll try to pick out the most relevant questions and things like that. Also, a huge thank you to everyone who sends, support our way and things like that. Going to try to focus on the updates of today's test flight and answering questions and things like that. But we do really appreciate everyone who, of course, sends support on these streams and all of our streams. But yeah, so Rock and TA0 under wing are both at runway 30 at Mojave Air and Spaceport right now. You can see it's just a little bit past sunrise, still some fog in the background there. And we're going to be standing by, and once we have an update as to our takeoff time, we'll provide that. But that should be fairly soon. You can see some personnel around the base of the Rock aircraft right now. And yeah, so Jack, I'm going to go out to you because you're out there in the field. How's it feeling this morning?
It's good. There's like no wind, at least not right now. I'm looking at a windsock, and it's just sitting there limp, which is what you want to see. Everything's looking good. I don't even think, you said that there's some fog. I don't even think that's fog, Thomas. I think that's dirt. Like, there's a lot of dirt roads around the spaceport. Yeah, and then people drive around, that dust gets kicked up, and because there's no wind, it's all kind of just settled low to the ground like that. It really looks beautiful with the lighting the way that it is right now. This is going to be an awesome takeoff this morning. So a little bit of a historic moment for the program, and some good views to boot. So you really can't ask for anything else, can you?
Right, yeah, absolutely. It looks great. And I think we'll keep an eye on that because a takeoff should be a gorgeous shot. We've got a couple different camera views that are all super, super cool. So we'll be piping the best views of takeoff that we can here.
We've got one view that's particularly super cool, but I'm not going to spoil that until it happens.
Yeah, I was kind of alluding to that, but we're not going to go there, I don't think.
Of course, Jack is so excited he just has to let the cat out of the bag. Like, if you don't want spoilers and
he hasn't let anything out. He just said there's a cool thing.
under promise, over deliver, but kind of over promise. Okay, I'll stop.
All right, Jack, I'm going to mute your mic, okay?
Hey, this is Grace. Me and James are back.
Yeah.
So yeah, where you can see we're out on the runway. All engines are started. We actually usually start 2 before we tow out, but they're all started now. And right now we're doing the whole sequence of pre-flight checks. And for an airplane this complex and big, it kind of takes a while. So right now we're doing flight control sweeps.
Awesome. Okay, so I'm also going to ask probably some questions that you've probably answered on stream before, because every time we do some of this coverage, we definitely get people who have not seen any of the previous Stratolaunch flights or are not familiar.
Yeah, of course, we love repeat questions.
Well, because we want to give everyone the background on what exactly we're looking at. In fact, I saw one chat message already basically saying, what the heck am I looking at? What does this thing even do? So, quick rundown. I mean, this is, I believe, the world's largest aircraft by wingspan, correct?
Yes, it is the world's largest airplane by wingspan, 385 feet long, which is longer than an American football field.
Which is, of
And
course,
for
the unit
those of
most
you,
Americans are most familiar with, so we
yeah,
appreciate that.
fine. Okay, it's like 117 meters for anybody who wants that, aka the rest of the world. Yeah. So, what is this thing? It's an airplane. It flies. Hard to believe, but it does. Those like
Despite
little.
how it looks, it does in fact fly.
I mean, the first time we towed out was the first time it like hit me that this thing was an airplane. Despite working on it for years and years, it just became like an immovable bridge being built inside. You know, there's a little ramp out from the second floor engineering offices that goes straight onto the wing, and the wing was on like this big fixture, and we were still building it, so it was hard to think of it as an airplane, right, James?
Yeah,
You like just go walk out on the wing and you're like, no follow us because there's stanchions and stuff, and you just go to where your shop needs support to answer questions, and then you go back, and this thing never moves. Like this thing didn't move until we took it out from the scaffold. That's the first time it moved. It was like a couple feet down when we set it on the gear, so that was weight on wheels. That was a big milestone. And then rollout was when it's like, oh man, this thing's gonna fly. What? Are we
Mhm.
crazy? But yeah, it's an airplane. And why does it look so weird? There's some good backstory about that. We can talk about that later. But yes, it's an airplane. Its mission today is to carry Talon. We're going to do captive carry. We're not dropping Talon today. And the pylon underneath it is a new build since the first time we flew it was Flight 5 in May of this year. And now we're flying Talon for the first time. So the main goal of this flight is to measure the forces between Talon and Pylon, the aerodynamic forces, and that'll help the Talon Aero team validate their analysis. So we're gonna go take it for a ride for the first time, come back. Hopefully nothing too exciting happens.
Right, yeah.
think
The,
I
the best
can-
test flight is, in fact, a boring test flight, right?
Yeah. So maybe today will be super boring and we will have nothing to say.
I think I can continue my apparent role here as a spoiler. When we do start talking about why it looks so weird, I think I have a short 2-word answer as to why the plane looks so interesting, and that 2-word answer is Burt Rutan.
Yeah, well, there's a bit of
I
that
love
going
it.
on for sure.
That is not untrue.
It's technically
Not
correct,
untrue.
the best kind of correct.
Yes, I love how his airplanes are all crazy looking. James and I both worked at Scale Composites too before Burt Rutan's company. How long were you there, James?
I was there about 5 years. I spent 4 years actually working on the Rock aircraft, so I'm mostly familiar with Talon, but I did work on the Rock aircraft for about 4 years.
Yeah, and you were working on Rock Avionics too, right?
Yeah, exactly.
Yeah, it
Alright.
looks. Let's just throw it on James. Rock looks weird because avionics made it look weird.
Yeah.
They wanted really, really long wire runs.
The outside looks weird. The inside looks weird too.
Would you
Yeah,
say
you
the
know,
inside looks weird, James? Yeah, weirder than other airplanes? It looks great. Bunch of wire
Well,
bundles.
it's big and mostly empty. I mean, there's a lot of wiring, hydraulics, pneumatics, but a lot of people ask, is it empty? What's on the
Yeah.
inside? But
Yeah.
it's actually a lot of empty space.
Yeah, which is kind of a luxury when you're working on airplanes, right? Like we do have tight spots. Like some of our mechanics
Sure.
will yell at me. They're like, "Are you kidding me? I had to like spend 2 years stuck in this little bay inside the wing doing tapes." But no, like the fuselage, like running wires, usually you're in like a tiny space in an airplane and you have like zero clearance to do anything. But here it's like it's like the
like you can
McDonald's
stand up.
play
Like,
places. Yeah,
Right.
yeah. You could stand up, you could do cartwheels and stuff if you're brave. Yeah.
it's funny. You say avionics made it look weird, but I've also had avionics people tell me that everyone else's problems eventually become avionics problems. So we'll give James some slack there.
Yeah, sorry, James. I don't know. What was the original question? We kind of diverged.
We were just talking about
I
basically the
forgot.
overall mission of Rock, and I guess in this case, Talon-A now. So you mentioned we're not going to be separating Talon-A or TA-0 specifically today. So it's just a captive carry flight and mostly facing around like validating those aero models.
I guess we could zoom way out, James. We could go from like the Okay, what is Talon supposed to do? Because we didn't even talk
Yeah, like
about that yet.
we're
Yeah.
getting questions. What's the eventual goal of like operational Talon vehicles?
Yeah, that's the obvious first
Yeah.
place to start.
So Talon-A in general is a Mach 5 class reusable hypersonic test bed. So the intent is to offer customers the opportunity to test their payloads on the vehicle, once we launch it in a hypersonic flight regime and collect data, that's meaningful scientific data.
Yeah, like what kind of payloads would the customers be wanting to put on?
Yeah, so in hypersonics, a lot of people are looking at, different thermal protection systems, things that can withstand the harsh environments of hypersonic flight. Like, things get really hot when you fly hypersonic, right? Because of the air friction is increased. So a lot of payloads, look at things like that, thermal protection systems, and different sensors that they can use to better characterize those systems and how they perform.
Yeah, thanks, James. So that's the eventual goal. Okay, let's back it up to today. So
Mhm.
the fully reusable Talon hypersonic testbed is TA2. That'll be the first one.
Right.
And then TA1 is the non-reusable but hypersonic testbed.
Mhm.
TA0 is our separation test article. Do you want to talk about like how similar are TA0 versus TA1 and 2?
Yeah, sure. So TA0 is very similar. I mean, it from the outside, it looks just like TA1 and looks just like TA2 is going to look. TA0 today is a little lighter than TA1 will be because we do not have propellant on there.
Mhm.
And so we're not going to light the engine today. We're not releasing TA0. Like you mentioned, we're measuring those loads that are imparted back up into the pylon due to the aerodynamic forces. That's one of the big test objectives. We're also checking other things like a lot of avionics stuff. Actually, we're checking that we can get data back from the TA0 vehicle. You can imagine.
A lot of those are your test points, right?
Yeah, they are. So I mean, there are a lot of avionics inside, such a small vehicle. That thing is not nearly as empty as rockets. So
it's a lot more cramped. So
Right.
like I'm mostly a structures person, so I know nothing about avionics. So what kind of things are you looking for today?
So I was thinking this morning. I always like to compare stuff to cars because I'm a car guy.
Mhm.
When I'm not working on hypersonic vehicles. So a lot of the sensors we have are pretty similar to what would be in a car. We measure temperature, acceleration. We have GPS. We have pressure sensors, position sensors. And that makes up most of the sensors on there, but we just have a bunch of them. It's a lot of data that we're collecting today. And we want to make sure we get all that data back from Talon into the control room.
Cool. I mean, so we always talk about this like build up test approach. So it's not the first time you've tested any of these things on Talon by any means. Like you've done it on the ground and then the next stage was during taxi test. So what's different like between a taxi and flight that you're like, oh, okay, maybe this is going to work different. Let's see.
Yeah, I mean, a lot of it is the same. It just, it becomes a different environment whenever you fly, right? So I think of it, in terms of the avionics, you're in a colder environment now. You're at altitude, the air's thinner,
Yeah.
it gets colder.
Yeah.
You're in a different vibration environment. Things are shaking around a little bit more. And of course you have the aerodynamic forces on the vehicle now. So
Yeah.
you can check as much as you can on the ground to, build your confidence that it's going to work in the air, but eventually, like we're doing today, we have to go test it in the air.
Yeah. Sweet. So that was like mid backing up, and then Rock, I guess this is a very background player. It's just a supporting cast. It's a mothership just to carry the star of the show today, which is TA0.
Absolutely. Oh man, all right. So this is everyone. You can see why we bring Grace and James onto these streams because they know everything, and I just sit here and ask a question, and then they talk for 5 minutes about all the amazing things, and I appreciate it
Thanks,
because then they have
James.
time to look at even more questions because we're getting a whole lot of them. So I'm just going to keep them coming here. But please jump in also if you get any updates as to they're getting close to finishing those pre-flight checks or getting close to movement and stuff like that. Please just jump in and interrupt me. But all right, I'm going to go to our next question here, which is asking about the Rock carrier aircraft. And although I guess this is also relevant to Talon, basically, are there any plans for Rock operationally to be able to operate from different operating bases other than Mojave?
Yeah. Yeah, we're capable of flying off of any runway that a B-52 can. So it's actually more flexible of a scenario than you would think with this weird-looking airplane. So, yep, we can fly in different ranges.
All right. But I believe the initial Talon flights are all planned to be from Mojave here, correct?
Yeah, the short-term test flight campaign is all planned from Mojave. It's really a perfect place to fly, and as you guys know everything. I'm preaching to the choir.
Oh
Clear
yeah, Mojave,
skies,
the Mojave test range is just perfect. I mean, we've been out here for other things as well, and it is the home of test flight, I think, is how Jack describes it. So I would agree with that. All right, I'm going to bring in another question here. We got some questions basically asking, I guess let's start with today's flight. Dean's asking how long of a flight is planned today, and also how high, what altitude they might be reaching today.
Yeah, you want to take that one, James?
Yeah, so today we have several test points at different altitudes, but I believe our max altitude today is 22,500 feet.
All right. I'm going to bring in some more questions. Oh, yeah. So then the follow-up question to that was asking, what's the highest altitude that Rock can reach itself? Not necessarily pertaining to today's flight, but what they can, what you can reach on future flights if needed.
Yeah, we are flexible. We can support all sorts of different customer needs. So we tailor all of our flights for whatever our future customer needs are.
Gotcha.
Yeah,
All
but
right,
in general, like, sorry, that was a vague answer. But generally, we can do like airliner altitudes, plus or minus.
Yeah, okay, gotcha. I mean, a lot of these systems are taken from airliners, right? Like Rock has a bunch of 747 parts on it, if I'm not mistaken.
Yeah, I find that part so fun about Rock, like how a lot of the systems are cannibalized from another airplane. I can tell you some. James, do you want to take this one?
Oh yeah, talking about
Yeah, you were around
what we
when
built Rock out of.
Well,
Yeah.
neither of us were around when the two 747s landed that we cannibalized. So that was like maybe a year, I think, before I got to Scaled.
Yep.
But yeah, Scaled bought two 747s for the sole purpose of taking things and putting it on Rock.
Yeah, exactly. So yeah, when Grace and I came in, I think, yeah, maybe a year or two after they had flown into 747s and started taking them apart. I actually saw pictures of them when they started disassembling it. It was pretty cool. But yeah, the engines are from the 747. Actually, a lot of the avionics are from the 747. So, some of the radios and things like that. But the entire airframe, of course, was designed and built by Scale Composites back in the early 2010s timeframe.
Yeah, the whole like flight deck was cut out of the 747, right? Like the co-pilot, the pilot seats, like the floor, that was from the 747. The cockpit, like the outside structure, like the whole structure of the fuselage and the cabin is new, but the seats, the like floor under the seats, the panels new. We put new stuff in it. And then yeah, a lot of the boxes, the systems boxes. I worked on pneumatics, so I'm like kind of biased, so I only know about that. But we took the 747, like the pneumatic system in the pylon of the engine. Like we didn't change anything about that, but we had to install a new pneumatic system in like the leading edge of the center wing to feed the engines. But we did reuse a bunch of the tubes, like they're like big 7-inch ducts from the 747. We used those, and then a lot of the avionics boxes to control the valves and stuff in the pylon, like the ACTU and like various things, and some of the power units and stuff too. We took from 747, and
The landing gear too, right?
yeah, the landing gear.
Another fun
The
fact,
engines.
if I'm not mistaken, on the landing gear, since we have 6 gear, and I think we only use the inboard body gear, right?
Yep.
So we had to get the 2 more body gear from a third 747
Mm-hmm,
to make up that, the full 6 main landing gear, I believe.
Yeah, that's correct. We also did that with the engines. If I maybe somebody, one of the control room will correct me, but I think that's what we did with the engines too. We only used one of the types of pylons. I'm not sure if the engine itself is different, but I think the pylons are different.
Yeah, that would make sense.
So yeah, we had to buy some like extra parts too. So two entire 747s were not enough for this airplane.
It's like 2.5.
Yeah. And James, why would we do that instead of like making everything from scratch?
Well, first thought is it saves a lot of time. From my perspective, being, the avionics guy, designing, HF radios and VHF radios from scratch or buying them even, right? New would be really time consuming, schedule intensive, expensive. So you kind of start off already into a partially designed aircraft, right? And you kind of build the airframe around it and make sure the systems can talk to each other from a starting point that's already, kind of far along.
Yeah, like all the 747 components have so many hours on them, so they're like proven flight equipment.
Right.
So you're not starting from like very, very zero, but it's still not easy. You have these, then you're like, okay, well, how do I structurally attach it to this new airframe? So there are challenges there too. Like this metal gear, how are we gonna like bolt it to this composite airplane?
Right. Yeah, absolutely. Well, really quick, I'm going to jump in here with a couple updates. Also, I just want to point out this new kind of zoomed in shot. You can see the Talon-A vehicle under the wing of Rock. And it's weird. Obviously, it's because Rock is just a huge aircraft. But Talon-A doesn't look it doesn't look like it fills all of the space available underneath that wing. Is that because it's potentially on the smaller scale of vehicles that could eventually fly, or be carried and launched by Rock, basically?
Yeah, so TA0 and Talon-A in general was designed for a very specific mission, as the hypersonic test bed, and it's the total mass of Talon-A is only a fraction of the full capability that Rock can carry. So Rock and the center wing is capable or designed to carry about 500,000 pounds. So
Wow.
imagine we're only TA0 is 2,500 pounds give or take. So it's only a small fraction of what it was designed to carry. But Stratolaunch does intend to build newer and bigger vehicles in the future. I think you can actually see some of that on our website too.
Yeah, I believe so. I do want to jump in with the other update. I want to bring the chase plane, which will be flying alongside Rock for today's captive carry test, is starting its engine. You might be able to start to hear that in the background as well, because we are about but somewhere between 5 and 10 minutes from Rock's takeoff per Stratolaunch. So thanks for that update. 5 to 10 minutes from Rock getting airborne here, and I believe, like before, we'll expect the chase plane to be airborne first, right?
Yes, that's correct.
Cool. So we'll be keeping an eye out for the chase plane taxiing out for that takeoff, but engine start is underway for the chase aircraft, and then we'll expect Rock to be airborne not too long after that.
Yeah, the chase is a citation, and it will start up its engines. It'll taxi out. It'll take off first, like you said, Thomas. It'll circle around, and then basically pick up with Rock as Rock starts to roll. I can't believe I just did that. I'm sorry.
Oh, jeez.
It was
That
not
was
even
so good.
intentional.
So
I
good,
wish I
though.
could say it was intentional. I really do. But that's the flow that we will see here. We'll see the chase take off, do a once around. It'll pick up with Rock as it starts to roll, and then we'll be in business.
Two
Sounds good.
demerits. We're keeping count, right, James? Yes, 2 demerits for everybody.
All right. Well, we look for the chase plane to get moving here. Quick question that I think I can take, because Wonka wants to know if Rock is going
Flaps
hypersonic today.
Oh, sorry about that. You see, the flaps are down now, so we're still in the pre-flight checks portion, and there's a lot of things to check. So we were doing flight controls checks, which is the same as in any little airplane. If you've flown, you roll right, look out your window, make sure the ailerons are going the correct way. Like that has actually been a problem before. Roll left, and then pitch up, pitch down, rudders. So same like concept as we're doing on Rock, but there's a lot, a lot of like controls, a lot of systems. So right now the flaps are coming back up.
Right.
We have, oh man, 7 flaps per side, 4 inboard, 3 outboard.
How many
I'm pretty
degrees
sure.
of flap do you have again? Because it always looks like it's like
Yeah.
90. Like I
I
love how the
know.
flaps on Rock
It-
look because it seriously is insane. But it's
It's
not
like-
90, right?
Very aggressive. It's 70 degrees. So like, yeah.
I love
So-
That is still like way more than most airplanes.
Like, it might as well be 90, you know. But they were sized by trivia. We'll have lots of trivia today, James. But like, why do we have 7 flaps? Why didn't you split that same span into like 10 or 5 or 4? It was sized by the actuators, so that is one of the cool, like, okay, so we chose, like, this is a valid engineering method. Hey, this actuator is the one we want to choose. We'll let that size the flaps. And obviously, there's a lot of other stuff going on, but yep, we chose the actuators first. They're from 747. They aren't 747 flap actuators. I don't know where on the 747 they are, but they're actuators that come from the 747s we had.
Gotcha. All right, so
Sorry
I'm
for the
going to take.
interruption.
No, you're good. I'm just going to take this quick question because Wonka wants to know if Rock is going hypersonic today, and I'm going to go out on a limb and say no, and hopefully never. I don't think Rock is supposed to go hypersonic.
That's right. Yeah. If Rock was going
Yes,
yeah, we don't want
let's do it. Let's just call up the people real quick and be like, so you guys just, you know, you can push up the throttles like all the way.
Maybe it could be a race between Talon and Rock today.
I think
Pretty
Rock
sure
would
someone's
need.
done that in Kerbal Space Program before. In fact, I'm pretty sure Thomas has probably done that in Kerbal Space Program before.
I cannot confirm nor deny, Jack. I think Rock would need some help getting hypersonic. Talon looks like much more of a hypersonic vehicle than Rock does.
Yeah, one like non-sciencey, like quick way to tell how fast an airplane's supposed to go, usually I think, is like what the wing looks like. So Talon's
Yeah.
wing is like really swept back, and it's pretty small, like area-wise. You can, well, I guess you can't see that on the shot here, but like the wing swept back and it's kind of small, and so you can tell it's supposed to go a little faster. You've got a big wing on Rock, a little slower. So, like if you go fast, your speed, you get more lift from the same wing going fast. So Rock needs a bigger wing because to get the same amount of lift because it's going slower. So that's a very like quick. I'm sure there's exceptions to the rule, but you can kind of tell just by looking at airplanes.
Yeah. I mean, there is a thing to be said. Some vehicles look fast, some vehicles do not look fast. But yeah, absolutely, the wing area is kind of the dead giveaway there.
You can tell because of the way it is.
You can tell because of the way it is.
Well,
the way it
yeah, I
is.
don't know.
Yeah.
We were just talking about like sea creatures. I don't remember why, James, but yeah, like some animals just look like they're meant to go fast and some aren't. like they just look swoopier or something, you know, like sharks look fast, jellyfish look slow.
Some birds too. I mean, if you look at some birds and then compare them to aircraft, it's like, that looks strangely similar, you know.
All right, well,
there
there is
goes the
our.
chase.
I was gonna say there is our chase aircraft, and I was also about to point out it came up on flight radar, so I'm like, it must be moving soon, and then before you know it, there it is. So that is
Chase.
November 8 Echo Bravo is our citation chase aircraft today, and we'll be taking the runway ahead of Rock. Again, it looks like runway 30 is in use once again at Mojave, and we'll report that going airborne here shortly. I think we'll get a camera on that.
Yeah, in chase today we've got Anna Benet, Dave Bedores as the pilots, and Dom. Oh,
Going?
I can never pronounce his last name. Sorry, Dom. Dominic, our ingenious.
Yeah, sorry,
photographer.
Dom. I should know that too.
It's Moan or, and Vanessa Gonson, our observer, and brilliant structural engineer. She'll be watching a couple of things.
From the chase plane.
Anna, yeah, from Chase Plane.
Nice.
Yeah, she was in Chase last time too. A lot of the flights she's been in.
Yeah, I think
In
so. A
Chase.
lot of the pylon flights,
Mhm.
you know, she was in Chase taking pictures and watching it since that was her. I think she was the lead engineer on that.
Yeah.
I think you and Vanessa, yeah.
When she came on, she like helped take over the structure on Pylon, so there's the lead structural engineer. Yeah. And the gear. So I had to go back and remember it. We're getting up to so many flights. We can't keep track. When we were like every
Right.
4 flights,
Like,
it was
good
easy.
problem to have.
Yeah, it is. I was like, when was the first flight that we swung the gear? It was the third
Mm.
flight. So third flight, we just did that one. You remember it was weird. Everybody was like, why aren't all the gear coming? It was just one gear. We retracted the left mid main gear. That was third flight. And then fourth flight, we retracted all of them. And she was in both of those flights because she was heavily involved in the gear structure too. So like, it's
Okay.
always nice to have somebody up there like looking out for your structure, seeing if there's any like vibrations. They actually get up really close. I saw some pictures from Chase. They get up really close. It's such a cool view, it seems.
All right, gotcha. I got a question in chat asking if the chase plane has like a cool nickname or something.
I'm actually not sure. Yeah, I don't know. Maybe we should make one up for it.
I mean, sounds like chat wants one, so take that for what it's worth. But I mean,
Hey,
Rock
sorry,
is
I'm
a
back.
cool
Was
name
there-
for the carrier aircraft, so I think the chase
Yeah.
plane needs something.
Grace just came out. They wanted to know if Chase has
She's
a
playing
nickname.
it. I don't know of one.
I don't either.
Yeah, I should have
I was
There's
saying
got to
we
be a
need to
pun to
come
be
up with
made with the word chase and flying quickly or something. I don't know.
Chase and Rock. I'm not very punny. We'll have to like hand it off to Kate, I think. Let me write that down. For Kate.
Oh, man.
Anna, I found out yesterday. I think I knew this. Relearned. She like so cool. She's flown like C-130s before. Yeah.
Nice. Oh, hey, I just see another aircraft that just showed up on flight radar, and it's a little bit bigger than the chase plane, I think. Then we got AOS on a rock, which will be cool. I know I'm going to keep an eye on that so we can read out altitudes and things like that. But so yeah, chase plane getting close to taking the runway here, and we'll expect that to loop around, like Jack said, and pick up a rock as rock begins its takeoff roll. We touched really quick about the crew that is on the chase plane. Can you run us through who will be on board Rock today?
Yeah. Yep. So it is Evan Thomas as co-pilot, Steve Rainey, aka Hooter, as pilot, and our FE is Brad Shab, and that's our crew. We have 3 people. There's only 3
Gotcha.
seats.
Right. Yeah.
Is this Hooter's first time as pilot, or has he flown? Because I know Ivan has done a number of them, but I'm not sure if he's done all of them so far, or how does that work?
That's a good question. I can't remember if last time Hooter was left seat or right seat.
I can't either. I know Hooter has flown, but I'm not sure if
Yeah.
he was left or right seat.
Yeah. Yeah. Let me
Gotcha.
ask real quick, see if I get an answer.
Sorry,
So
I
right
threw you a
now,
curveball there.
so right now we're still in pre-flight checks, doing release system checks. I don't know if we just finished them, so we're doing like tightening belts, parachutes, O2. Like we're getting near the end. It's a lot of coordination between all the different players. There's ground crew. That's like the crew chief is Chantel Williams, and she's got her crew there. On the ground, there's flight crew in Rock, the Rock flight crew, and then there's like the Chase flight crew, and then there's control room. That's a whole fleet of engineers watching their parameters.
Mm-hmm.
Those are the 4 coordinate, and then there's like emergency support and everything. But everybody has to talk to everybody, especially to like time when Chase takes off, because you want that to be like a certain amount of time before Rock will be done with checks. So it's a little bit
Right.
of, it's a little bit of like of a dance.
And now, how does that work with? Because Rock has now been sitting on the runway for a few minutes, and obviously, as much as Mojave is a hub for test flight, and part of the reason I'm sure y'all are out there is because you have all of the room needed to conduct all these test operations that are so different from like normal airplane operations. But Rock has just been sitting on the runway for a while. How does that work coordinating? Like, hey, we're gonna need the runway for like 30 minutes or so, rather than, oh yeah, we need the runway for 2 minutes for a takeoff roll.
Yes, that is a whole job too. Coordinating with the airport. I am not actually sure what how that works. If we need to like pay for reserving a time, or we reserve the whole day, or we reserve like a couple hours in the morning for when we think we'll be on the runway. Or if it's non-exclusive, reserving, like, can people take off of runway 8? while we're on
Right, yeah, because there's a
30?
crossing runway.
Yeah.
There are 2 runways.
Yeah.
So
Yep, there's 2. Well, there's actually a third that it's 1, 2. There's
that's
a
right.
third
There are
runway.
3.
Yeah.
My apologies.
The ones we mostly use are like 826 and 30.
Right.
But yeah, I'm not sure if airplanes were able to take off on 8 because you can tell airplanes like, okay, take off 8, but like be off before 30 where they cross.
Mm-hmm.
So I don't know, but we have a whole coordination teams to make sure that gets coordinated with the airport.
Gotcha.
Just want to point out really quick, the wigwag lights are on. That's what those are called, right? I'm not just hallucinating and made that up.
Oh, the
nose gear?
Yeah,
Yeah.
the nose gear lights.
I swear on a previous stream somebody said, maybe it was Mason, said that they were called wigwag lights. Now I'm second guessing myself and I'm going to stop talking.
Yeah, they are wigwags. They may have other names in the aviation world, but they're wigwags. I mean, if you think about like emergency vehicles that, the lights flash back and forth left and right, those are also called wigwags.
Awesome. Thank you for confirming I'm not insane. At least
Also,
about this.
speaking, yeah, not about this, but otherwise. Speaking of Mason, he is here with us today, keeping track of cards because James and I cannot multitask. So thank you, Mason. He's telling us that up next is Chase launch.
Gotcha.
All right.
All right.
Yeah, we're watching for it to roll out onto the runway there.
So chase aircraft going to be getting airborne here shortly, and that'll precede, of course, rocket getting airborne itself. We talked about the personnel on both aircraft. We do have a quick question. Is Talon ever going to be crewed, or is Talon an uncrewed vehicle?
Yeah, it's uncrewed, so it's a manned, fully autonomous vehicle. So it'll be controlled by flight computers and all of the the avionics that we've kind of been talking about a little bit today.
Right, gotcha. Thanks. Brian's asking which side of rock. I think we get this question every time, but it's important because you can't actually tell from just looking at the airplane what side of rock are the people actually on, because looks like there's 2 cockpits.
Yeah, that's a good question. All the flight crew is on the right side, so the left side is mostly empty, but there is a lot of airborne support equipment, electronics, a lot of wiring, some telemetry stuff, data acquisition. A lot of the electronics and power equipment's over there, but there are no seats over there. So all the flight crews on the right side.
Yeah,
So it's
James,
camera left, but it's actually the right side of the aircraft. So right now it would be the left cockpit from this angle.
Right. Yeah, that's exactly right.
Yeah, actually, okay. Who knows? Who can tell us? What is stage right and stage left? Like, is that from audience standpoint or when you're on the stage?
That's from being on the stage.
That's okay. Well, then it's stage right for rock.
Right.
Like if you're on rock, it's not on right.
Right. Exactly.
Yeah. So James, why don't we just like put all that junk in the left-hand cabin in the right-hand cabin?
Okay. Well, I did talk about how most of rock is empty. That is not the case for the cabin. So because it is more of a controlled environment, it's pressurized. The temperature isn't quite as variable as the rest of rock. There was a lot of equipment in that right-hand cabin already. So if you look in the left cabin, there's some electronics in there, but if you look in the right cabin, there's way more electronics in there. A lot of avionics equipment in there.
Okay, so just like won't fit. It won't all fit in the right-hand cabin.
It will not fit. And there's probably other reasons too, like structural, limitations.
Weight,
maybe
yeah.
I don't really know, but I think it physically won't fit.
Yeah, definitely that. But also, were there any there's some zonal separation, like thoughts and redundancy thoughts. Like if you don't want you have like 2 ASCTUs, one can control everything, but you want them kind of separated in case one gets spotted, or if I don't know if there's some sort of like failure that is like locationally based, so your other one won't go down too. So there's some redundancy things, but I don't know if there are for the things in the 2 cabins. There are in other places on rock.
There are, yeah. Whenever we architected the data system, we put some of the hardware in different locations, right?
Uh-huh.
We have some stuff in the left fuselage, right?
Uh-huh.
And there's some stuff in the right fuselage that does the same thing, but like you said, it's spatially
Yeah.
separated.
And why does it even want to be in the cabin? Because like when I was first like working the environmental control system, like why do we bother pressurizing the left-hand cabin, and like how safety critical is it?
Chase is
Yeah.
about to take off.
Yep. Okay, cool.
Just heard him talking to Tower. They are about a minute out. Well, under a minute now, but yeah.
Good deal. Thanks, Jack.
Yeah, we're looking out for it. That'll be our next big milestone before rockets are born.
You can just barely see it sort of through the ground layer haze
Yep,
and
there you
dust
go.
there. There it is.
Yeah,
about
taking
on
the
the
runway now.
This is always a great scale thing because you see the jet, the small normal jet that's rolling out in front of Rock, and then Rock in the background, like well behind the jet that's about to take off. You just look at the size difference between those two aircraft, y'all.
Yeah, and Chase is even in front, like perspective wise, so
Yep.
Chase looks bigger than it is compared to Rock right now.
Oh, I hear it.
I hear it.
I think it's getting bigger.
I
There
think
it
it's
is.
coming right for us.
It's coming right at us. Nice.
There you go. Wheels up on the chase plane.
Nice. Oh, look, it's perfectly centered between the rock tails. That was so cool.
Yeah. Looked like it was balancing on the tails. That was a good shot.
Yeah, that was really neat.
So chat's got a couple recommendations, by the way, for nicknames for the chase planes. Someone said Pebble, to go with Rock, obviously. Also, I saw someone say Roll, so Rock and Roll. So feel free to take those, free of charge. No worries if you want to pick
Thank you.
We're gonna
Thank
write
you.
those down.
So generous. I'm taking.
Yeah, I can't speak for Stratolaunch, but those are both amazing.
Oh man.
There's Chase. I have a friend who when he flies his minivan of the skies, it's Cherokee 6. It is really like a Honda Odyssey that flies. Whenever he takes off, he must play either the Indiana Jones theme song or A Whole New World in what's it called, Aladdin.
Oh,
Yes,
A
one of
Whole New
those two
World?
are his like takeoff roll. Yeah, that's his takeoff roll jam. I wonder what Pebble or Roll. I wonder what our Chase probably doesn't play music.
Yeah.
We're
Oh, no.
professionals.
Yeah. What movie was that? Was it Iron Eagle, where the kid fighter pilot would like listen to rock and roll music to get in the zone? That's what I imagine those guys do, but they probably don't.
I'm not your one for pop culture references. I don't know what irony. I'll write it on my homework. Okay, so
All right, I'm gonna keep reading some questions. I'll do one quick question while the chase plane circles around before Rock takes off. Just a quick question: does Talon have any sort of functional propulsion or engine of any kind on board, or a mass simulator in place of a propulsion system?
yeah, it has a real engine. It has a real I don't think it will be the flight engine for TA1, but I may be corrected there. But it is not a mass simulator. Even it's actually the real thing in there. But
Gotcha. It's obviously not functional today.
Yeah.
Right.
Mm-hmm.
Nice. I was kind of expecting you to say no. It's just the aerodynamic shape of Talon because that's the point of this particular vehicle. But you've got the weight of an actual engine on there, so that's
we do.
awesome.
So parking brake is off on Rock.
All right.
Yeah.
That is a good step towards, moving, because I think having that on might be problematic. Up, and here come the engines.
Yeah, I thought I just heard something spool up there.
And we're rolling. All right, Rock's aircraft is rolling on runway 30 at Mojave. You just hear the engine spooling up. Here we go. And wheels up. We told you we had a cool thing planned. What a shot.
We don't get a lot of drone shots on our feeds, but anytime we get a chance to spool one in, that was cool.
Heck it out.
Yeah, that's awesome. Never gets old, especially one of the TA zeros on there. It's even cooler.
It
Yes.
looks so cool with Talon under wing.
Oh man, look at that. Talon is going for the ride of his life. This is the fastest it's ever gone.
That's true.
And highest.
Yeah. It's awesome.
Uh,
Yeah, congrats to the team too. You know, both teams, Rock team, Talon team, have been working a long time to get to this point. So
Yeah. Yes.
this is a huge milestone.
Yes. Definitely. All
It's been years. It's been years and years and years and years, even just since the first flight. And now we have a flight of rock with something under the wing. And just
Yes.
to go back to what you were just saying, Grace, a few seconds ago, I had no idea that was a real engine on Talon. I mean, obviously no engine activity on it today, but the fact that it's such a complete vehicle, even though it's not a flight article, you know, it's a carry article or whatever you want to call it. That's super cool. And yeah, a big deal, big day today. So cool
Yeah.
to see that vehicle come down the runway like that with the little friend under the wing finally.
Yes, man. So many years of work cumulative to get here. Even like people who have gone and come and gone from working on this airplane. Like if they're watching, they're seeing some rock carry something today, which is like the very first time. The pylon didn't count. The pylon was something to carry a thing. So man, this is so exciting. It warms my heart.
Now I'm going to ask some questions about what we're seeing here. So we're seeing the landing gear are still down on rock. Is that going to be raised later in this flight, or does today's test flight require that the gear stay down?
Yeah, we're gonna raise the gear. So right now we're climbing to 15,000 feet. During the climb, we do some release system checks, and we're climbing out at 155 knots indicated. And then once we get to 15,000 feet, we'll raise the gear.
Gotcha.
Yeah. And then after that, we'll do like some pitch doublet stuff that we've seen before.
Okay.
Yeah,
that-
sorry, we're excited by takeoff. So
No, absolutely.
wanna go
I don't
back.
blame you.
go back to talk about the engine. Like
Yeah.
why did we?
Yeah.
Yeah,
put real
so
wing there?
shout out to our engine vendor, Ursa Major out of Colorado. So we're actually flying one of their real engines today because they're collecting data at altitude today from that engine, collecting igniter bottle data and other variety of data, thermal data, vibration data, things like that. Very similar to what we're collecting on the rest of TA0. So that's why we have that real engine in there.
Gotcha. And that is, I mean, we got another question just basically asking if we can talk about Talon's propulsion system overall. It's a rocket propulsion system, right?
Yeah, it is. So it's a liquid propulsion system, liquid oxygen and Jet A. So liquid oxygen is the oxidizer, Jet A is the fuel, and it's a pressurized system. Has a different pressure and tank in the vehicle. So, like I said, the engine is from Ursa Major. And actually, if you get a chance to see the engine, you could probably go to their website or our website and check out, pictures of the engine maybe. And it's surprisingly small, but produces, plenty of thrust and impulse to, move the Talon vehicle along.
Yeah, it's a 5,000. It's like 5,000 pound class thrust
Right,
engine.
yeah.
That was like that was half the common soon. Oh, that was a bird. We were recently at the Edwards Air Force Base Air Show. Did any of you guys go? or see
I
anything about
heard
it?
about it way too late to even think about it, but if they do it again, I want to be there because it looked amazing.
Yeah, I had never. I heard that it was the first time in like 14 years or something that it was at Edwards. But yeah, we went. Stratolaunch had a booth, and we brought our Talon-A mock-up, so none of the real ones, but a mock-up. But then we actually brought a real engine too, and put it in like a little display. And half the comments were like, because they were both like full scale. Then there was the Talon mock-up and the engine, and people would look back and forth, be like, "That engine looks like." That looks really small.
Yeah.
That can power. That's the only one. How many are there on Talon? That's the only one. And I was like, "Yep, I'm not a propulsion person." Like, but apparently the engineers tell me.
Yeah, it's an efficient engine.
Yeah, I wasn't
Alright.
able to be at the air show, which pains me deeply. But I saw your guys' booth, and it looked like a really cool setup.
Yeah, it
Yeah.
was. I mean, we were in the same hangar as the B-52, so in my mind, it was a little overshadowed by this like huge airplane. It was so cool being in the same building.
That is awesome. So you mentioned that Jet A is the fuel for the liquid rocket engine that will eventually power Talon. And Jet A, for those who have been following our channel before, we usually talk about RP1 as a rocket grade form of kerosene. Jet A is basically just slightly less refined kerosene. Like it's still kerosene. It's just a different grade that is normally used on jet engines. But you can make a rocket engine use that fuel as well. And if you don't need RP1 grade, you can use Jet A grade, and I think I've heard of other rocket engines even using Jet A. And I'm assuming, I mean, Rock uses Jet A as its jet fuel, so that's got to be some easier logistics there, right?
Yeah, definitely having that kind of commonality between things always makes it a little easier.
Hmm. Oh, we can do some fun like numbers comparison. I haven't really thought about it this way. How much Jet A Rock has versus Talon. Oh, okay. I'm hearing from Mason right now that we have flaps down. I can't quite tell in this frame.
Well, keep an eye out. According to flight radar, we're up to 15,000 feet, so should expect to see gear retract here soon as well. There's a map. You can see it flying northeast from Mojave. That's the normal testing pattern that we've seen on previous flights. Is that just like a normal testing corridor that Stratolaunches normally uses, that area to the northeast of the airfield?
Yeah, that's a pretty normal testing corridor for Stratolaunch and a lot of scaled composites airplanes.
Right, gotcha.
So
Rock
right
is
now
up.
we're going through stuff like trim shots and pitch captures. Not sure if the flaps are still down.
Yeah, it's getting further and further away, harder to see the details like the flaps and stuff.
But you can see the chase plane off to just to the right of Rock, too. You can see both aircraft in frame, which is kind of cool. You could also see that Rock is currently the #1 tracked airplane on flight radar. The most people using flight radar are looking at Rock, which is kind of neat.
Nice.
But yeah, I'm going to keep going into some questions. Yeah, so some people asking about the landing gear, basically why you wait until 15,000 to retract it, because doesn't that landing gear add some drag to the airframe?
Yeah, it does. That's a great question. I think part of it is that retracting the landing gear uses up a lot of hydraulics. So like
Okay.
hydraulic demand. I think we have like a diagram. It's a hydraulic power triangle. You can pick 2 out of the 3.
Yeah, okay.
That kind of thing. So, most airplanes like retract their gear after they establish a positive rate of climb to
Mhm.
get rid of that drag. But Rock's got a lot of gear. It takes a lot of hydraulics. I think maybe we could, but also the drag doesn't hurt. We're not really hurting for fuel, so we're not going for efficiency.
Sure, okay.
Don't mind the drag. So there's just, I think, more reasons to wait to retract them than reasons to like retract them immediately.
Gotcha, okay. But yeah, we'll be able to make it out. You can still see the gear kind of shadowing underneath the fuselages there. But yeah, so basically waiting till you're stable at an altitude and you're not putting other control inputs into the system before you use the hydraulics to get those gear up.
Yeah. So you have a limited amount of like hydraulic fluid and hydraulic power, and the three main users are gear, flight controls, and flaps. Right,
Mhm.
James? Are there other ones? I think those are the main ones.
Oh, I'm sorry. I missed
The
that.
hydraulic users on rock, the gear, flight controls, and flaps, I think are the main ones.
Yeah, I think so. I
Yeah.
can't think of anything else that uses.
Yeah, so I think that's in the triangle. You could use like varying levels of all of them at the same time, but just to make it simple, just choose two corners of that triangle. So only do flaps and flight controls at the same time, or
Sure.
flaps and gear at the same time, or gear and flight controls. Like operate them. Like obviously, if the gear is down, it's not using that part of the triangle.
Right, yeah, you can't move the gear. The gear can be still in one position or the other.
Yeah.
All right. All right, chat's still thinking of different names for the chase plane, by the way. I'll let you know if I see any new ones come in. But what other questions we got here? Yeah, so people asking, will Talon be released today? Talon it's a captive carry test, which as the name implies, Talon 0 or TA0 specifically will remain attached to underneath the wing of Rock for now, because you're mostly trying to verify that the models that you can make before you do any flying are accurate. So you have, I mean, what kind of sensors are on board Talon, and even are there any on Rock also to verify how the combined airframe kind of behaves during flight?
Yeah, there are. There are a bunch of sensors on there. So one type of sensor we use is a strain gauge.
Yep.
So you think you step on your bathroom scale. Your bathroom scale probably has a strain gauge in it. Strain gauges are meant to measure load or force or weight. You can also, so when you think about Talon and the airflow hitting Talon and pressing up on Talon from the bottom, just like it does on the Rock wings, it's pushing up into the pylon as well, and putting a force onto the pylon. So that's one of the things we're measuring today, and we're measuring that using strain gauges. Something else we measure is in-flight flutter, and what I mean, flutter is the quick movement or periodic movement of typically rocket fins or wings or something like that. So essentially, we want to measure, how much Talon is vibrating, and then, how much is there any kind of weird interaction between Talon and the pylon?
Yeah, it's
It
an
may be
air
concerning.
structural
Yeah.
phenomenon. It's like when you have a leaf or a piece of paper or something, and you like kind of like hold it out flat and then blow on it.
Yeah.
Like, and then depending on the speed you blow, like the paper flutters differently.
Right. Yeah. Exactly. Like, I guess you could imagine, right? Driving down the road, if you hang a piece of paper out the window, it just flops back and forth. Of course, Talon's not going to flop back and forth like that on a large scale, but when you have these, really nice sensors in there that can measure the small, amplitude flopping, quote unquote flopping, that's what we're looking for.
Yeah, and it flops differently depending on how fast you're driving and like
Right,
how thick your paper is, which is, well, thickness equals like stiffness, but stiffness is what we think about for flutter.
Yeah.
Yeah, and we've got a bunch of cameras on Rock too, so just we're getting like also visual data of Talon.
Yeah.
Too.
Yeah.
Gotcha. Getting some questions in chat about basically where this flight sits in the test program. So can we first start by just recapping the flights that have led up to today's flight? Because this is the first one with Talon under wing, but there were several flights with either the pylon that Talon is attached to, or without that, just the Rock aircraft doing its own test flights. So want to just do a quick run through and recap of the previous flights leading up to today?
Yeah, sure. So we've had 7 Rock flights until today. This is the 8th flight. So in flight test, of course, you do a build-up approach. The first flight was on April 13th, 2019. The 7th flight, the flight just before this one, was on June 9th, 2022. So today, we've expanded the envelope enough on Rock, and Talon, was ready to fly. So today's flight is the first captive carry of our first Talon vehicle, TA0. After this, we'll fly this vehicle a couple more times in captive carry and continue to expand the envelope. And then by the end of the year, we will release this vehicle and perform the actual mission that TA0 was intended for. So that'll be by the end of this year. And then it's, full speed ahead working towards TA1 hypersonic flight in the beginning of next year.
Yeah, and like James said, the build-up approach means that we don't like add too many things on one flight or change too many things like each flight. Like the very first flight we fly the pylon, we're not also gonna like fly Talon for the very first time, So first flight was just rock. Third flight was when we retracted one of the gear. Fifth flight was when we first flew the pylon, and now eighth flight is when we're first flying Talon, just on a large scale, like overview style. Is that what you were looking for?
Oh yeah, perfect. Thank you. And James kind of stole the beginning of my next question, which was going to be basically what comes next. And so a couple more
Mhm.
captive carry flights, and then you said that the goal is to get to the separation test for TA0 by the end of the year. Is that right?
Yeah, that's right. So we're targeting tracking towards December this year for that TA0 separation demonstration.
Gotcha. And of course, that'll in part depend on how all the captive carries before then go and things like that, I'm sure.
That's right. Yeah, I mean, talking about all the data that we collect, there is a lot of data that we have to go through after every single flight. So the job's not over when the
Mhm.
plane lands, right? A
Mhm.
lot of those guys that are in the control room, they're responsible for those systems. So after the flight, they go home, get something to eat, go to sleep, and get up the next day and start looking at all the data. And we do that up until the next flight usually, and try to minimize the number of changes we do to the vehicle between flights, if possible.
Yeah.
All right, gotcha. Really quick, I want to introduce because we're going to keep bringing some updates, of course, throughout today's test flight. And so we have a couple Stratolaunch people. Again, huge shout out to Grace and James for hopping on for Stratolaunch personnel. Also got the NASA spaceflight team hosting and things. And I do want to just quickly introduce another NSF voice who will be helping me out, picking out questions and things like that. I believe we have Chris Gebhardt joining the show. Chris, we got you on comms. Talking while muted.
Talking while
There we
muted.
go.
Yes. Yes, I was going to say what I was saying was good morning, Thomas, and good morning, Strato family. It was an awesome takeoff of rock this morning, was it not?
It really was. But Chris, my immediate question for you is, as a fan of the space shuttle, how do you feel about a new? It's not quite a space plane, but it's a hypersonic vehicle, space plane-esque. How do you feel about this?
Oh, well, anytime we can have another space plane, I will always welcome them into the fold. Yes.
It's like a rocket plane. That you can call it a rocket plane, right?
I mean, it has rock in the
Right?
title.
Yeah, that's actually how I describe it to people, because
Wait. Did somebody try to say rocket plane like ROC? It
Rock
Probably.
it plane, yes.
no.
these puns are out of control.
More demerits. Yeah, James, would you call it a rocket plane?
That's how I describe it, because I'm actually a rocket guy myself, but I know I work with a whole bunch of plane people. So yeah, I mean, and it looks like a rocket plane, right? It flies like a plane, but a lot faster than a lot of planes. And it has a rocket engine and a propulsion system like a rocket would. So a lot of times I refer to it as a rocket plane. If you took the wings off and put fins on the back, right, that made it look more like a rocket, then I might refer to it as just a rocket. I think it's the
But it has
wings that make
wings,
it,
so
and landing gear too, right? Like whenever we get to
rocket's not landing here.
Yeah,
Well, okay, legs.
yeah, that's true.
Right, that was actually a great question. And before I dive into that, just a quick acknowledgement that looks like Ruck has made the U-turn heading back towards Mojave now. And so that'll be hopefully it'll be getting closer to that camera view. We'll get some better shots as it gets closer. But as Ruck makes its way back down the other way of the test corridor, basically, we were adding questions. Basically, once Talon is on either on operational flights or even early test flights where it's going to land, how does it land? I think one person in the chat was like, "What are you going to use? A catcher's mitt or something?" Like how does Talon get recovered?
Yeah, it does have landing gear. It has two main gear and one nose gear. So the intent is for it to actually come back and land on a runway, just like other airplanes would. But this one is kind of different because it's fully autonomous and it will do it by itself, right? So we can. That's the goal, is to have a vehicle hypersonic test bed that is fully reusable, so we can go fly it, drop it off rock, flies hypersonic, and then comes back and lands, and then we can go do it again.
All right, gotcha. Thanks.
So
All
right
right.
now we are still at 15,000 feet. We're doing simulated approaches. So that's like pretending that you're nearing the runway. So you call a certain altitude the runway and you do a simulated approach. And we do that to evaluate handling qualities, because if you're a pilot, you know the hardest parts of flying, well, hardest parts of GA flying, I know, are when you're near the ground. Like when you're in the air,
Right.
nothing,
Yeah.
like that's not where things usually happen. It's near the ground. So landing and takeoffs are the hard things. So the pilots want to do some simulated approaches to make sure the handling qualities are as they expect, like they kind of match what they've practiced in the flight simulator that we have in the hangar, well before we come down to try to do the real thing. And the only difference, since we're like, well, why haven't we landed before? Yes,
Yeah.
we have, but not with Talon. And we're
Right.
not
Sure.
expecting a huge difference because, just look at it. It's a little fly on the back of an airplane, but you still want to test it out.
I absolutely love that saying, Grace. I'm gonna have to start using that, like a fly on the back of an airplane.
Okay, I
love
kind of
it.
regret that. I don't mean to minimize the effort for Talon-A. It is huge engineering and build effort.
Oh,
Some people who work on it would be like, "You calling my vehicle a fly?"
Oh, that's funny, because I more meant it like this was more like my thoughts back to the shuttle days of when they would put the shuttle on the larger plane
Oh
to ferry
yeah.
it back across the country, and like like
Mhm.
people would always call it, oh, it's like little plane on a big plane. I'm like, you calling the shuttle little? Like,
Yeah,
And of
it's
course,
all
everyone watching, you can now check off the shuttle box on your
Yeah.
NSF Big Note card. We did it
you go.
on a airplane stream, so you're welcome.
Going back to what we were just talking about really quick with the gear,
Mhm.
is it all actual wheels, or are any of them skids? I know like the X-15 had skids. I know Virgin Galactic's nose gear on their spacecraft is a skid. Is it all wheels, or do you have to go with skids for like heating reasons or anything, or how's that work?
Yeah, so in Talon, it's all wheels. I won't claim to know a whole lot about landing gear, but for Talon-A, it is all wheels.
Yeah, and on rock, because that's what I know. Obviously, we've talked about this. Those are all wheels, and there are, last I checked, 28 wheels, since there's 6 main gear, 3 on each side, and there's 4 wheels each gear, so that's 24. And then 2 nose gear and 2 wheels per nose gear. That's plus 4. 24 plus 4. Yeah. Yes. 28. I did not embarrass myself with simple math. How about Talon?
What?
How many wheels does Talon have?
Oh, yeah. So it's only 3 wheels, I believe. Each main gear has a single wheel. So 2 wheels there, and then the nose gear has a wheel. And they're surprisingly small. I mean, I actually saw them a few months ago in our shipping and receiving, and the nose gear is maybe
You want to say like go-kart wheel or
like maybe a go-kart, like 8 inches
dolly
diameter,
wheel?
9 inches diameter.
Oh, only. Okay.
But they're really nice wheels, right? They're like Goodyear aerospace grade tires, I guess I should say, wheels. But yeah, probably a little more expensive than the tires we put on our cars and go-karts.
Yeah. And I mean, like, I guess what is that trade? Maybe neither of us should talk about gear because it's out of both of our depths, but
Like a skid versus.
yeah, because like Spaceship One, yeah, the nose, skid, and the mains.
Well, I would think
It saves weight, obviously.
Yeah, saves weight. Maybe a skid is a little simpler to design.
But obviously, a skid isn't steerable. Like, if you want a
Right.
steerable like nose wheel or any steerable gear, you can't do that with a skid. Mm.
Yeah, probably easier to maintain. I mean, maybe with a skid, you have, your
You have to
skid-
replace it.
You
yeah.
have to replace the part, the sacrificial skid part. But, with
Right.
gear, I think there's probably a lot to maintain with all the hydraulics and stuff like that. Maybe.
Very interesting. Yeah, we've definitely seen that on a couple different kind of rocket planes or space planes, whatever vehicles you're specifically talking about, where it's not always a wheel, but there you go. All right, I'm going to keep some questions coming here. Thomas Banks is asking, how long will Talon be flying once it separates from Rock? I'm assuming this is in relation to actual test flights. Like, basically, how long would you expect Talon to be under powered flight and gliding during a hypersonic test flight?
Yeah, so not today, but later
Right, not
it's
today.
between the entire time between after it drops from and when it lands it's 10 to 20 minutes.
All right. Do you know how much of that is under like powered thrust and how much of that is gliding?
Yeah, we don't know.
Don't know. All right.
Yeah,
But so as I mean,
we'll have to get somebody else to replace me next
okay.
time.
Well, of course, we'll have that even more relevant for those actual powered test flights. So,
Yeah, our gear is up now. Oh yeah, it's just hard to tell. The gear is up now.
all right.
The
It
gear
looks
is
like maybe
awesome.
like some of them are up. I think I still see some down
Yeah,
on
it
that
kind of
camera.
looks like the left. Wait, which way are we
With
looking at?
left and right main gear still down.
Oh, sorry, no, the gear are not up. Next up is gear up.
Yeah,
That's our
Gotcha.
next
Okay.
card.
Ah,
Yeah,
okay.
sorry.
Yeah, right now we can
Misreading.
actually see Rock kind of pitching up and down a little bit. Those are those pitch captures you talked about, right?
Yeah, okay, I'm hearing gear is coming up now. Let's watch it.
All right,
Oh,
keep
1 minute.
keep a close look. Of course, Rock is about halfway down the corridor from this camera view, so we're at full zoom here as it comes back towards Mojave. But we should hopefully get a glimpse of landing gear retract. And we mentioned earlier the reason that the gear haven't been retracted until about now is basically so that you can save some of the hydraulic power for flight controls and flaps when you're taking off and things like that. And now that they're basically at a more stable altitude, you can send some hydraulic power to get the gear up because there's a lot of landing gear on this aircraft.
Hey, sounds like gear is going up right now.
I don't quite see it yet.
Trying
Looking,
to
yeah,
make it out.
looking.
There's like a small black
Mhm.
dot in the.
Well, the plane will get closer to the cameras here, and then we'll get more detail on whether or not the
Yeah,
gear are
yeah.
up or down. Luckily, it's coming our way.
Cool.
It's coming right for us. All right, that's the second time we've already said that this stream. We need to like.
Oh, yeah,
Uh,
got an update. Okay, so I was saying earlier that the flaps use actuators from 747, but I didn't know from where on the 747.
mhm.
They were gear door actuators on 747 that we use for our
Ah,
flaps.
Okay, I think I saw
Oh,
the black dots disappear,
like-
so it looks
Right,
like
yeah.
gear's up.
Okay.
yeah.
It's like using like if you're an amputee, like you need a new arm, but somebody donates a leg, they like attach the legs to your arm. Okay, well, okay.
A little bit of Frankenstein.
An actuator is an actuator, I suppose.
Yeah.
Right. If it works, doesn't matter what the original use
Yeah.
was for, right?
Yeah. I guess it's more like using a tendon from your leg and putting it in
Yeah.
your arm.
Yeah, that makes sense.
That's
But yeah, you can definitely see the landing gear have now been retracted, so Rock flying in a slightly more aerodynamic configuration now. A little less drag as the gear has been retracted. And so you basically expect those gear to remain retracted until it starts coming in for landing attempts, right?
Oh, flaps. Oh, there's no way we can see that. Flaps are coming up now, I hear.
All right. Rock is getting, you can definitely see it on this camera view, it's getting closer and closer to Mojave. You can make out more of the aircraft.
Make out and Talon be
Yes.
between the two fuselages. Yeah, it's starting to come back into resolution there. Nice.
You can see on the left-hand
Yeah.
side of the screen the flight radar data, about 15,000 feet of altitude and about 200 knots ground speed right now. Looking pretty cool. I'll bring some questions back in here. We talked about Talon flying. Oh yeah, another question from John asking: Has Stratolaunch have any plans for a variant of Talon that could be human rated? So actually carrying personnel on a hypersonic vehicle.
I'm actually not sure offhand. I know that we do plan to build bigger vehicles.
Mhm.
If they're going to be autonomous or manned, I am not sure offhand, but they'll be bigger so people could fit in them. Not saying they will, but they'll
Yeah.
be big enough that they could, unlike Talon, which is, if you think about the nose of Talon, the size of it is maybe like 3.5, 4 feet wide. So
We're using our hands here.
Yo.
Nobody can see us. James is like about this big. I'm like, James, nobody can see.
so you can't, a person couldn't fit in Talon.
Yeah, the company plan is we're focusing on Talon-A's right now, but then once we are successful hypersonically with Talon-A, we can build off of that technology and like all of our staff that we have here and pursue other projects.
Gotcha. Yeah.
Nice.
A relevant question here from Peter asking: Would Rock, so the carrier aircraft, ever be autonomous on its own, or is that one that's going to always have to be piloted?
That is a great question. So, the plan is to always have that one piloted. Being an avionics person myself, it would be really cool to automate it.
Mhm.
But no, we'll always have pilots in the Rock aircraft.
Gotcha. Again, everyone, please tag at NASA Spaceflight in chat if you have questions, but we're going to keep those in basically throughout the test flight here, as well as just providing updates on the flight itself. Rock pretty much flying directly back towards Mojave at this point. There's a shot from Mojave itself. You can see it flying basically right over the airport. Gears retracted, Talon under wing, and test flight well underway at this point. Mentioned, of course, Rock being a piloted aircraft, but of course they're flying off to one side because the twin fuselage design. James is wondering if there's some sort of camera or something like in the center of the wing that helped the pilots maintain centerline during takeoff and landing, or basically have a point of view from the center of the aircraft rather than off to one side.
You know what's hilarious? Instead of trying to make the pilots figure out how to land Rock centerline on the centerline of the runway, there is a bonus stripe on 30 for the pilots to
Bonus.
land on.
So hold
Okay,
on,
but
you
they're
painted a line on the runway that's off center because that's what you line up with.
you know what? I'm not
Oh.
actually sure if it was for Rock or if there are two lines that are like off center for other
Oh, okay.
reasons, like for the airport. I don't really know if it was put there for us. It might have been.
I think we
But-
did. I was talking to Anna, the chase pilot, and I think she told me we put it there
Yeah.
for Rock.
Yeah.
And that makes sense, right? Because like pilots, like visually, you're trying to line up with that center line strip on the runway as you're coming back. So
Yeah.
it would make a lot of sense to give the pilots, if you're not targeting center line, okay, well, here's the one off center line that you need to target, and now you know, like from your situational awareness, not just a camera, that you're at the right location. So it makes a lot of sense
Yeah.
for like visual flight as well.
Yeah, because you're 50 feet off of center line. The fuselages are 100 feet apart. So
Yeah.
it'd be a lot of like, mental and geometric math for a pilot to be like, okay, where do I
Right.
think my wing center line is? But there are other things too. So our chase does follow Rock down and flies kind of behind, I don't know, behind to center or behind to the right. But they actually do some calls too. Mostly they're there for like, height calls as normal chase. But there is a stripe painted on the bottom of the Rock wing. There's 3 stripes, right? 3 or 4. There is one at butt line 0, and butt line is just what we call like the Y station, which is right and left. So there's one at butt line 0, there's one at butt line like 10 and one at 20 or something, and one at 25 maybe. So there's a few markers to like visualize, and that's for chase. And then ground crew also, when we were doing taxi tests, ground crew would be like behind Rock. And so they could help call Rock because we'd intentionally go do like centerline captures. That's a normal thing to do in taxi tests. So you'd kind of like go off to the right 20 feet, 30 feet, and then capture that center line again. And that's to practice your gains because your inputs on Rock have a little bit of lag to when when the aircraft actually reacts. So there's every airplane has this, and that's why it's different.
Right.
Like it's kind of different, and Rock is kind of slow. It's big. A lot of big airplanes are like that. So we have a simulator to practice that, but then we also practice it in taxi. And so for the pilots to know whether they have captured centerline or not, or if they're actually 20 feet off centerline, which is what they're trying to capture too, Chase on the ground will call it out for them. They're like, okay, you're 5 feet to the left, 10 feet to the left, 20 feet to the left. And they use that stripe on the bottom of Rock Wing to compare to the center line of the runway.
You know what just struck me here, sort of looking at the visual with this is, when Rock is on the runway, right, you can really tell how different its fuselage design and mold line is from like the other aircraft that you're seeing. But man, when it's in the air, it really has that bird-like feeling, right, of mechanical flight copying natural flight in terms of like the overall designs of the fuselage. It's really cool to watch the aerodynamics of this incredible aircraft.
Yeah, it looks so much less dopey with the gear up. Like as soon as the gear came up, I was like, wow, this is a
It's
Looks like a
aerodynamic.
real plane.
yeah.
It looks
like,
like a
wow,
real
this-
plane.
It looks so cool, but maybe I was telling my colleagues, I was like, okay, it's probably Stockholm syndrome. Like, it's probably Stockholm syndrome that we're like, oh man, this actually looks like a really beautiful airplane now.
Listen,
yeah,
I
it
think
looks
it does look
aerodynamic.
beautiful.
It kind of looks like a graceful goose-like form. Right?
It
If I were
does.
to pick a bird,
You need to paint like duck bills on the front.
There we go. There we go. Right.
I'm in
just
full
Yeah.
support of this.
yes, as long as it can still fit among all of the other advertisements we have, on like Brondo on the side. It's what plants crave.
What plants
Yeah,
crave?
get
Nice.
some extra revenue.
Somebody has to finish the saying if you say Brondo. So thanks.
Oh yeah, sorry, Brondo.
It's what plants crave.
Yeah.
It's
This
what
stream
plants
not
crave.
sponsored by anyway.
Yeah.
A fictional drink company? I don't know. Like
Yeah, I was hoping we wouldn't get flack for we won't get any sort of legal ramifications, right? Because that's not a real company, right, James?
it's not a real company. No,
Well,
it's not.
Yeah,
It's a movie reference at best. Like
hopefully.
What movie is that? So bad. I made the Iron Eagle reference, and now I don't get this one.
How do you know Iron Eagle and not Idiocracy?
they're like right next to each other in the catalog. They both start with I.
Yeah, that's a good point. Okay, I'm gonna write it down. I'll make an assignment.
So we're gonna add to the NSF. We need to make an actual NSF bingo card because I feel like someone makes a movie reference that someone else doesn't get is like way too common on our streams at this point.
That
Yeah.
that is true. Yes.
Yeah, we could like tally who it is who isn't getting them, and whoever gets the most points of those goes into like the Hall of Shame for that time. Usually it'll probably be me. So like.
I don't know. A
awarding
bunch of us at
awards.
NSF could give everyone a run for their money.
Oh
for the
yeah.
things we haven't seen. Yes.
Okay, good.
But
Okay, so-
I actually noticed something about the aircraft that's kind of interesting to me. So I noticed only one of the fuselages has that like air probe that sticks out in front of it. Curious question: why only one? And is it on the fuselage where the pilots are?
Yeah, so that's the air data boom, we call it, or the test boom. So that gives the pilots indication of how fast the airplane is going. You can also tell them, if it's pitching up, pitching left, or not pitching, but yawing left and right. And there actually are two more of those booms, air data booms, one on TA0 and one on the pylon as well, so that we can collect that same kind of data from those locations too. You can also kind of see, interactions between them.
And
But
is
those
that
are-
and is that to understand like the air conditions, the air currents where Talon is versus like the airflow that the plane is flying into?
Right, yeah, exactly. It gives you an idea of what's happening, in the airflow out in front of the vehicle. So that's a lot of the data, that our flight sciences group is going to be collecting today and looking at that.
Yeah, the And why do we have 3? It's because, well, rock is so big, like
Right.
the weather is a
Right.
I'm kidding, but it's just like, you know,
It's
if
a
you're
different-
building,
It's a
if we're
different
s-
zip code.
yeah, if your building is so big, you need like different weather stations for different parts of it. But
yeah,
no,
that's
it's
kind, that's
because
kind of. Go ahead, Grace. Sorry. Yeah.
yeah. No, I think you were going there. So yeah, Talon is, I mean, it's not like geographically that far from where the cockpit is. It's like, oh, what, 50 feet like left and then like 50 feet front. So like, I don't know, 70 feet. But the air effects like of rock itself could be non-zero at Talon. And so we've like done CFD to try to substantiate like what is the effect of rock on the air around Talon versus when Talon's in free flight. And so the
Ah.
airflow around Talon is different than like in front of the nose of rock. So that's why we have another air data boom on the pylon.
And I imagine when you go to actually release Talon on a subsequent flight, right? That's a huge part of understanding the like aerodynamic transient
Mhm.
regime as it drops below the slipstream of rock, right?
Look
Yeah.
at this.
And it's
Yeah.
swooping up and down, right?
Yeah, sorry to interrupt. Is it it looks like it's climbing.
Yeah. So we were
And
doing
dipping.
pitch. Yeah, we were doing pitch attitude captures, and now we're doing
Wow.
NZ captures.
Oh,
So NZ is like number of G's up and down, and Y is like left and right G's, and then NX is forward and aft G's. So like if you were like on a roller coaster, like I think the Hulk and Universal in Orlando, they just accelerate you straight forward. So that is like NX into your seat, like you're being pushed back. NZ is when you feel a positive NZ is we define it as your butt into the seat, and negative is like butt out of the seat. So when like you're getting like pushed out of your seat versus into the seat. So they like pitch the airplane up to try to capture a certain NZ, like 1 point something. And you're usually at 1. So if you're straight and level flying, you're at like 1G. We're just sitting in our chairs here in this room, 1G, hopefully.
Yeah.
Ideally.
Ideally, you're at 1G, yes. And are these like what exactly are these pitch profiles for? Are these to like gain information in a captive situation for when you are getting ready to release Talon?
Yeah, I think there are partially there's multiple reasons. I think for the pitch captures there is like handling quality still too. And then there's also loads information for Talon later, like, hey, when
Ah.
we thought we'd like do 1.6 Gs, and so the distribution of load between the 3 attach points we thought would be this, but it really turns out to be like this. It's a determinate attach, so really that shouldn't change very much, but I don't know, between adapter and mini wing, that's not determinate. So yeah, there's multiple reasons to do NZ pitch captures.
Gotcha.
Okay, now we're doing a 3-minute hold. 3-minute hold attitude.
All right, gotcha. So I want to circle back to this really quick because we were talking about basically what those maneuvers and things are all verifying. You did mention the term CFD, and for people who may not be familiar, that is computational fluid dynamics, right? You're talking about like it's basically simulations of the airflow that you can do before you actually go into flight.
Yeah, exactly. Yeah. So this entire thing is just trying to balance how much analysis you do versus test. That's like a thread that runs through all of like building anything or engineering. Like if I were gonna build a paper airplane, I could just like do 0 things, take a piece of paper, fold it up, and like throw it. You're like, okay, well, that's a thing. And then you tweak something, you do it again, see if it got better or worse, and you just keep doing that. And that's like one end of the spectrum, the 0 analysis end of the spectrum, and it's all test. And then the other end of the spectrum is like all analysis, 0 test. Although there's never 0 test. I think
Right.
of things more like satellites or like rovers or like things that go super far into space where you can test subsystems on
Yeah.
it, but you can't really test it in the real environment and like go change something because you're not going to go back up there and
Yeah.
service that thing, right?
Yeah.
So I feel like that's on the other end of the spectrum where like you got to do more analysis, right?
Right. It's also kind of part of that philosophy where to get to the 90% solution in analysis and design takes, a certain amount of time, right?
Uh-huh.
And then to do that last 10% to really perfect it and design the analysis takes like an order of magnitude more time.
Yeah.
And I think at some point it makes more sense to go actually test it, right? Because you're going to learn so much after a test.
Yeah. So that's where CFD is one of the tools that you use for analysis. And then you decide how much of that you want to do and where you stop and do test to validate the analysis. So different parts of Talon and different parts of Rock fall on different parts of the spectrum. It's not like, oh, we chose the leftmost point on that spectrum for everything on the airplane. It's like some subsystems you think there's more risk if something goes wrong. So you like go more towards the right of the spectrum, or it's harder to mod. That's a thing too. Just like how the thing is built, it's hard to modify it afterwards. Or I don't know, maybe avionics, James, like if you like get the box and then you can iterate the code really easily. So you, although I don't know what that analysis is. But yeah, the analogy breaks down at some point in this conversation.
It does. I mean, it's a lot of times in software and avionics, you can test, in the middle of the quote unquote envelope, right? Because there kind of is an envelope for that stuff too. Try to hit some of the corner cases, but and even, we even talking about testing hardware, avionics hardware, we even do environmental testing, right? We do qualification testing. So today we're in a new environment, right? It's going to be colder at altitude. The vibration is going to be different. We even test to those kinds of environments while on the ground. So we'll put our avionics equipment, on a vibration table or put it in a thermal chamber and expose it to, those kinds of environments to make sure they're going to work when they're at altitude and in those, the real environment.
Yeah. So it's trying to trade the risk versus the risk you want to take going into flight test versus the effort that it'll take to test that portion of the thing on the ground. So for example, like your environmental chamber testing and shaker table testing, like that's kind of an established thing, not super hard to do. So you'll go do it. But if it's like there's like GVT and stuff, a ground vibrational test of an entire vehicle is like a bigger deal. So it's all those kind of trades. And speaking of the shaker table, I don't know if this is something that a lot of is it common in industry to build a whole shaker table and put like a person and their entire their control station on it? Because I know at Scale we did I know PC they like sat on this huge table that like could shake.
I think that's a great idea if you can accurately predict the environment. And you think that, like from the human factors perspective, is the pilot going to be able to flip the switches?
Yeah, Are you shaking so much your eyeballs like actually can't focus on the different buttons? Like, Scale did that.
Maybe you need to put the pilot seat on isolators to kind of dampen it out or something.
I'm sorry. Let's back up just for 1 second. Are we talking about putting literally like the pilot and their control input, like control systems on a shaker table? That is fantastic, and I love everything about that.
I'm not like, okay, so I've got a lot of experience at Stratolaunch, but like very narrow in that I haven't worked at a bunch of companies outside of Stratolaunch, so I have no context. Like, do other companies actually do that? I wasn't sure if that was like a normal thing or not. But yeah, at Scale, we put a person on the shaker table with their like controls to see if they could still do the things required, like during the vibrations for like Space 2, for example.
That's exactly what should be happening. Like, yes.
Yeah, I feel like
Train
I've
as you fly.
seen footage of like astronauts training for the Orion spacecraft on like, but there was vibration involved. I wonder if that was literally just a shaker table. That's fascinating. I've never heard of that being done before, but now that you mention it, I wouldn't be surprised if that happens elsewhere as well. Like, especially
Kinda makes
for
sense, right?
rockets.
Yeah, and I'm sure that people do it in a G environment, right? Like people go G train and stuff, but also
there's like the centrifuge training for sure.
But do they have their like control panel in front of them during the G training just to see if they can still like operate?
I think, or even if it's not like the real one, it's like, all right, we need you press this button, like just the basic function of being able to push buttons and like think during that, rather than even if it's not like the control panel they'll eventually use or whatever.
Yeah.
That's fascinating.
So cool. Yeah, that's a different aspect, like testing the pilots, like because there's G training, there's like the shaker table we have, there's altitude chambers you go into and stuff.
Right. Yeah. That's so cool. Another question that's kind of relevant to that, someone asking, because of the offset cockpit, like it's offset from centerline. So when you turn, the cockpit motion is different from if you were flying just a single fuselage airplane. Has there
Oh.
been any sort of training or testing or something along the lines to see if like is there any air sickness that could come from that? Like, could the crew be negatively affected by that? Is there a way to compensate for it? Is it just you got to get used to it?
Yeah, I mean, they're used to it now, but that's a great point. So when you roll in a normal airplane, you're like on center line, so your body rolls too. But in rock, when you roll to the right, for instance, like you're also going up and down. So
Yeah.
like you're feeling an NZ in your butt when you don't usually you feel NZ when you like pull up in pitch or push over. But in rock, when you roll, you feel NZ too. And when you yaw, you feel NX. Like into and out of the seat.
Right.
So yeah, I knew that, but I hadn't thought of it from the air sickness standpoint.
Yeah.
And I mean, that's got to be a
wondered.
human factors problem, right?
Yeah,
I guess they figured it out though.
yeah.
They seem to be handling it pretty well.
I don't know. They don't have like barf bag report at the like end of day report situation, so we don't know if anybody gets airsick. But I would
just like
imagine.
the fact that it's like I imagine some company, not you guys, just has like a checklist that goes, and how many barf bags were used? Like,
2.5.
yes. Ooh, and a half. Ooh, nice.
Someone's good.
Someone took an average number a little too literally.
Yeah, we don't have that as part of our debrief. Maybe we should suggest that, James, because I don't know. But
Listen, all the more
beforehand-
data is better.
That's interesting. Usually I'm a data glutton, so I love the data, but it isn't, that's definitely not true. Like at some point, some data is like stuff that, and we struggle with this when we're like, okay, how much instrumentation do we want to put on this thing versus how accurate is it going to be? Because one, you could get good data from it, but two, the other very high possibility is that you get like errors from it and you can't tell whether it's like, whether your thing is doing a bad thing or if the instrumentation is just bad. And so you spend so much time trying to like chase down whether your instrumentation is bad or whether something really happened when really it was just like your instrumentation making problems. So there is there's a reason not to just Uber instro up everything. Right, James? Are you on the like intro everything
No,
side? Or?
Being the guy that is responsible for the instrumentation and installing it, calibrating it, making sure it works, I am not on the end of let's instro everything.
Yeah. So you really got to think hard about like, okay, what data am I trying to get from this, and will I really get what I'm thinking?
Yeah, we consider every single sensor that we have, and we, the responsible engineer, right, the person responsible for that sensor, we ask that they make sure that they absolutely need it. So we go through every single sensor like that. So every single sensor on the vehicle has a purpose. Whether it's a thermocouple measuring temperature or an accelerometer, measuring flutter like we were talking about, or vibration.
Yeah. And there's a huge effort to try to classify them so that you, as the avionics person, know when stuff has to be fixed or not, because some signals are like safety of flight, some of them are mission critical, and some of them are only like, some of them are nice to have, We're going to talk about those classifications.
Yeah, sure. So Grace is right. For every sensor or every signal we have, there's what we call a signal criticality. So every signal is needed, or every sensor is needed at some point, but they have different purposes. So some might be, quote unquote, nice to have just for engineering data. Some may be mission critical, say. We have to have it to verify that we successfully completed the mission. For example, maybe a mission objective in the future would be, we want to make sure we create a certain amount of thrust. Well, we have to instrument that and make sure that, we can measure the thrust because that's our success criteria, right? So that'd be kind of like mission critical. And then we have signals that are, related to safety, where we can or can't execute a maneuver safely without that signal.
Yeah, so for example, the like engine thrust, well, I guess for Talon, like that wouldn't quite be safety critical, or at least not for rock. In that, like, if we lost that signal, we could still come back home and be like, fine.
Right, exactly.
But like, I don't know, maybe some of the engine instrumentation, engines on rock and stuff, like those would be safety critical.
Well, so flutter is a good example usually
Mhm,
because
mhm.
you do flutter test points to make sure you don't have a flutter problem. A flutter problem could be bad.
Mhm.
So if we lost our flutter instrumentation, we wouldn't go do those flutter vibration kind of test points, right? So those are considered safety of test or safety related.
Gotcha. Makes a lot of sense. Thank you so much. Keeping questions coming. Again, tag us at NASA Spaceflight. I'm always looking for questions as just a quick status update. Rock is now back at the far end of the test corridor. As Rock is flying northeast of Mojave Air and Spaceport, say about 15,000 feet. Is that the altitude that we're expecting Rock to mostly stay around for today's test?
So we are going to climb to a higher altitude. I think our max altitude is around 22,000 today,
Gotcha.
closer to the end of the cards, if I remember right.
Yeah, gotcha. All right. And we were talking about, I want to dive back into this. So we were talking about the captures the maneuvers that we saw the Rock perform. I keep saying the Rock. The maneuvers that we saw Rock performing earlier, especially when it was flying closer, where you're pitching up and down, and you described them as pitch captures, and then you were also talking about NZ captures. So I'm going to try not to embarrass myself because I did take structural engineering classes, so I should know these terms. The NZ captures, is that a maneuver where you basically pull up until you reach a certain G load, a certain NZ value, and you're holding that for a certain amount of time? Is that what you're talking about? Or like more intricate details on what exactly that maneuver actually is?
Yeah, that's my understanding of it. I also took structures classes, but it's been a while. I've been dealing with electrons too long, but that's my understanding is that yeah, you're pulling G's, right? And you want to maintain that acceleration like Grace was talking about in the Z or X direction or in the seat of your pants or in your chest or
Versus a pitch capture. So that
Right.
one you're like targeting an angle. So for example, like, 5 degrees or 10 degrees, 20 degrees instead of a 1.2 Gs or something. So you're just trying
Right.
to capture different things.
So then, yeah, so a pitch capture is about reaching and holding a certain attitude, whereas in the NZ capture, for example, is like the rate at which you're pitching up and down, which produces those G loads. Is that the difference? Am I describing that right?
Yes, you're describing it correctly.
Excellent. Do you do the same thing for like, are there roll captures? Are there yaw captures? Like, are all those also used?
Yep.
Nice.
Yeah, definitely. Yep. We have roll
Very
and yaw
cool.
captures. I don't know if we don't have NY captures. You can't really do NY, but we have roll like yaw angle captures. We
yeah.
have roll angle captures.
Yeah,
Yeah, I
okay.
think NZ is the only G capture that we do.
And that makes a lot of sense. That's kind of like because I mean, in one dimension, that's just a matter of your thrust, and then the other one would be if you were like translating up and down. With like, I feel like the G load you encounter most commonly is when you're pitching in the direction. So that makes sense. All right, I've got more questions coming in from chat, so I'm going to keep those coming. Pivoting over to talking about Talon, which is of course the vehicle under wing of Rock today. It's just a separation test article that will not separate today. It's just a captive carry flight. But the eventual missions of the hypersonic testbed that is Talon-A, what kind of missions or customers or payloads or what applications exist for that vehicle that the hypersonic test will serve to support?
Yeah, so we can fly a pretty versatile mission. So we're open to having a lot of different customers. Typical payloads would be like thermal protection systems, temperature sensors, things like that. One of the big problems with hypersonic flight is things get really hot. So you have to know how to deal with those things. And we're only going, Mach 5 in that area. So things get pretty hot there, but other hypersonic vehicles can go a lot faster and things get even hotter. So a lot of payloads in hypersonics are kind of geared towards that thermal protection system and the instrumentation that you use to characterize that.
Yeah, so the point is like Talon is not the actual end goal. our customers' vehicles are their end goals, like, and we're an accelerator. We're like a helper. So when we were talking about the spectrum of like zero analysis, all test versus all analysis, zero test, like our customers don't really actually have a test option for open to them that's like
Right.
very easy, like that you can do often and cheaply, because to test in the hypersonic environment hasn't been routine in like a very long time. Like since the X-15 stopped flying in the 60s, yeah, there isn't routine access to like
Right.
hypersonic,
Mhm.
like horizontal flight. I think you can like go sign up, get in some wind tunnels, but I think there's only a few, and I'm sure it's like exorbitantly expensive
Right.
Sure.
and hard to get
Exactly.
on the list.
That's what I was going to say is that you can get into those wind tunnels, but there's a
Well,
long line.
Yeah, long
The,
lines.
the test section, I think, is probably pretty small.
Yeah,
So you can't test like a full vehicle, to my understanding.
yeah.
Yeah, it'd be a
Someone their vehicle
subscale or
happens to be
something.
real small.
Right. Yeah. Like a, little Hot Wheels car kind of
Yeah.
size.
Yeah, and there's like more vertical options, sounding rockets, but
Right.
that's you don't recover your thing from that too. So
Right.
that's
Yeah.
one advantage of Talon-A.
And there's a difference. I mean, with, horizontal hypersonic flight, you're flying it, you're flying left to right instead of up and down, right? So you can maneuver. First of all, Talon-A is a maneuverable hypersonic vehicle. So the environment is a bit different when you can maintain altitude at, whatever altitude instead of like a sounding rocket
Yeah.
where you're screaming through the different altitudes really fast.
And if your eventual like application of your thing is hypersonic like horizontal flight, then like it makes sense to
Right.
test it in hypersonic like horizontal flight.
Right.
And yeah, that's also like well sounding rockets. There's set like set launch
Points,
locations, and Rock can go to a lot of different airports. So like the ranges that Rock can go to are different, and we can recover things. And why would we care about, or why would the customer care about like recovering their thing? Like if they're testing thermocouple, testing some sort of sensor, and they get it back.
Yeah.
I think there's a few things.
Yeah, I mean that's a good question that, on an expendable vehicle, everything that, you're measuring and monitoring on the vehicle has to be telemetered back or sent back over the air with a radio.
Yeah,
right?
yeah, like that's all the data you'll ever get.
Which
Yeah.
it can be problematic, like sending things. Think about your cell reception, right? You don't always have good cell reception if you're behind a mountain. It's the same way with, in aerospace. If things could be bouncing off the ocean, they could be bouncing off mountains in some strange way or off clouds. Moisture in the atmosphere can affect those kinds of radio transmissions, right? So with a reusable vehicle, it's much more reliable. You have a better chance of getting your data back.
Yeah, because there's the data is also stored on the vehicle,
Right.
so you can like download it when it's back.
Exactly. Yeah.
But then also, if you can actually look at your thing again, if it's materials or TPS, like you get the visual
That
data.
too,
Like when
yeah.
you get it back, you're like, oh, well, that's scorched. Like,
Right.
like you can look at it,
Yeah. Yeah, that's a great point.
and then you can possibly fly it again. Like accumulate flight time. Like on the same piece of hardware, you can like get multiple like flights on it. That could be useful.
Yeah.
And so that kind of ties in with earlier talking about the difference between analysis and test, but also there's different like qualities of tests. So if you go to a wind tunnel, you might need to have a subscale test article in the tunnel, or the tunnel won't be able to get to the exact right environment for the test. Like you can test some things, but it's not the same as going and flying for real. That's got to tie in with recoverability too. If you can actually get the hardware back, that's got to be, you got to have more confidence in your data and your results of that test. If you can physically inspect all the hardware, your sensors or whatever, when they come back, rather than, sure, you beamed back all the data in a telemetry stream, but then the vehicle is expendable and lost, and you can't really go and verify that the data you received via telemetry was accurate, and you can't physically inspect the hardware. So there's got to be benefits in that way too, right?
Yeah, for sure. Different quality of test is a good point. Like you're always trading like how much to test versus not, but also the quality of the test versus the effort to get that quality of test.
Yeah. Yeah, that's a good point. That I'm thinking of like wires and avionics stuff, right? If you you don't have a camera inside the vehicle, so maybe some wires come loose or, whatever.
Mhm.
You wouldn't know that unless you were able to pop the doors off and look in there and say, oh,
Right.
that bolt kind of
Mhm.
loosened a little bit. Wasn't a problem, but, things like that are extremely valuable if you can get the vehicle back.
Yeah. Yeah, that's stuff we were thinking about before we did our super exciting recent test, the mass sim drop test.
Oh, yeah.
We can tell you all about that.
Please
Yeah,
do
so
go on.
so I think there's probably some strata like Twitter or some TikTok posts or whatever. Are we on TikTok?
Yeah.
We'll have to talk to Kate.
I think I saw it on LinkedIn.
I did. Okay. Anyway, yeah, you can go look up. I think there's videos somewhere. But we did a mass simulator drop test. The point of that is to get us a little bit further to the right on that scale of analysis versus testing. So we did a bunch of analysis, but like, can we reduce some risk before we go drop a Talon for the first time? So we went and did a mass simulator drop test. Mason's in the room. He's smiling. He had such a good time. He's in charge of the release system on the pylon, which is in charge of dropping Talon. So what we did is, well, obviously we don't want to damage a real Talon like TA-01 or 2. So we built this dummy mass simulator. It's exactly what it sounds like. It's like a bunch of welded steel tubes to simulate the mass and CG of Talon. Doesn't simulate the like arrow shape or anything. Just mass and CG, but has the same exact interfaces to pylons. So the 3 attach points, and then also the umbilicals. So there's the mechanical attach points that like hold Talon on to pylon from a just load standpoint, but then the umbilicals is where we pass all the like the care and feeding of Talon, because it's like, it's the star of the show. It's the princess baby, so it's got like locks and GN2 and signals to it. So we've and signals and power and stuff. So those all go through the umbilicals, and so we also simulated those for this test to get like even closer to simulating every part of the separation. So we attached that, and what we did is actually just dropped it. We dropped it in the hangar. Like we dropped this 65-ish, 100-pound mass in the hangar, and it was a spectacular day, and everybody was so stoked, like, because we did so much subsystem testing to build up to it to make sure that test went well,
Yeah.
which in itself was a test to make sure the real thing goes well. So there's like so many steps.
And we used a gigantic, like, inflatable
Yeah.
stop bag, which was, I don't know, I
Yeah.
thought that was almost as cool as the actual separation.
It was so
test.
cool. Yeah. So those like stunts that people do, like motorcycle stunts, car stunts, like ski, like sports stunts, ski and gymnastics and stuff.
I got the video
Oh,
of that
yeah.
with the airbag.
Nice.
Right there.
Yes. Oh,
Yeah.
there it is.
That's awesome.
Oh, so cool. Those are
look
the
at
3
that.
attach points that you're seeing there.
Nice.
Yep.
A short
Sweet.
clip.
Yep.
Luckily, it was on your YouTube channel, and we grabbed it real quick so we could show the stuntman airbag drop in there.
Yeah, cool. Thanks
Yeah,
for doing
it's
that.
so cool. Thank you so much. Yeah, watch the rest of that video. There's some cool like clips from Mason explaining a little bit more, and from a like Mason standpoint of why we did that test and some intricacies of the release system.
All right, gotcha.
Nice.
All right, well, I'm going to keep questions coming here. Again, tag us at NASA Spaceflight in chat. We'll also keep you updated on the flight test itself. A quick check-in on that front. Grace or James, any updates as to like specific test cards that they're working on right now, or what they're doing on this particular run of the test corridor? Anything interesting there?
Yeah, so we were working on some IAD stuff. So like testing, you always encounter little hiccups and you just decide whether you like wait, figure them out, do a different test point that doesn't require something at the time. So like working out some IADs. We're back on, so we're now on card 19. We're still at 15,000 feet right now.
So starting side slips, it's like, so yaw direction maneuvers.
Yeah, so I mean, these are
Beta
side slip,
sweeps.
they're beta captures, but this is like, I would think this is the same as the pitch, like angle captures. This is the beta angle capture, but
Mhm.
it's not labeled as like a side slip capture, but I think that's what it is, right, James?
I'm not sure.
Yeah, there's a couple different angles that we're going to capture, get data at. And then I think we're trying to stabilize at those angles too. So we're not just going to them and swinging through. They're going to try to set their rudder, throttles, or yaw trim as required to keep that beta. And beta is
So like
the
hold a
beta
side
is
slip for like an extended period of
mhm.
time.
Beta
Interesting.
is the yaw angle. Yep.
Nice.
And I can see that being important because sometimes when you're when you're landing and there's a
Yeah, a
there's
crosswind
a
or something.
there's a crosswind, then you have to like stabilize in a certain side slip.
Like those crazy videos you see of the planes coming in sideways to runways and everything.
I
Not
know they
quite that, quite
they
that,
look
but
like
that's
they're
what
like
we're talking
90
about, yeah.
degrees. Yeah. Our gear, okay, those are like it's so cool to me when airplanes have like the gear that actually like swivel. What is that called? It's like the steerable main gear, I guess. We have
Oh
steerable nose gear,
yeah.
but our main gear
Oh.
are always tracking forward. Like the main gear wheels are always parallel to the fuselage, but some airplanes can turn their main gear
Like
I get
almost
some,
like a crab
Mhm,
kind of thing.
mhm.
Yeah.
So they can just like go ahead and land with their fuselage like sideways to the
Wow.
to the runway, and their gear is tracking straight. Their fuselage is like not tracking straight, but our fuselage and our main gear don't like relative to each other, so we can't do that. But it's pretty cool.
Yeah, it straightens out pretty quick once you get wheels on the ground.
Yes, it does.
Right, yeah.
Speaking from someone who's been in a plane that's done that, yes.
Oh
Yeah,
yeah.
it can be kind of terrifying.
Yes, when you're on the ground, you're grateful. No, but I mean it's neat too because like you can sort of like we were saying earlier, understanding the aerodynamics of how the plane flies, and like you were saying there, Grace, right, trying to maintain the side slip for the different weather conditions that the plane might have to fly in. It's important to understand and validate those engineering practices.
Yeah, for sure.
But
All right.
oh
Go
yeah,
ahead,
sorry.
Chris.
I see a question in the queue that I'm kind of interested in here.
Go for it.
Yeah, so Brian is asking, can the rock be used as a heavy lift transport to transport cargo to different areas?
It could be. We have massive capability weight-wise and volume-wise, actually. That's kind of what makes it special.
Yeah.
I mean, like, weight is a thing, but not a lot of airplanes have, like, this volume between the fuselage that you can put stuff in. Usually it's like, all right, you can mount stuff under the right wing or the left wing, but then there's, like, ground clearance and also, like, more stringent weight requirements because you don't want to be, like, flying around trying to use all your ailerons on one side to compensate for the asymmetric weight. But yeah, we've got 100 feet between the fuselages and then like pretty good forward and aft space for like 500,000 pounds of weight. How
That's a
many?
lot of Amazon.
I mean, yeah, Amazon. How many Miatas was that? Let me look that up. Oh,
Oh
also,
no.
did we correct that Cadillac? Yeah, we corrected the Cadillac thought.
No,
Yeah.
we didn't.
No, we did because I was like so horrified that we were so far off. It was like 5,000 pounds.
We didn't say what it is.
Oh
made
yeah.
of, which is a narwhal. So Talon today is about the same mass of a narwhal.
Yeah, which
Fantastic.
I think I've discovered this every single time, but it always shocks me that the narwhal is a really animal. Like I've seen it on National
Yes.
Geographic and everything. I was like, how is
The first time I saw
thing?
the first time I saw a narwhal was in the cartoon show Futurama, and I thought they had made it up. And it wasn't until I saw a picture of it, I was like, wait, that's a real animal? Like,
Right? It's one of those animals that you're like, okay, what are you thinking?
Oh my goodness. Love these Strato streams. They're amazing for all of these reasons.
Yeah, another
Rock
one
is
is
current.
like the platypus, another animal that you're like, okay,
Yeah.
what the heck?
Yeah.
Like
Yeah.
what the actual heck?
Doesn't even sound real.
That's funny. We got Rock flying basically, looks like kind of parallel to the runway off to the northeast of the airfield now, coming back closer to Mojave. Test cards are continuing. Aircraft still around 15,000 feet in altitude. And I see the landing gear have been retracted for a while now, and they've been doing lots of those test cards, doing some yaw captures earlier. And you can also see the chase plane flying alongside. We did have a quick question in chat asking what kind of chase plane that is. It is a Cessna Citation 550, I believe.
Yep.
Just
that's what
basically
it
a
is.
business jet. But yeah, and then this other question in chat, I think we touched on earlier, asking how many airports can this vehicle land at? I guess let's start by talking about the Rock. I believe you said the Rock is basically capable of landing anywhere a B-52 can land. Is that correct?
Yeah, that's right. Yep.
And is that mostly a wingspan, like,
yeah.
Yeah, so there's
limit.
a couple different things that determine what runways you can land on. Mostly it's the runway length and the runway
Right.
width. Well, yeah, I guess those are the only things. And there's altitude at which your runway's at. So, I mean,
Sure.
super high altitude becomes a problem. But runway width, obviously, like both your gear have to fit on it. And you kind of want like a little bit of, you want some on the sides
Yeah, you don't
for
want both
margin.
sets of landing gear like on the edges of the runway. You don't have no room for error. That's bad.
Yeah. So that's width. And then also you want length. So for landing and taking off, you need a certain, like for taking off, you need a certain amount of speed before your lift is greater than your weight. So the two opposing forces in the Z direction is just lift and weight. And it's really, really easy equation. Like you want lift greater than weight. And then lift is determined by the shape of your airfoil and how much wing area you have. So if you fix those, which you do because our wings are already built, and oh, well, we don't have one of those like cool morphing airplane wings. Yeah, our
Mhm.
wing is built. So then the only other way to like change how much lift you get is by pitch and speed. And when you're on the runway, like obviously you're not gonna like pitch up or down. That'd be weird. Unless you could sit on the tail. That wouldn't be a good day. Anyway, I'm diverging. So you just change your speed. You get more speed, you get more lift. Like that's the bottom line. So you need a certain amount of speed to get a certain amount of lift to take off. So also depends on the air density. That's where the altitude comes in. But at a
Altitude
given
and like
altitude
weather on a given day, right?
and weather, yeah. Also, it's airspeed they care about, not ground speed. So if there's a headwind, then you need less runway because you can get to a certain airspeed in the same like in a shorter distance.
Right.
Because like if you're sitting at 0 ground speed and the headwind is 10 knots, then you're at like 10 knots
Yeah, your
airspeed
started
already.
airspeed of 10, exactly.
Yeah, in Mojave. Oh, okay. You've probably seen these videos. Sometimes the wind is so strong here that like the airplanes in the boneyard will like once they kind of you could see them. I don't think anywhere actually close to taking off, but you could see them thinking about it, like they're at 0 ground speed. There's 0 ground speed and the wind is like so strong that it's like making
Nose up,
Just stuff
nose
starts
up, nose up.
moving.
yeah, you're like ooh okay. Or if your airplane's really like doesn't need that much airspeed and is slow, like mine's like will take off at like 40 knots or something ridiculous. Like you can just be sitting on the ground and take off if the wind is strong enough. And then I've heard of people, if you're trying to land and the wind is higher than your landing speed, you'll be like at your landing airspeed, but ground speed you'll be going backwards.
Yeah, you'll go backwards.
Yeah. Anyway, what was the question? Oh, right. What airplanes can rock land at? Yeah, so it depends on runway length and width and altitude. Also slope of runway. Like, I mean, this
Oh,
is
yeah.
like very intuitive
yeah.
in your car. Like if you're trying to accelerate up a hill, like at 10 feet, you'll be going slower than if you were going downhill. So there's that. So yeah, you need to establish a certain speed so you get the lift that you need for takeoff. And your speed is limited by your thrust. So you can only accelerate a certain amount. So like thrust and weight are your forces in the X direction. So you can put up max thrust and you will only accelerate how fast you accelerate based on your weight. So you need a certain amount of runway length to get to your speed. So that's a long-winded answer to what determines which airports Rock can land at and take off at.
And then there's that added complication too. Like once you have the runways determined that you can actually physically land at, right? Then actually being able to land and take off depends on the weather conditions of the day, right? Because a strong enough headwind and you run out of enough room on your runway to gather enough speed, right?
Yeah, well, headwind helps tail. Yeah, if you have tailwind, you'll run out of
Yeah.
room on the runway. Yeah, that's
Oh,
why
I
you
had
always
that
try to
backwards.
take
Yes,
off into it.
yeah.
Yep. Mhm.
Awesome. All right. Got another question here relating to the vehicles that Rock will eventually launch or drop or release or whatever the right word there is. Does Rock have to fly at a certain attitude, like a pitch angle, in order to release or launch a rocket-powered vehicle such as Talon?
That's a great question because in previous iterations of like different other vehicles that were possible things to carry in Rock's past, there were different pitch attitudes. And actually, there was one that it was a pretty aggressive pitch. I know because because it seemed pretty scary to me at the time, but I don't know, maybe it's a normal thing for people. And the model that we have in the one of the models we had in the lobby had that iteration of rock at that pitch angle for release with the boosters and the fuselage. There was fire coming out of the back. We didn't end up doing that.
Yeah, I think it depends on the launch vehicle too, right? The test vehicle.
Sure.
If it needs to, have the carrier aircraft do a kind of pitch maneuver. So maybe to say it a different way, Rock can do that.
Mhm.
I don't know that it always has to, but it's certainly capable of doing that, I would say.
That is a great, much more concise answer. Joyce. It can, but doesn't need to. For Talon-A, we don't need to.
That's what.
So so we're releasing rock at rock level.
Okay. Gotcha.
Very nice.
We're not doing like some people like call it like a zoom climb or something.
Yeah.
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 Just level for
Okay.
Talon, but rock is capable of releasing at all different points.
Yeah, gotcha. Another question kind of related to that, when TA0 eventually does its separation test, does it have like actively controllable surfaces on it where you can do active gliding on the way down, or is it simply a test of it separating and falling away from rock, and everything beyond that will be waiting for TA1?
So TA0 is only a separation demonstrator, so we don't intend to glide the vehicle or anything like that, or have active control. It is a separation demonstrator.
Gotcha.
Yeah,
So
Okay.
the idea is that we want to, we're reducing risk for our upcoming flights, right? We want to make sure we can
Right, yeah.
safely separate the vehicle from rock and have it fall away in a predicted manner. And we're even validating those models too, right? Because we've predicted how it's going to fall away. We want to collect that data so that we can validate those models.
Yeah, we're interested in the like first few feet, not
Right,
all the way to the
exactly.
ground.
Not beyond that. Gotcha.
Yeah.
All right. Well, everyone, just a
Uh,
quick reminder here to tag us in chat with @NASA Spaceflight. If you got any more questions, I'm continuing to look for those and pull those out best we can. But yeah, otherwise, oh yeah, there is a question in chat asking if we can talk about that our old design that had the cockpit in the vertical stabilizer.
Yes, I love talking about designs that didn't happen. I also love talking about designs that happen. Okay, but probably even more the designs that didn't happen. Yeah. Have you seen the picture of Rock with the cockpit on the right tail?
I've heard about it. I've heard the tail throughout the years, but have never seen the picture.
Okay, yeah, it's pretty cool. So this one had a Bronco tail, and the cabin was on like the right, on the tip of the vertical on the
Wow.
right, like where it goes to the Bronco part of it.
Yeah.
And I don't know if it was this iteration, but one of the ideas was that in an emergency, oh no, I don't think it was this version, but in one of the iterations of the many dual fuselage airplanes of Burt Rutan's, one of the ideas is that that cabin could detach from the airplane in an emergency and fly home by itself.
Wow.
Uh-huh.
Oh wow. What?
Escape
Yes.
pod.
Yeah.
That's pretty sci-fi.
It was
So like an
I
escape pod from the
loved it.
Enterprise. Like
Yeah, like okay, let the airplane crash and burn, like the cockpit can go home. Yes, that was incorporated into one of the designs.
nice.
Yeah, there was a lot of
So
evolution
interesting.
throughout the years.
All right. Well, any updates on the test flight itself? They still working on yaw captures, or are there some other test cards they're working on now?
Yes, I hear that we are climbing now. We're on card 20 and climbing.
All right, gotcha.
Nice.
And Chris, please jump in if you see any questions. I'm looking at questions too, but if you
I
see
am
any that you want to
too,
ask,
yeah.
please just take a look and feel free to jump in with those.
We were
Definitely is.
we've been at 15,000 feet this whole time, and now we're climbing
Oh.
to 22,000 feet.
All right, copy that.
And when you were talking about the different missions that can be tailored here for various customers flying on Talon in terms of what you can do, does that include the release altitude for Talon, or is there like a set we have to release it within this range? Like how does that work? What's the maximum sort of altitude Rock could be at and do
Yes.
its mission?
Yeah, that's a good question. So there is, a wide range of altitudes that you could release a vehicle from. Um, today we're climbing up to around 20,000 feet. So of course you could release anything up to that altitude. The max altitude of rock, I'm not 100% sure, but I often hear it compared to, like a 747 or your, kind of normal, airliners, passenger jets and things like that. So anywhere from a few feet off the ground, I guess, to maximum altitude similar to like an airliner.
Yeah, yeah, for
Gotcha.
rock, and we can launch Talons from about like as low as 20,000 feet to as high as 35,000 feet, depending on what our customers need. So
Okay.
that's also something like we will, give people what they want.
Yeah. And then Talon sort of climbs above that release altitude, right? Or can it just do straight, like let's say you release it from 15,000 feet, let's just say, and like can it just go at 15,000 feet and maintain that, or does it have to do some type of like climb maneuver for its aerodynamics as it comes back to land on a runway?
Yeah, so that's a really good question too. So it does, release at a lower altitude and then climbs to a higher altitude and flies at that higher altitude. So the air is a little thinner. You can go faster a little more easily. So that is the goal.
Gotcha. Gotcha. And so I guess here too, like I mean, we're seeing the captive carry test today. You've talked a little bit about the drop test that is coming up. Hopefully soon here with this system with Talon and with Rock. What sort of lies beyond that? Like let's say this test goes well, let's say the drop test goes well. What sort of lies ahead for Talon?
Yeah, so today is our first captive carry of TA0. We're doing some limited system checkouts inside TA0, mostly passive type stuff. We're checking out GPS, we're checking telemetry, we're checking power systems, things like that. So coming up next, if everything goes well, we'll do another captive carry, maybe two more captive carries, and then expanding the envelope. So checking out more subsystems in TA0, and then by the end of this year, December, we'll release TA0 for its intended mission and demonstrate that safe separation.
Gotcha.
So pretty,
And
we're here at kind of the end of, close to the end of TA0's life, which is kind of exciting. And then, after that, we'll, full speed ahead on TA1, our first hypersonic vehicle.
I know,
Yeah.
right? The little test beds that help us in the early days, but we don't necessarily need them all that long, right? Like Talon
Right.
Zero. But
Right. We have to let go at some point.
Yeah.
Can you do it, James? Can you let go?
I have
Can you do?
I have a tear running down my
Yeah,
face
yeah.
right now.
James tearing up. It's pretty embarrassing.
and sort of like to that so Rock definitely has pilots, but Talon is fully autonomous. So does it fly itself to its destination and sort of land back on Earth by itself? Does it use you just mentioned backup parachutes for like a previous design? Like, does it have backup parachutes in case like as backups? What sort of goes into how Talon will fly itself back after it separates from Rock? On
So
operational missions, not this one. Let's make that clear for everyone.
yeah, yeah. I mean, I'm the rock person, so you can
Well,
talk about Talon.
yeah,
The rock has no parachutes. Well, the pilots, okay, the crew has parachutes,
Yeah.
but there are no like drag chutes, or anything on rock itself, or
How-
like spin chutes or
How
anything.
big of a parachute would you use for a
That's a great question. We should get our aero team on
Is it
that
how
ASAP.
big of a
Like,
parachute, or is it how
ASAP.
many parachutes?
Yeah.
How big and how many?
Like one on each tail.
Oh, imagine if you were driving down the freeway and you saw something falling out of the sky, like kind of spinning with like shoots coming out the back, trying to rest the spin.
Yes, I.
Yeah, no, Rock has none, but the crew have, the normal shoots
Yeah.
that crew wear. But Talon,
So Talon does not have any parachutes. that's why we have to, put so much emphasis on testing the software, testing all the avionics, the flight controls, and, make sure that it's going to be able to perform the intended mission, which is to fly it back, eventually fly it back home and land it on the runway. So it is, fully autonomous, no parachute, no kind of like backup recovery options like that.
Gotcha. Gotcha. And deadly ATW thing. Hopefully that answers your question too. No parachutes across the board. So, but here's another good question from chat asking, what are the technical differences between dynamics when flying rock and a normal plane?
That's a great question. And we already kind of covered a little bit of it, but there's still more to dig into there. So we talked about the off-center line thing. That's like the biggest, first, most obvious difference between a quote unquote normal plane. Also, don't tell Rock that. Don't don't hurt her feelings. She's a good one. Yeah, so your off-center line, that is one of the big things, and I think we've gone into mostly like all of the things about being off-center line, including just the visual cues and also the different forces that you feel by being off-center line. But then other than that, rock is just also like big, heavy, so it responds slowly. And that kind of depends on like a lot of things. There's how many flight controls you have, how many of them like you use at what time. There's different modes you can turn on to use like inboard and outboard ailerons. So rock even feels different in different phases of flights depending on like how you have your flight controls configured. So I don't know. I've flown the rock simulator, but obviously not the same thing. And flying the rock simulator, it just feels a lot slower of a response than other airplanes. But I'm used to really tiny airplanes, so I think the big airplane drivers that have flown the rock simulator they're not super bothered. They don't seem to think it's way different. Like Mark Giddings was like, yeah, feels like a big airplane. And then when he went taxi test, he kind of like said the same thing. He's like, yeah, like handles like a big airplane. So I don't know. It probably varies pilot to pilot too, based on your experience. But I just thought that rock responded really slowly. So it took a lot of like thinking and planning ahead to be like, okay, I'm trying to land. Now when do I have to put this input in, this roll input, and when do I have to take it out to like get the response that I want? So it was a lot of planning ahead, but that's as a small airplane pilot.
Yeah, I remember flying the simulator years and years and years ago, and I'm sure it has changed a whole lot since then.
I've heard it's gotten better in the good direction.
To fly at the end, but I know it's a lot easier to fly now.
Yeah, and another thing is the control forces. The forces are heavy too, but our flight controls are hydraulically actuated, so it's not just like flight control cables. You're not actually muscling cables 200 feet down the wing to the tail, to the ailerons and to the tail. They're hydraulically powered, but they are mechanically actuated, like kind of hybrid. So there's different things you can do to tune different forces, but generally rock felt a lot heavier than stuff I was used to, which isn't surprising at all. Any other different things, James?
Can't think of anything.
I mean, this is something with all multi-engines, which I don't fly, but I thought it was kind of hard to keep all of the engines at the same level, like all of the thrust levers at the same level. We have a little tool to try to do that too. But if you needed to, you wanted to intentionally put one of the engines at a higher or lower thrust level to kind of as yaw trim, and you wanted to keep it there, you can do that and change the friction of the thrust lever to loosen it and then put it where you want and then tighten it again to make sure it stays. I don't know.
Yeah, I think it would be fun to make a Talon simulator where you could actually fly it with a joystick. That would be cool. See if anyone could control it.
Yeah.
I mean, all I'm saying is I own a joystick and a computer. So if that ever exists, let me know.
I was gonna say, I'm thinking what we need is a rock mod for KSP, so we can all fly this thing.
I'm just saying, KSP, the new flight sim, whatever works best. I'm here for it. We'll stream it. It'll be a Stratolaunch and NSF stream. Let's go.
It's like now available on Steam.
Now available on
Download
Steam,
it.
Talon Simulator.
Get into those Christmas sales.
Indeed,
go.
indeed. Well, so here's another question about that kind of goes into the dynamics of flying. You know, space planes tend to land much faster than commercial airliners because they're gliders. They're coming in. They've got one shot at it to manage their energy. Is that the same with Talon? Like when Talon is coming back to land, is it essentially a glider? It's got one shot to hit the runway, sort of like the shuttle did and the X-37B does, or does it have fly around capability with its engine?
Yeah, it does come in unpowered, mostly empty, very little propellant on board. So it is gliding. And those two vehicles that you mentioned are, yeah, it comes in very similar to that, not quite as high of an angle of attack, but very similar approach. So it's slowing down as it comes in and then touches down, like you've seen videos of the shuttle and other vehicles do with the back wheels first and then, gently puts down the nose.
Gotcha. And Mark, this is a question that I think fascinates so many people when we see the two full fuselage bodies of the aircraft. So the crew is in the right-hand cockpit, right? So on the left-hand side, what is that cockpit actually used for? Is it monitoring equipment? Is it just empty space? What's sort of on that right side or left side of the fuselage where the crew isn't?
That's a great question. Also, okay, you took my memory. I forgot. We didn't even consider we didn't say today why the crew is on the right side. Well, they're the same. Well, you guys don't know that, but they are the same. The cabins are the same. They're both pressurized. That's a good question people sometimes have. They're like, is the left cabin pressurized, even if there's no people in there? And it's for equipment. But why do the people sit in the right? And it's because if you're in a cockpit, the pilot sits on the left, the co-pilot sits on the right. So you want to be in the right cockpit so that the pilot can look out of the left cockpit and see the store. So your Talon or your whatever you're carrying, it's easier for your pilot to see. I was like, well, does the co-pilot not care? Like if you sat on the left side, the co-pilot could see it better. I was like, I don't know.
So that's fascinating. So the cockpit that the crews sit in for the flights is dependent on the positions that the pilot and the co-pilot sit in that cockpit.
Yes. Yeah,
Wow.
just like how a lot of things in America are determined by, okay, you sit on the left side of the car.
Yes.
And everything's yeah, same thing.
Unless you're driving a post office truck thing, and then you sit on the other side with mailboxes. But
Yeah. I also thought that you want the pilot on the inboard side because it's closer to center line. I'm not sure if that's a huge consideration, but if I were the pilot and ultimately responsible for flying the airplane, I'd want to be on the inboard side closer to center line, even though it's a matter of 3 feet over 50 feet. So whoever's in charge of directional control, I could see that being like, oh, I want inboard, I want the windows, on an airplane, I want the windows. I think those are the two main. Can you think of any other ones, Jared? Any other considerations?
I think those are all probably either reasons to do it or benefits of having it that way.
Mm-hmm.
It just feels a little more natural being on the right side. Like you said, you drive on the right side of the road, land in rock on the right side of the runway.
Actually, I didn't think about that aspect of it. I was just thinking well, the pilot sits on the left side, so left side of the cockpit, so which
right, but they're in the right cabin, which is
that might feel really weird to land on the left side of the runway. You're like, I'm going the wrong way, if you're driving.
Yeah.
We should ask them. We get some good questions here. Let's
ask them how they would feel if we change the to the left.
Just change it midstream. Okay, we're 8 flights in. All right, we're now gonna just swap which side you sit on. Okay, thanks.
No, they probably won't like that.
Okay, but the original question started out with what's in the left-hand cabin.
Right. Yeah. So there's a lot of airborne support equipment over there. So electronics, circuit breakers, power boxes, data acquisition. There's a lot of networking equipment, some radios, things like that. Things that we, of course, don't need access to in a flight, and that can be operated on their own without any kind of human intervention. So we were talking earlier about, well, why don't you just put that stuff, in the right-hand cabin? And one of the answers is there isn't enough room. A lot of rock, like the fuselages there's a lot of empty space back there. There's hydraulics, pneumatics, flight control cables, a whole bunch of wires. But the right cabin is actually pretty packed with, similar stuff. Plus, 3 full-size humans and a whole bunch of, avionics and electrical stuff. So there's not a whole lot of room in the right cabin right now.
Yeah, and then the corollary question that I asked when I found out what we were doing is why does it even have to go in a cabin? Like, it won't fit in the right, but why does it have to go in a cabin? Why can't it go in empty space in the fuselage?
Yeah, that's a good question.
Yeah.
So I think one reason is some electronics can be sensitive to pressure and temperature.
Oh, like it's not certified to an unpressurized
Right.
altitude, like 30,000 feet.
Right, exactly. Yeah.
And temperature. Usually avionics like it better when it's cold, right? But there's a
But
limit.
not too cold.
Okay.
There's a sweet spot. Once you start getting, like -40, -50 Celsius, which is, this is going to be a
Oh, that's
test.
cold.
What is
Yeah.
that in Fahrenheit? -65
that would-
Fahrenheit?
Oh, -40 is a
Well,
crossover, right?
40,
Yeah.
40 is 40, and then 54 is like -65. Yes. Yeah. So really cold temperatures can disrupt the operation of some sensitive electronics. You'll have little microchips and stuff stop working. So that's one reason first of all, we test a lot of our electronics before we fly them to make sure they can withstand the environment, we're going to put them in. But if we can control that environment, as in heating things up, right? Or cooling things down if there's a hot issue, we'll do that as well. So you can put heaters on things, you can put basically air conditioning on things that would get too hot.
Yeah, the 747 actually has racks that we took. We use those same racks for some of our boxes that you plug in cooling air to, and it has a manifold that distributes that cooling air to little holes that then are directed to the boxes that sit on it. So there's active cooling where it's conditioned air, and then there's some kinds of fast cooling where it's forced air, but it's not cooled air. It's just forced ambient air. And then there's no environmental control at all.
Yeah.
Yeah, Chad pointing out also, I would imagine humidity is another quantity that you got to be looking for, especially in that unpressurized environment.
Yeah, humidity doesn't become a huge issue. We're in the Mojave Desert; it's pretty dry. But at altitude, changing altitudes, it can become an issue. But typically in this environment, humidity isn't a huge issue.
Gotcha.
Yeah, that's why. So, long story short, left-hand cabin is conditioned, it's pressurized and temperature controlled, but there's no people in it. It's for all our avionics.
Right.
Gotcha.
And talking about environmental temperatures and things like that, one big test point or test objective for our avionics team today is to measure the temperature inside Talon and anchor or validate that thermal analysis that we did. So like Grace was talking about, we did so much analysis, right, leading up to test. Well, a lot of that, or a big portion of that, was thermal analysis to determine how hot or how cold it was going to get inside Talon. So we've done that on the ground. We know how hot it gets while on the ground, but now at altitude, it's a much different environment. The outside air can be as cold as -50 Celsius or -65 Fahrenheit in some cases. So it could change that internal environment on TA0.
Oh, okay. Another cabin, fun trivia fact. Left-hand cabin is environmentally controlled for the avionics. But why are there windows? The avionics need to see outside?
Oh,
What
yeah.
the heck? Why? That's sometimes an interview question we ask. Don't tell our future interviewees.
Oh, okay.
It's
Well, I don't know.
because
Sometimes some of these streams might be really good recruiting tools. They might be watching right now. You're giving away answers.
okay, fine. Here's a freebie. Here's a freebie. We'll have to come up
Give
with
it away.
other.
Give it a question.
We'll have to come up
New
with
question.
with new questions. But there's windows on the left side because it's easier to engineer one thing and build two of them than to engineer two things and build two things. That's
Ah,
it
sure,
seems like there would be a more complicated answer, a more
No, but that makes
sciencey
sense.
answer, but that's the answer. That's the entire reason.
I think I've seen like early renders of what Rock was maybe going to look like, where there was only windows on one side, and honestly, it also just looked weird. Aesthetics is also important in engineering, okay? Like,
Yes, because the people online will be mean later to us if our airplane looks weird. Oh no.
listen, you got to look good for the customers too. Everything's
Uh-huh.
marketing, right?
Uh-huh.
Oh man, that's funny.
Yeah.
Let's see. I'm going to bring in a couple more questions here. Charlie's asking, what do the pilots think of Rock? Do they enjoy flying it? I'm sure it's a very strange aircraft to pilot.
You know what? That's never part of the debrief. That's not one of the questions of
All
they're
right, we're
like, okay,
adding
how
things
did
to
it
the
fly?
debrief
Did the
here. The
pitch
barf bag count. What do they think? Do you like flying this weird plane? Like,
Like right when
Are
they
you
walk
sure?
in,
how
just
were
be
the
like, "Hey, y'all have fun." Like
I
just ask
mean,
that as the first
okay, they
question.
always come back so happy, but I
well,
would too.
that's a
It's
good point then.
testing it
Yeah.
because like everybody here loves, or not everybody, James says he's a rocket person, but a lot of people here love
I'm a
airplanes.
rocket person, but I love watching Rock.
Yeah, loves airplanes, loves testing, is excited about like, building and testing and engineering flying. So yeah, everybody, ground crew, like, crew chief, control room, flight crew, everybody's coming back super stoked about everything. So it might be hard to separate out how much of that is from the sheer joy of flying Rock. So we
Sure.
will add that to the debrief and ask.
All right.
Checkbox. Did you enjoy your day?
On a scale of 1 to 10, how would you rate your experience? Yeah, it's a good survey like that. But no, you mentioned the kind of crossover there, and I think Stratolaunch and Talon is like a great example of the crossover between like aviation and more rocket-powered stuff. Like obviously this application utilizes both of those things, but I think the people that are interested in one or the other, there's always at least a little bit of overlap. Like if you're a big rocket or spaceflight person, you're also probably at least a little bit of an aviation person, and vice versa. Um, and because there's also a lot of applications that utilize both. You have space planes, you have rocket planes like Talon, where you're combining things from both sides of the aerospace field. I think that's pretty common. It's pretty cool though.
Yeah, it has been an interesting experience for us for sure.
Yeah. One unique thing about Stratolaunch I like to tell people is that we have the airplane side, right? And we have the rocket side.
Mhm.
Some companies are only building the rocket side, and there may be aircraft or aviation aspects to it. Stratolaunch is pretty cool in the fact that we have the airplane, the carrier aircraft, and we have the rocket, development program. So, like you were saying, folks that are interested in airplanes, there's plenty of that. If you're interested in more like rocket powered airplanes or rockets, there's a lot of that too. So it's kind of cool in that way. That's what I enjoy personally about Stratolaunch is the variety of the work that we get to do.
Yeah, I gotcha. That's really cool.
Yeah, I mean, I guess if we're thinking this is a recruiting plug, yes, I have
Hey,
thoroughly enjoyed my time here, and that's not just because I think our PR manager might be listening later. Like, I really have. I've gotten to do so many things.
Yeah.
Not avionics, not any avionics actually, but
you can if you
I
want
did.
to.
You wouldn't want me to, but okay. It did some weight and balance and loads, like flight landing
Yeah.
loads, that kind of thing. A little bit of structural design, pylon, like new pylon, structural design and project management. Oh, pneumatic. Before that, I forgot. A couple years of my life in pneumatics and environmental control system. We had to re-engineer quite a bit of the tubing runs in the center wing, along with my compatriot Matt Tisdale. Yeah, got to go all over the place.
Yeah, that's really cool. I've done mostly avionics, software, hardware design, like circuit board design, analog and digital stuff, wiring design,
Mhm.
quite a bit of analysis actually. I'm responsible for that thermal analysis now that I spoke of, and a lot of the environmental test stuff. So determining all those vibration levels and what the thermal levels and acceleration levels are going to be. I've done a lot of that. In my early days, I actually designed some structural brackets too. So
You did.
some
I
very,
did not know.
very small ones, nothing.
Where are they?
Uh,
Should we go check those?
Actually, the brackets that hold the data acquisition units in Rock, those big, gigantic carbon brackets
Oh yeah.
that are probably way overbuilt, I did those.
Good job. Did not know that. Yeah, we get to
All
go all
right,
over.
there you go.
Hey, I love this. Okay, another reason why you love working here is the people are just awesome. So one of our aero engineers on Talon, called Brian Monroe, was listening to the feed and was also wondering how big of a parachute Rock would need. And so he just
Did he do
he
these?
just ran some numbers real quick and messaged me and said, so to bring a 1 million pound rock down at an acceptable descent, I don't know all the limits of his analysis, but bottom line, we need 44 acres of parachute there.
Wow. I think that
44
sounds like we should
acres.
find something other than parachutes.
He assumed a single chute with a drag coefficient of 1.4. I was asking, hey, does it matter if you split that up into a bunch of smaller chutes or if it's one in gigantic? Oh, he said it probably does, but yeah, 44 acres.
That's a lot.
That's untenable.
Yeah, it's probably like a couple of cattle farms or something.
Yeah. The scale of doable to not doable, I would say it's towards not doable.
You need a lot of sewing machines to make a parachute that big.
Yeah. Oh man, all right. Let's see, we got a question here, another one from Charlie saying, what materials is Talon-A use in its construction? And we can talk about Rock's construction materials as well, but Talon, what, I mean, building a hypersonic vehicle, what kind of materials you're looking at?
Those composite. It's all composite, just like Rock. Talon-A uses legacy shuttle thermal protection systems.
Nice.
So it's all material that has been used.
Yep, the shuttle legacy TPS is another example of cannibalizing, borrowing things, proven technology to accelerate your vehicle, just like us using 747 landing gear and engines. So you don't have to develop your own because why would you? You don't have to. We're all about speed. We want to get to the end as quick as we can.
Yeah.
Right. All right, cool. I didn't know there was legacy shuttle TPS on there. That's really cool.
Yeah, I thought you guys would be stoked about that.
We are, and I'm gonna have to make sure when Christy gets back that we make sure he knows that because that's awesome. But meanwhile, you can see the aircraft flying over Mojave once again, back towards the airfield, up at around 22,000 feet of altitude now. This is the higher of the two altitude levels that we've seen Rock fly at today so far. Any updates on what kind of test cars they're looking at this point in the test flight?
Yes, so we are at 22,000 feet, like you said, around 185 knots indicated, and this is mostly a flutter card. So they're doing some wraps, some like pitch, roll and yaw wraps to try to induce oscillations.
Oh, okay.
They'll give a quick input. So instead of a steady, like a pitch capture when you're trying to put the airplane in a certain state,
Mhm.
like a pitch angle, this is you're flying straight in level and you hit the yoke really hard or you roll the yoke, a really abrupt input, and then take your hands off and see how the airplane settles out.
Oh, okay. Gotcha. And then let's see here.
So the control room is actively monitoring. Did we talk about the control room yet?
A little bit. I did want to mention that this is the first time that all of our engineers for the Talon program are in the control room.
Yeah. Mhm.
So shout out to
Oh,
those
right.
guys.
Yep.
So far it's been mostly the Rock aircraft airplane engineers there because that's what we've needed. But the Talon engineers have been shadowing and doing a lot of
been training the last
a lot of sim sessions.
And it was kind of cool because the Rock engineers have been in there for years now and had a lot of experience, so they were all able to help bring the Talon folks online. trained them up. So, getting ready for this day.
Yeah, but it was the same process that all of the rock control room engineers had to go through, or almost all of them. Were you in the control room for first flight?
No, I
Okay.
was in for some taxi tests.
Okay, right. Yeah, so I was in the control room for first flight only, not second or anything after that. But the run up to that first flight, I think almost all of us, maybe 2 or 3 of us, actually had any control room experience on other airplanes, but the rest of us had none. So it was starting from ground zero in how do you participate in a control room? What do you say? When do you say it? What level of urgency of your thing do you need to reserve for talking to the test conductor? Versus, some stations have a direct knock it off permission to go straight on to the comms, but mostly you talk to the test conductor. Oh, shout out to our test conductor's mom today, Patty Mills.
Oh,
Courtney Mills' mom.
Yeah.
Courtney Mills is our integrated ops manager and test conductor. Everybody wears many hats here. So
Yeah,
yeah,
so-
I'm hoping that Talon engineers are having a good time in the control room on their first flight today.
yeah, absolutely. I mean, it seems to be going well so far, for sure.
Yeah, it feels like a whole different skill set from engineering. Being in the control room it's kind of like, I don't know, it's kind of like cooking dinner versus playing in an orchestra.
Yeah.
It's just different.
Right. Well, the communication between people is critical and like time sensitive, I think, too.
Mhm.
Whereas when we're just working in the office, it's like, oh, I'm going to walk really slowly over to so-and-so's desk and ask him a question and then waddle back to my desk.
Well, you do. I'm usually sprinting because
Oh.
I'm so impatient. It's like, why am I walking? Well, walking is so slow. Like, I can't afford this kind of time.
We all need little scooters, I swear, like little scooters.
No, I proposed those wheelie sneakers. Nobody was on board.
No,
Yeah, in
no.
one meeting, what was it? It was one of our integrated ops
You need those
meetings.
sneakers, but with like as many wheels as Rock has. So there's just like a line of wheels down the bottom of your shoe.
I looked it up. They make wheelies for adults because I was curious. They do. You can buy wheelie shoes for adults. I don't know why we don't do it. Because our hangar's massive, Rock is 385 feet wingspan. So to get from one side to the other takes half your day if
Yeah.
you're walking. So.
Well, and it'd be perfect. It's all flat concrete too.
Yeah.
So you could really,
Mhm.
really get up some speed.
It's a really nice smooth surface. You look at it, you're like, I really want a longboard on here.
Yeah.
Or wheelie.
Oh man.
Don't tell EH&S, they might have opinions. Yeah.
All right, let me see. Keep going with some questions. And some other people who may just be joining the stream, so maybe we'll just do like a quick recap of where we're at. This is the 8th test flight of Rock, all things told, but the first captive carry test flight of the Talon-A vehicle underneath Rock's wing. And Talon-A is a hypersonic testbed, so a rocket-powered vehicle designed to be released from Rock and use a rocket engine to accelerate up to about Mach 5, and then eventually come down and land and be able to be a reusable testbed for various applications of hypersonic research. This vehicle is a separation test article, TA-0, and it eventually will have its final flight when it separates from Rock and basically verifies that it can separate cleanly from the carrier aircraft, right?
Sorry. I wasn't paying attention. What was the
No,
question?
I just when you jump in if I mischaracterize anything, but basically just recapping what this particular test flight is, and TA-0
Yeah.
will eventually do the separation test, but today's just a captive carry and the first of a couple captive carry flights, right?
Yes. Yep. The release test is the end of a series of a couple of captive carries, and this is the first one.
Yep.
So that's why we're so pumped today. And it's why Talon engineers are in the control room for the first flight today, because it's the first captive carry, because Talon wasn't on the past flight, so there's nothing to look at.
Yeah, actually, they were in there. I guess I forgot. They were in there for the taxi tests leading
Yes.
up to this flight, but
Yes.
this is their first flight.
Yes.
These vehicles being in the air together.
Yes.
Pretty cool. I'm excited for those guys. I know they're having fun. hopefully it's not too stressful.
I mean, it is a whole different kind of like,
Yeah.
oh wow, you're the person responsible for making safety calls on this system and seeing if anything's going wrong. It is
Yeah.
a lot of
Right.
different pressure. Yeah. But the taxi test was a build-up approach thing. We also had an engine run. Yeah, so we can talk about all the different steps getting Talon on. So it's not like, okay, yesterday Talon wasn't on Rock. We made it. Now we're
Right.
flying. So there are a
Yeah,
couple
what
things.
goes into that?
Yeah. Do you want to give an overview of all the Talon-only testing? I don't have very good visibility into that, but I'm sure there was a bunch of that before it even came into this hangar.
Yeah, so we have two different hangars here. We have kind of what we call the assembly building, and then the big T hangar, which is where Rock lives and where we do the integration of TA-0 or the Talon vehicles with Rock. But over in the assembly building is where most of the Talon vehicle-specific work takes place, from fabrication to testing. And then once we fully tested those vehicles, we roll them over into the other building right up under the center wing and then do the mate and combine them. But a lot of the vehicle testing it's actually not a lot different than what we do while in the air. We power, one of the very first tests we do, and I'm speaking from the avionics perspective, is we power the vehicle up. So we bring up our batteries, we power on a lot of the sensors, propulsion sensors, flight control sensors, accelerometers, thermocouples, and we check each sensor, make sure that those are sending sending the right data and the data looks good, like we would expect it to. We do flight controls tests where we sweep the flight controls up and down and back and forth. The propulsion team does several propulsion tests where they pressurize systems, actuate valves on and off, make sure all that works. There aren't any leaks in the system. We do GPS kind of tests, make sure we have GPS signals, and the antennas are working appropriately. Data is being transmitted off the vehicle. So we do a lot of tests at the vehicle level that we then go and repeat at the integrated level when we put Talon on Rock, because it's a different environment. Hooking Talon up to Rock changes, kind of changes the playing field a little bit, because now instead of two different vehicles, it's really one vehicle at that point. So we have to retest a lot of that stuff. But yeah, integrated test is a whole nother ball game. And I know you, like the Rock team, does a lot to get ready for, Talon coming over to, get ready for that mate.
Yeah, well, both teams. So, Talon by itself did its testing, and then Rock by itself did its testing. And all the testing that we've done since we first flew, maybe people are asking, hey, what are you even doing on Rock? Isn't it done? You already flew. What's going on there? We did fly. It was only to fly Rock though. So we hadn't integrated a lot of the support we need for Talon. So a lot of the electrical systems, the avionics that Talon needs, the systems on Rock that we need to monitor Talon, those weren't installed. So all of that was after flight one, after flight 2 or 3 was a lot of integration effort and then testing that out. So we would test as much as we can before Talon comes over, same as Talon. Talon tests as much as it can before it's integrated. And then the happy day comes when Talon comes over to Big Hangar and we mated it. And we started that. That was the very first integrated test, was when we mechanically mated Talon to Pylon. So we've done a bunch of integrated tests then. We call a test integrated if it has both vehicles. So
Right.
First test was mechanical mate, and then we did another mate where we then passed power and signals, so we mated with the umbilicals. And then after we could do that, then James and Rock Avionics team did a bunch of avionics checkouts.
Yeah.
Then we did I guess this one's not an integrated test. We did the mass simulator drop test.
Yeah.
But that's not Talon. So that's an interesting one, if we call it integrated test or not.
Yeah.
Yeah. Then Talon remains mated for a while for everybody to keep checking out their signals, everything they want. And then we did a rollout. So we then see what the signals are doing when we're outside versus inside. Do you want to talk about what's different there? I know there's some, but you would vocalize it very, very much better.
Yeah, sure. So once we go outside, One big difference is, well, we're outside, so we have a clear view of the sky. So anything, GPS, SATCOM, telemetry, that kind of stuff, you can really exercise those designs now because you can test them what we call end to end. You can actually use, the hardware like satellites or telemetry receivers on the building or et cetera, to send data back to where it's supposed to go. You can't really do that full end-to-end kind of test when you're inside the hangar because you just don't have access to those assets like that that you do when you're outside. Something else we do is called EMC testing, so electromagnetic compatibility testing. It's pretty standard in the aerospace industry. We go outside and one of the big sources of EMI, electromagnetic interference, are the plane's engines. So we of course can't run the engines inside, so we have to go outside to do that. We start the engines, we turn different things on and off and make sure that all of the electrical systems are working together and there aren't any kind of anomalies, from an EMI perspective. Like, something might, if you turn on a big powerful transmitter, it could potentially cause something else to stop working. So those are the kinds of things that we check out when we go outside that first time.
Yeah, so we rolled the airplane out, did that testing, and at the same time, after we rolled out, did that engine run at the same time. So it's a little baby steps, and then after the engine run and outside EMI EMC testing, then we went and did taxi test for the first time with Talon mated. So that's the first time we kind of like have relative movement between the two. And now we're doing the first captive carry flight. So that's the background of how we got here.
All right. Well, thank you for that. And that kind of catches us up, I think, to today's flight. So
Yeah.
far, so good. Out near kind of the far end of the test corridor, again, as you can see on that map on your left side, up at 22,000 feet. Test flight appears to be going well so far.
Yep, we're still on the same card as we were before when we said we're doing wraps, pitch, yaw, roll wraps, try to excite some flutter. So we're still at the same altitude.
Gotcha.
James, do you want to talk about what we mean by cards?
Yeah, sure. So I think of what we call the test cards as kind of a script. It has, the cards have all of the test objectives on it, but it's in pretty great detail. So it'll call they're literally pieces of paper that the test team uses to go through step by step all the different test points or test objectives. So they'll have things in there like if you do, a pitch maneuver, it'll have the airspeed you do it at, the angle of attack, and all the attitude and all the test objectives for that maneuver step by step. So that's kind of the way I think about them. Think of them as like a script almost. That
Yeah.
You're literally going step by step through and manipulating the aircraft do the things you want it to do.
Yep. Like if you were in theater or
Right.
a movie or acting or something, everybody has the same script and you all follow along to see where you are.
Yeah.
Or sheet music or something, like everybody who's playing an instrument has the same sheet music and you track along. Like, okay, we're on page 4. Don't play the wrong notes.
Right.
Okay, the piccolo is supposed to do something here. After that, okay, the something, I can't think of any other instruments right now. The flute's supposed to do, like, the 4 flutes are supposed to do this other thing, and everybody knows what they're doing and what's coming next and their place in the whole sequence of events.
Right, gotcha. And some of those cards are also like higher priority than others. Like, isn't there a sense where like there's the cards that you kind of need to complete on today's flight, but do you have other cards that are like, all right, if previous cards go well and you've got flight time left, you can do these, or there are ones that can be kind of scrubbed if you can encounter delays elsewhere. Is that kind of on the fly? You can decide, no pun intended, if you can decide certain cards maybe not can be moved to a future flight or something like that, right?
On the fly. Let me get tally list again. Okay. Yes, totally. That's exactly right. So some cards are higher priority than other cards. And so in the briefs beforehand and the test plan, that's all identified. So it's not a surprise to anybody when if you use more time on a previous card than you thought you would, and so you use more gas, you're like, or just flying time, and you say, okay, we don't have time for all these cards. Which one should we kick off? That's not really decided on the fly. Everybody knows beforehand. Okay, it's these two that we don't really need. But yes, it's on. It's a live decision that
Gotcha.
that the test conductor, flight crew, everybody makes. And there's a cool thing called a fuel ladder. A fuel ladder that the propulsion person makes before the flight. So if you've got 20 cards, for instance, you have a little table that says for each card you think you need this much fuel based on how long the maneuvers on the card take and what power setting you are on for the card and what altitude you're on for the card. This is how much fuel you expect to need. And so then you tally that up, and so you've got a cumulative fuel. So if you're on card 2 and you've already burned more fuel than you have budgeted by card 2, then you know, oh, okay, well, we've got to kick some cards off of this test so that we have enough fuel to come home. So that's the fuel ladder, and there's a couple columns. There's I think a min fuel, like return home fuel, and then there's a nominal mission fuel. This is what we think. This is how we think it'll go, and then there's a minimum. Like if you hit this, you need to kick cards off. That type of thing.
Yeah, I gotcha.
Oh, and that is made by Matt Tisdale. He is the propulsion station right now, I think, or at least he the card.
Yeah.
Shout out to Matty T's mom, Diane Harper. Hi, Diane.
Awesome.
Yeah, we have the fuel card here, and Mason is monitoring it.
Gotcha. Okay.
Okay, so previously we were wondering how many Miatas 500,000 pounds
Oh
is.
gosh.
And
Okay.
it turns out this is quite a coincidence. Do you think, James, or maybe there's some sort of natural law? A narwhal you said a narwhal ends up being about the same weight as Talon is today, which was 2,200, 2,400, something like that. That happens to be how much a Miata weighs.
Wow.
What are the
I
chances?
knew there was a car that had to weigh that much. Cadillac is way off. I didn't realize how much a Cadillac.
Caddies are big.
So
Caddies are big, man.
Another fun fact: when Talon is full of propellant, it will weigh closer to a Cadillac.
Okay.
It's about 6,000 pounds.
Okay. All right, so we go from Miata to Cadillac.
Yeah, it's a big jump.
Okay, it sure is. Anyway, 500,000 pounds is 208 Miatas. So somebody was asking how much we could carry, or could Rock be be modified to be a heavy lift transport? We could transport 208 Miatas.
From the
We
weight
could also-
perspective, you'd have to
from the
fit
weight
them
per-
all in the volume between the two fuselages somehow.
okay, are you
but
gonna make me do this? Did we already do this? I feel like I
Like the
equated.
volume of a Miata.
Yeah. Well, I'll just take length and width and see what how we would pack them
Yeah,
to fit in our space. But I'm pretty sure we could.
we could I was going to say we could consider crushing them. Then it's just scrap metal.
That is really great engineering. Did everybody hear that? So one of our jobs is to question requirements. James is going to question requirements.
Right.
Okay.
We
do
actually
you need the cars
Miata?
operational when they get
Yes.
there, or can
Is
they
the
be compacted?
Yeah, is the requirement to bring uncrushed Miatas or crushed Miatas? All right. BRB.
Excellent engineering work there for sure, though. But anyway, yeah, keeping questions coming as the test flight continues. Everything appears to be going well so far. And let me see here. So we were just kind of recapping. We earlier just recapped all of the test flights that led up to today, and including the kind of integration test that they did between Talon-A and Rock before the first captive carry flight, which is today. We also touched on earlier how the Rock, Talon-A is the first vehicle that Rock is carrying, but there is definitely room for larger vehicles in the future, and when those come to fruition, I'm sure we'll hear and see more on that. But Rock is built to carry things larger than Talon-A for sure.
Yeah, that's what's so great about Rock. I mean, I look at the pylon and Talon on there right now. Be like, yeah, the Rock is overbuilt. Why is it so big? Doesn't need to be that big.
Yeah.
But it's just a bonus. So that means we're really flexible. So we're not using all of Rock's capability now, which actually was very nice when we were designing pylon, because then we had the luxury of weight on an
Yeah.
aircraft. That's pretty rare, where you could just throw weight at stuff like, oh, the march is a little low. Okay, just, thicken it another like 10 thou or 20 thou. Who cares about the weight? This thing can carry 208 Miatas.
Yeah.
It will not care if it's like 20 pounds more. So that was really nice from a design standpoint, and not having as a constraint of a design space lets you go faster. So that definitely helped. But later on, when we do want to use all of the design space, use more of the volume, more of the weight capability of rock, that means we could possibly carry bigger pylons, multiple things under the rock wing. It's really flexible, like pretty exciting to see what we can do in the future.
Yeah, there you go. Quick question in chat that I think I can just take quick. What fuel does the plane use? It is a Jet A. It's powered by 6 jet engines from 747, so they'll run on Jet A fuel, which is coincidentally the same fuel that the Talon-A rocket engine runs on. That actually runs on jet-grade kerosene and liquid oxygen. So both the carrier aircraft and the hypersonic testbed are fueled by Jet A. Of course, the Talon-A vehicle requires liquid oxygen because it's a rocket engine rather than a jet engine. But otherwise, yep, Jet A. And we got another question about rock that I think we've touched on earlier streams, but maybe not today. Mike is asking, any idea why rock, the tail, was not designed with conjoined horizontal stabilizers? So why there isn't one big horizontal stabilizer between the two tails, basically?
We love this one so much. Because it's a great question. I love this question, and I love that people always ask it. I ask it too.
It would look cool.
It
I
would.
think it would look.
Yes, if we're just going for the looks factor,
Yeah.
windows on both cockpits, Bronco tail.
It would look sweet.
Yeah. No, but every time I think about this, I think I always have slightly different answers, because there are different factors that go into this decision, and I'm sure I don't know how much each of those factors was weighted in the decision that was actually made. So I can talk about, parts of the picture. I can give you color to the decision, but I am not in the head of the decision maker. But a couple of the things are that if you connect the tails, you'll obviously add weight in the back. The other option, aft of in the aft area of the airplane, versus forward, like if you put weight in the cockpit, forward. Or you could beef up the center wing to take the torsional, the torsion. So I'm thinking of torsion, like if your arms are out, again, I'm using my arms and you can't see, but pretend your arms are out in a T, and you twist your palm up to the top of the room. So that's torsion on the rock wing, and that happens if the two fuselages are out of sync. Like if one of them is trying to pitch up and one is down, that would be a very bad day. We have things that prevent that, but that's an example of putting a huge torsion in the center wing, and we call that a moment, and that's measured in force times distance. So that's huge. And you could either build the center wing to withstand torsion, or you could connect the tails, and building up the center wing turned out to be about the same amount of weight as putting in a Bronco tail, to my understanding. So if those two things are equal, why not choose a Bronco tail? Because like James says, looks cooler.
And for those who may not be familiar, what do you say a Bronco tail? What shaped tail are you talking about?
Oh, yeah. So it's if the tails were connected, if the two tails were connected, and Bronco in particular, I think is only when it's kind of at the top of the tail. So you could imagine if we just connected the tails as they are. So the horizontal stabilizer is kind of towards the middle-ish of the vertical tail, and you could connect it right there where it is, or you could move the horizontal tail all the way up to the top of the vertical tail. Some airplane configurations are like that too and not connected. But if you connect those, that's what we're saying when we say Bronco tail. So, yeah, what do you think is the most, sorry, getting close to the mic, most famous Bronco tail? James, if people were to be like, okay, what's a Bronco tail? So if they're the same weight, why didn't we pick the Bronco tail? It has to do with where the weight is, because if in an airplane, CG is very important, that your center of gravity in airplanes, I don't know why, they tend to grow weight more aft. It's easier to get an aft CG aft of where you want than a forward CG. It might be because there's just more length aft of your CG than forward. Like your cockpit is not as far forward from your CG as your tail is, so there's just more space to add more weight. So if weight were added equally among the whole airplane, then it would tend to go aft. So to keep your CG where it is, it's better to add weight to your center wing than to add weight to your tail. So that's one thing. There's a bunch of other things too.
Yeah.
I was going to keep going. Yeah, James, you
I
want to
think
add
one
one thing?
design consideration, I don't know if it led us to make the not Bronco tail design, but maybe a limitation on your payload's release trajectory. Right?
Yes.
I mean, there could be increased risk of a payload being or a launch vehicle being released. It falls down, kind of falls back because of drag before
Yeah,
the rocket engine ignites.
Yeah,
You would want to make sure there's plenty of clearance back there.
Mhm. That's a
not-
great one.
Not that, it's going to be falling down. Rock is going to be still generating lift.
Yes. Yes, it all depends on the mission too. Sometimes
Right.
we were talking about how a rock is in a pitch up attitude or even like climbing while releasing the store. If it's not, but also is the store a lifting body versus not? And if it is a lifting body, is it just angled down to make sure that it's not making lift, that it'll fall away? Or are the flight controls set at the angle to make it go down and not up and back and hit the Bronco tail? But yeah, that's a great consideration that I don't think I've mentioned before.
Yeah. I see people saying a P-38 Lightning in the comments. That's exactly what I think of when I think
Oh yeah, yep.
Yeah. Then there's also this one that I would think you want it actually higher would be to get out of the wake of your center wing or your engine. Well, we don't really care because our engines are outboard of the fuselages, but we have flaps inboard of the fuselages. So the effect of the flaps on our horizontal tail was a thing. That was definitely a thing. So I would think if you like move the tails up, then you could get it out of that wake a little better. So that's a pro on the Bronco side. But then another one is you often see the horizontal tails of airplanes in the middle vertically of the fuselage. So if you had the tail a lot higher on your vertical tail, then you just think about the moment on your fuselage. It's displaced vertically a lot from your fuselage. So if you've got a twisting, I'm saying MX and I'm making that like your thumb is going back.
right hand rule.
Yeah, the right hand rule. So just picture you're looking at the back of rock and the horizontal tail is wanting to go clockwise or counterclockwise. That's an MX, a moment in about the X direction. So if you have that on your tail or an FY on the horizontal tail, then there's a moment arm to your fuselage. And your fuselage is where all of your load eventually gets dumped into your fuselage. So if it were centered in your fuselage, then you're kind of twisting right about that good torque tube. But if you're off displaced, then that force is a lot more. So that's another consideration for where your tail goes.
All right.
Do you have any other ideas, James?
I saw someone in the chat said Baloo's airplane and Tailspin. I also think of that one because I watched that cartoon when I was a kid.
What cartoon?
Tailspin?
That's the name of the cartoon?
Yeah.
Like a TV cartoon or like a comic cartoon?
A
Oh my
TV
gosh.
cartoon.
Oh my god, tailspin, tailspin.
Yeah.
Everybody
Yeah.
knows this?
All right,
Okay,
this is
so
all right, I didn't get this one, but I'm glad Dawson Jack too.
I unmuted my
we're
mic.
even singing. Is that the
There was
is,
the
is
intro
that
song,
the intro
yeah.
song? Tailspin, tail.
Yeah. It was awesome.
Huh. Okay. Okay. Oh, also, all right. I love that some people are listening to us, James. We're not going to a vacuum. We have to be careful about what we say. One engineer from TLG, subcontract engineering group that helped a lot with rock development and rock loft shape. Andrew McComas, shout out. Thank you so much. Okay, so his perspective is Bronco Tail came with. Oh, and he is the person for reference that I would trust most to know the story because he helped determine the rock, like he made the rock center wing loft. So he says Bronco Tail came with higher risk of deep stall. Okay, where the wing wake during the stall would blanket the tail, creating potential loss of control. Okay, so deep stall is like a stall is when you are pitched up so much that the airflow isn't attached anymore to your wing. So then you lose lift, and then usually you push your nose over by putting your elevators down. So you nose down to recover from the stall. So you reattach the flow on your main wing. A deep stall is when you get in a stall and you can't recover because your tail is also blanketed. So that's what Andrew is saying would happen with the Bronco tail. And so our lower split tail eliminates that risk and provides the same clearance for payload release. Thank you, Andrew.
There
Yeah,
we
that's
go.
awesome.
hmm Also, my friend Dan Cray also has very many. I think he sent me a whole PDF about the trade back when with some Bert sketches. Yeah, about.
It's so cool.
I'm not convinced everybody is on the non-Bronco tail side. I think there's low key like Bronco tail fans.
The Bronco purists.
Yeah. Like
Nothing but Bronco tail.
and twin fuselages. Like, okay, you got a design problem? Twin fuselage.
Yeah.
A couple of us were I went to USC, the University of Southern California, and I was on the air design team there, and we build model airplanes for the Design Build Fly competition that AIAA hosts. And so a couple of us went to their CDR this year to help them make their design better. And one of their config trades was biplane, 2 wings versus, conventional airplane and blended wing. All of us were like, 2 fuselages. Did you guys not consider 2 fuselages as part of your trade? It's like, Tanner, type it into I suggest 2 fuselages. He didn't.
You're like, what?
Yeah. No, we're like, why does biplane mean 2 wings? That is very wing centric. It could mean 2 fuselages.
Yeah.
It's biplane. It's not bi wing,
It's true. You get people that like multiple wings, multiple fuselages, but is there a plane that has both?
No.
2 fuselages and a bi-wing.
I don't know of one, but I've seen an artist rendering of something that looked like rock that had 3 wings and 2 fuselages.
But
I don't know what it was.
there were engines on each wing.
I don't think there were. I don't remember. It was
That's crazy.
pretty unique. Yeah, but the more fuselages, the more wings you have, the more joints you have. So those are the things you have to trade. Joints are usually more weight. Like if you've got, it's not 1-to-1. Like if you say, okay, I've got 30% more wing, you can usually be like, okay, it's 30% more weight. But if you go from 1 wing to 2 wings, it's not just the wing weight, it's the joint weight, and joints usually, like, they are more dense. They weigh more than other structures. So
Yeah, well, you have
gotta think about
you
that.
have to make them stronger to
mhm.
counteract those moments that you were talking about.
Yeah. So a 2 fuselage, 3 winged airplane just seems like a nightmare.
Yeah. Goodness.
So, adding all this weight and things like that, I mean, Chad's been actively on the whole Miata thing and pointing out that, first of all, you can't load all, 208 Miatas because you still need like 30,000 pounds for the 44-acre parachute that we calculated earlier.
Wait,
So you
did
gotta
somebody
save some weight
figure
for
out?
that.
Did somebody figure out that the 44-acre parachute,
The
how
one
much it
number I
weighed?
see in chat right now is 33,876 pounds. I don't know where they got that number, but that's allegedly the number.
Okay, how about we make this is what you do in engineering. You make assumptions, you
Yeah,
write them
approximate,
down,
and then you
people
test,
can.
and then you
Yeah.
refine later.
Okay, so our assumption for the Miata mission is no parachutes. How about that? We'll do that.
Okay.
Okay, can somebody tell us about that? I didn't actually get a chance to go look at volume, so I'll let James take care of this feed right now.
All right, I'll get
Oh, man.
Your TI-89?
I'll get my TI-89.
Do you
calculator.
actually still have a TI-89?
It's in my backpack right beside me.
That's pretty good.
And I have I was going to go there. I have a pocket protector and a slide rule. Just kidding.
Wait, do you
I do at home, not here.
do you actually?
I do.
My-
They're more of
my-
like display items for my.
It actually took me a couple years before. I'd heard people say, nerds like pocket protectors, like pens. It took me quite a few years before I actually found out what a pocket protector was.
Yeah.
I mean, like, what the hell is a pocket protector?
Yeah.
It protects from the ink, right?
It does, yes. So
Okay,
you put your
so-
pen in your pocket, you
right.
don't mark up your nice white,
Mm.
like 1960s NASA dress shirt.
I got it.
I want to go back for a second. For the TI 80 whatever calculator, do you have any games for it? That's my immediate question.
No.
No, I never did that, but in college, I programmed in tons and tons of equations. So, like, for example, like compressible aerodynamics, I would program in all the flow equations, so I didn't have to type it in every time.
Smart.
And you could just input arguments, like you're writing software, and it made test taking a lot easier.
So you're the reason that we can't bring programmable calculators into exams anymore, huh?
It is solely James. He was the only one taking that.
Because you can't do that anymore, by the way.
Well, they actually let us do it. They would make the exam such that if you didn't do that, there was no way you could finish it in time. Like you had to
Sometimes I've
program.
done ones where I think Virginia Tech makes like an online calculator for both incompressible and for compressible, and you can like do it that way. And sometimes you have tests that use that, but other times it's like no online calculators and you can't bring a programmable calculator because then you just put all the formulas in it. You have to bring a formula sheet, and then it's bad. I like your way better.
Yeah, I know what you mean. I had classes like that where they want to make sure that you understand the fundamentals, right? Which is very important in engineering.
Mm-hmm.
But at some point, once you kind of get past that, I think that's when they maybe transitioned us into, they knew we could do it by hand. We could do the back of the envelope hand calcs. And at some point, you want to kind of make it more efficient. But I will say, in the industry, you don't have to do hand calcs for everything. Once you understand, when you understand the fundamentals, a lot of it is automated. Do it with a calculator, do it in MATLAB, Python, C++, or whatever.
Yeah, for structures, I think a lot of the people I know, at least to me, I basically had to write everything from scratch, also because it wasn't that complex, like compressible flow dynamics and stuff. But all the structural calculations, everybody would have their preferred, little Excel sheet or MATLAB script or something for, lug analysis that you've developed so you know where everything is and it's formatted the way you like with the colors that you like, But I don't think I ever graduated to TA-89s. Am I a lot older? Maybe I'm like generations behind you. Florida is at like 5 or 10 years behind everybody else. I think just it's a time warp.
Hey.
You grew up in Florida? Well, I'm Florida. Oh, where are you from?
I'm from Mississippi. Not
Okay,
Florida.
fine.
It's close.
Okay, close. Yeah, so I feel like we're a little bit behind. So I think I had a TA-83. I think that's all I had. I don't think I ever had an 89.
was the standard for me, so
there it is.
We're in there.
Oh yeah. Okay. James actually he showed me right now. I'm touching it right now. It's TI-89. But yeah, I think I only had TI-83. Probably maybe 84, 83.
We need to like run the calculator out there to one of our cameras so we can show it on the stream. Like, oh, here it is, really. We have it. It's right here. Next time Rock goes way down range, we need something to look at.
Yeah, it says Mississippi State right on the back.
It sure does.
What does it say? Property of? Sorry.
No.
Asset tag on it, like
inventory, like calibration sticker.
Yeah.
Oh my goodness.
I'd be very concerned if they had to calibrate your calculator.
Well, yeah. How does that work?
I think there were some Pentium chips that needed that back in the day or something like.
Oh my gosh. How did we even get to what conversation were we on that we eventually got to calculator discussion?
I think we were talking about the Miatas.
Oh, that's right. We were talking about calculating the volume of that rock can carry. See, it was relevant at one point, chat, okay?
No, you were talking about compressible flow calcs. Was that when we were talking about deep stall?
Oh, and also we were talking about deep stall, yes.
I don't know.
Think of all the math that has to go into making this happen. I mean, look at this beautiful plane. There, we're back all the way back around.
Yeah, nicely done.
we are, but it impresses me so much how past programs before TI-89s did just fine with slide rules. Well, not just fine, but okay, they had it's completely different, but airplanes flew without TI-89s.
One of the fun facts that I hear from people every now and then is that the computing power of like a TI-89 or 82 or 83 or whatever is basically what they were using in the Apollo missions, 50, 60 years ago. Which is, to think about that is really amazing.
Yeah. Now what my little dinky smartphone has, it is actually dinky. I have a very tiny one.
Yeah.
It's called a Palm, but it's more powerful.
Yeah.
Than a lot of
but with the invention of microcontrollers, microprocessors, and that kind of thing. You don't have to build your computers out of individual logic gates and transistors now. So things are a lot smaller. Computers are a lot smaller now.
Yeah. Yeah, and T-84s, we probably did have 89s. Florida is but it's fine, it's up there.
Yeah.
And it's the most affectionate ragging on Florida. It is my home state. I was probably just too cheap to buy the most up-to-date technology.
Surprised mine lasted this long.
How long have you had that thing? Does
Well,
it have a
so-
date on it? You should write a date on it.
Yeah, I should. The sticker is probably as old as like, the last time I used it in college.
You had this since college?
Yeah, this
Okay.
is what I used in grad school.
So that's
So
at
like
least-
2000, well, this is gonna date me now. It's like 2014 was when I graduated grad school.
Oh, wow. At least 8 years old there. Okay. So we're on card 25 finally now, right?
Yep.
Okay,
Card
so we were on
25.
24. We were on 24B for a while. That was pitch, rolling yaw, wraps to excite, flutter. What's card 26, James?
So 26 is an exciting one for me because it's the Talon telemetry checks where they check if we're getting telemetry back from Talon as we expect it to come back, meaning that when Talon is a very small vehicle in the middle of a very large vehicle. So Talon has antennas on it. And you could imagine that if the big rock fuselage is between our ground stations and Talon, it may block the telemetry. So what the pilots do is they do a few maneuvers to put the fuselage between those two places to try to block it and then gradually unblock it. And that data will help us validate some of those antenna patterns that we predicted for the Talon vehicle.
Okay, so does that mean the cards leading up to this point have all basically been how is Rock handling with Talon under wing, but not really looking at Talon itself so far?
Currently for the major test objectives, a lot of the Talon test objectives on this flight are what I refer to as, passive.
Yeah, we call them ride-alongs.
Ride-alongs,
Yeah, the
yeah.
ride-along test
So
objectives.
It's kind of a continuous test, just monitoring the Talon
Mhm.
vehicle.
Yeah, for
So-
example, those engine parameters you were talking about.
Right.
The Talon mode.
Oh, right,
Exactly.
yep.
Yep. So all
So-
the temperatures and accelerometers and
Mm-hmm.
all those things are just continuously monitored.
Yeah, there's no dedicated test point for it, right? There's no card
Right.
in which you do something for that data. You just always get it.
Gotcha, yeah, I got you there.
So sounds like we skipped card 26 or already performed it. It is a pretty quick test and
I mean, yeah, if you're
It-
just looking for telemetry
Right.
link, it shouldn't take long, right?
right, exactly. And it's kind of one of those ride along tests too, where the pilots were maneuvering the vehicle anyway. So I imagine our avionics guys got that data prior to that card.
Gotcha. Still up there at 22,000 feet and kind of at the midpoint of the major test corridor, currently flying pretty much due north actually from Mojave. And let's see, we took off right before like 8:30 Pacific. No, that's a lie. It was right before 8:30 Pacific. So we're like we're just about 2.5 hours into today's test flight. All appear to be going well so far. See if I can grab some more questions. What else can we talk about here? Oh yeah, we do have some more questions about Talon itself, and of course these apply to future missions, not today's captive carry flight. But the question from Brian basically is Talon going to be the first autonomous vehicle to land on the runway, or have there been others?
It's a good question. So it will not be the first vehicle to autonomously land on a runway. There are at least one, maybe two X-37B autonomously lands.
Mhm.
And I'm fairly certain someone will probably correct me, but I'm pretty sure the shuttle, even though it was manned, that the
Yeah, I don't know
approach
if the
and
shuttle
landing.
counts as autonomous. Like it's the
Yeah,
parts
it's
of the
more of a-
reentry and approach are.
Right. It's more autopilot than
Yeah,
autonomous, I guess.
X-37 though for sure.
Yeah, X-37B. That's the only one I can think of offhand.
Was
Yeah,
that
I
question
know
for just on any runway anywhere?
Yeah,
Like fully autonomous.
Yeah, I'm thinking of, because I know the like spaceships in Mojave and Spaceport America, those are all piloted.
Doesn't
Yeah, I
Scale
don't.
have an optionally crewed plane? I forget what it is. It's like the Model 401 or something like that. Scale has an optionally crewed plane, so there's that as well. I'm sure there's others I'm just not familiar with.
There was
Or
the
we're
one
talking
that
space
was
planes only.
it wasn't a space plane, but there was the one that was supposed to be autonomous, and they ended up having to strap a saddle to it.
Oh, yes.
I think Mike Melville, or
Yes.
Mike Melville actually sat on it was a smallish UAV, but I mean still big enough for a person to sit on.
Right.
And he was the safety/backup pilot because in the maybe initial stages of not really trusting the like autonomy. This pilot, Mike Melville, I'm pretty sure it's Mike Melville. If somebody knows better in the comments, please correct me. I think he sat on top of that airplane on like a saddle.
There are
and with backup
pictures.
from
I've
because
seen
I'm putting a
pictures.
picture. I'm getting a picture right now so that they can show
Okay.
it. It's like one of the best things that's ever existed ever in the history of anything.
yes, it's one of my favorite things.
Only in the
This-
Mojave
I'm
does take
picturing
place.
the like external seat you can mount the things in Kerbal. Is that what we're talking
wish-
about?
I
Oh
wish
my
he was
God, it
wearing a
is.
cowboy hat. That's the only thing that could make this photo any more extra, is if he was wearing a cowboy hat. But it's
Is that-
literally just a guy riding saddleback on a plane, like waving, like "Hello, this is normal. Everything's
Yes.
fine."
Is there a way we can put that up on the feed?
Yeah, in work, we're working on it.
Okay.
I'm sorry. I just need to very
That is a
clearly
real
state
photo.
that this is a photo.
This is a real photo that exists that was not photoshopped. It's like one of those photos that looks like it's completely not real. Like, oh, you photoshopped
Yep.
the guy on there.
There it is.
I think that's tape, y'all. It looks like there's stuff
It looks
taped.
literally like you duct tape things to that plane.
That's probably his seat. That's the saddle. I bet.
I don't know if it was actually a horse saddle or any kind of official saddle or just some foam taped down or something. But yeah, that was
What
Skeleton
altitude
Raptor.
is that plane flying at?
Looks like several thousand feet.
Like, it's not flying like low. It's
yeah,
No.
high.
And I'm not sure what the test campaign is, if the pilot was actually flying or if Mike was just a backup pilot and he didn't actually have to do anything and the airplane actually did fly itself and land autonomously. If so, then I feel like it would count in your count.
right.
Do you have
Sure.
like a Nintendo controller or something, or do they just like cut a hole in the top and put a joystick there? Anyways, this is not related to Stratolaunch. I think we should be clear. Just interesting plane designs.
Well, Stratolaunch came out of the same company. Stratolaunch, the carrier.
I was going to say another plug for recruiting. If you want to do cool stuff like this, maybe not ride an airplane. You can come to the Mojave Desert because this is the kind of cool stuff that happens out here.
Yeah, this is not a Stratolaunch airplane, but Rock Carrier Aircraft came out of the heritage of the same company that did this.
They're like cousins or something.
They're cousins.
Yes.
Yeah.
Yes, we're cousins on the we're very like incestuous families on the airport. You kind of go back and forth. You go work here a little bit and then you kind of go work here a little bit, and it's all everybody loves airplanes. Everybody shares the
Yeah.
airspace.
No kidding.
All right.
I got another Talon question here. Now that we've talked about the autonomous runway landing, Brian asking, will Talon ever be able to go to space, or is it exclusively an atmospheric test vehicle? What kind of regimes, other than speed, we know it goes to Mach 5, but what kind of altitude regimes is it built to operate within?
That's a good question. So Talon-A is not intended to go to space. And if we're talking about space, the Kármán line, 300-ish thousand feet, it's not intended to go that high. I believe our first mission is intended to go to around 90,000 feet or so.
All right.
So within the atmosphere, but once you get that high, the air is pretty thin. I mean, you transition through different layers of the atmosphere, and once you're that high, going a lot higher doesn't make a big difference in air density.
Yeah, okay. Yeah, once you get beyond some point, it's very thin air, and you need big changes. You need, big change in altitude to have even a noticeable change in air pressure at that point.
Right. Yeah, exactly.
All right. So that was
So
that
I
question.
did get
Go
a
ahead.
chance. I did get a chance and figured out uncrushed Miatas, easy, 208. 500,000 pounds of uncrushed Miatas. The volume, we can fit it. Easy. So
Easy, she said.
I assumed, I started with trying to fill up the X and Y, the Y and Z that we have. So let's say that you get 80 feet between the fuselages, that's 10 feet of clearance to each fuselage. You probably don't want to be that close, but that's just where I started. 80 feet wide and 30 feet high. In that square, looking front on, if you oriented the Miatas the same way as rock, so driver is facing forward, then you can fit 14 Miatas across and 7 stacked on top of each other. So 14 across and 7 down is 90, almost 100 Miatas already. And 500,000 pounds is only 208 Miatas. So you'd only need 2 rows of them. So obviously we would not, if we were actually going to go do that, we would orient them. We'd stack them a little deeper and less wide. That's probably what we would do.
But not only could you carry the weight of 208 Miatas, you could literally fit that many cars between the two
Volume.
fuselages.
Yes.
Yeah.
Wow.
Yes, 100%. I assumed each one, well, just whatever Google told me their width and length and height was, and I just made them touch. I didn't assume like half a foot or anything between them.
Yeah,
So
yeah.
does not include the structure to carry them. So that's another thing. Maybe just on a broad strokes, conservatively assume that you need about the same amount of weight to carry the Miatas.
Well, you could just
as
like
Miatas.
bolt each car to each other and bolt the top cars to the wing.
Frame,
You
yeah.
don't need a structure.
Now they're
true.
frictionless Miatas on a spherical plane. Spherical
Okay, so
Miatas on a frictionless.
if you put a Miata in a box and you can't see inside the box,
Miata really think.
is the Miata still there?
Next up, Grace, we're going to need aerodynamic calculations with the top
Right,
up
that's
and
where I was
top
going
down.
next. Like now you have
Okay.
extra drag from carrying the Miatas. Although I mean they're cars, they're roughly aerodynamic.
We'll see. Well, up to what are Miata? I don't know. Miatas look like they're supposed to go fast, but they look like they also kind of go 60 miles an hour.
Yeah.
Sorry, Miata owners out there. Sorry, Matt Colbreth.
This makes me so happy though, because I love things that can put a sense of scale in your head
Yes.
for how big things like this are, or rockets also. It's a similar kind of thing where rockets can look small if you're looking at it from 20, 30 miles away, but
It's hard to grasp how big rock is, really. That's why we put it in terms of football fields, but American football fields, but that still doesn't seem enough because I haven't been near a football field in, I don't know, 15 years. So I don't know, but a Miata, I've seen one last week or the week before. And for those of you who don't know, it's a little car that looks like a jelly bean. A Mazda Miata.
Jelly bean.
Yeah.
But yeah,
Roller
I
skate,
wasn't
maybe.
I wasn't like talking at the moment, but when you guys were talking about it earlier, when the Miata talk started, that was my immediate thought was like, oh, would they have to be crushed to fit? And I love that it's like, nope, not even close.
They actually do not at all. Maybe if Brian Monroe, our aero guy who answered the parachute question earlier, if he's still listening, maybe he can think about whether or not he wants to estimate the drag from 14 by 7 Miatas, or I guess pack them into whatever aspect ratio you
Yeah,
want, Brian.
you've got room to pack them, I think, more aerodynamically than that, actually, which is
Yes.
good.
Yeah.
We're entering a new market as heavy air transport of sports cars.
Yeah, we could spare some weight for parachutes, so we wouldn't even have to we wouldn't have to land and unload all of them in one place and drive the Miatas to where they want. It's just aerial Miata delivery. Somebody pushes a button on the computer. They're like,
exactly
okay, I
what
want to.
Miatas anywhere.
That's what I was gonna say. Like rocks just flying over rocks within range of the house, and it goes, "All right, release Miata 3," and Miata 3 just parachutes into the driveway. Yes.
No more supply chain issues.
Yeah. It's like within, let's say, 12-hour delivery window. Like, from when you push the button on your computer for buy. Is that how you buy cars? You just push a button, put your credit card in.
It's
buy a
how
car.
I bought my car, but I don't know that.
And then Rock will fly over, drop a Miata. Even if I didn't want a Miata, I would probably buy one just to see that.
Right, just
see
for
Rock
that.
fly over, drop it in my
That'd
yard.
be awesome.
Thanks, Rock. Bye.
It's the future.
Oh, kidding. Oh my goodness. All right, let me see what other questions we've got coming in here as the test flight continues. Again, please jump in if you have any other like updates on the test cards or anything. But oh, here's a quick question. Rock's call sign. So when it's talking to air traffic control, and this is for standard like ATC communications for airliners and stuff like that. Do you have kind of different? It's mostly based about your thrust level. Um, that basically determines whether you have to append a heavy to the end of your call sign, or I think for the A380, it's even a super at the end, and it basically helps ATC dictate how much spacing between after a plane takes off or lands, another plane can fly in to avoid most of the wake turbulence. And I'm wondering if we know what kind of classification Rock has, because I mean, 747 engines. 747 is I know heavy, and so I'm wondering if Rock has to if it's like Rock 01 Super or something like that when it talks to ATC. Do we know?
That's a good question. Grace stepped away from it, and I'm actually not sure. The call sign does not include a heavy or super, though. I've heard it referred to as
I
a
wonder
heavy, and it is definitely heavy, but
right,
I'm not
yeah.
sure the formal designation.
Yeah, I wonder if also, I mean, specific to whether it's used in the call sign, it's also like still technically an experimental aircraft, right? So
Right. Yeah.
there's might be some exceptions like, okay, you don't have to specify heavy or super because it's already being handled as a experimental aircraft. Not sure exactly how that works, but as far if it was
Yeah.
gonna be like an operationally licensed aircraft with one of those appendages, it would at least be heavy if it wasn't a super.
Yeah. I think that's probably safe to say.
Yeah.
But yeah, I'm not sure either offhand.
So, James, since you're here, I'm going to ask you about kind of what specifically you're looking for from this test flight anyway, because you're looking at it mostly from the Talon perspective, and of course, the first captive carrier with Talon up in the air. And so, is there any particular part of this test flight, either a piece of data or a specific maneuver that they did with Rock today, or something like that, where you're most interested in learning from, or most interested in getting data from? Um, like basically a big point that's of particular interest of today's test flight for you?
Yes, definitely. So the temperatures that I was talking about, so the internal temperature of Talon, I am very, very curious about, just because I spent a lot of time working on the thermal analysis, predicting what, those temperatures might be. In addition to that, the vibration levels. We're required to test our avionics to those temperature and vibration levels. And we spent a lot of time doing the analysis to predict the vibration levels. So I am very curious to see what our captive carry vibration levels are going to look like, and if they match what we think what we predicted them to be, or if we were, off a little bit. But the cool thing is we can always kind of tweak our models to match that. So when we predict, the next flight or the next vehicle, our models will be that much more accurate. But probably those two things, temperature and vibration or flutter data, is what I'm most interested in.
Gotcha.
And a bit earlier, we were talking a little bit about Rock's performance and how how the G forces are different when you're not within center line of the vehicle, when you're doing all these various maneuvers, but Talon is in the center line. So Talon has like from the forces it experiences in terms of like G's as you're rolling around, turns and everything, is Talon more benign than what the crew would experience on Rock in that regard?
Yeah, I would think so. Just thinking about it from like the explanation that Grace gave earlier. Talon is kind of more, like you said, in the center line, kind of in the neutral position, right? Um, and the pilots are more, here's an engineering term, cantilevered.
Yeah.
So they're further away from the center of the vehicle, right? Um, so yeah, I would think that you might experience fewer G's where Talon is than in the fuselage, depending on the maneuver that the vehicle's doing. But we'll know after this test because we're recording all that acceleration data. So that'll be really interesting to look at.
Yeah, because the pilots are kind of out on a cantilever, they know they're the NZ thing.
They bounce
yeah.
a lot more.
Yeah.
There's some bouncing around.
Nice.
All right. I do have another question. This is another rock question as well. Adam asked, does the left fuselage need to be ballasted in any way? Is ballasted the right past tense of that word? I think so. Does it need to have ballast, I guess, in order to offset the equipment for the cockpit? Like, basically, if you just put the equipment that each fuselage has, is one heavier than the other? And if so, do you need to ballast that out? Or is that just trimmed out by the control services?
That's a great question. I think ballasted is the correct past term of ballast.
It sounds a little
Also,
weird, but I don't know
ballast.
what else it would be.
Ballast is plural of ballast, right? Yeah.
Yeah.
Yeah. You put one ballast, you put two ballasts. Mm,
Oh, the English language.
okay. Those are questions that are too hard for us, but we can answer whether you need ballast or not. So the right hand, left hand of rock. Yeah, there's some weight differences. You want to go through what they are? So obviously there's the crew, but let's say even if they weigh like 300 pounds each, that's 900 pounds, which Rock doesn't care about. But let's say they're 1,000 pounds. What else is asymmetric? Because we've got some asymmetry. There is more equipment in the right-hand cabin than the left. Engines are symmetric, gear symmetric. I mean, there are more flight control cables running in the right-hand fuselage because they're going from the cockpit to the center wing, whereas in that area of the left-hand fuselage, there's no flight control cables. So yeah, everything is pointing towards right heavy a bit.
Do we balance the left more?
So we don't have to. The so let's say it's 5,000. It's not 5,000 pounds to the right, but if it is, then
Grace is doing some math here.
then that's yeah. Oh yeah, yeah. So if rock is about 500,000 pounds today, empty is about 500,000,
Oh, wow.
and then we've got fuel that's like 200,000, so it's really 700,000.
It's just a very small
So
percentage.
It's less than 1%. Yeah,
Oh,
it's
so,
less than
okay.
1%.
So it's negligible on
Yeah.
the performance of the aircraft, I guess is what.
Yeah, but that's percentage weight. So what we really care about with center of gravity is moment arm too, because 1 pound out at the very tip of the wing is a lot more powerful than 1 pound. That's
Right.
1 foot from the So that's the moment thing we were talking about, but it's 50 feet out. 50 feet out, 5,000 pounds. Yeah, 250,000 pounds. 250,000 foot-pounds. That's, yeah. When we're talking rock terms, that's nothing. And for example, we know what today's CG is. It is not 0. It's a little bit off center line. Let's look it up.
So yeah, so
think I
then
have
on
something.
individual flights, you would trim out whatever little offsets there are for particular test flights, right?
You know what? We should ask the crew.
I
If
was
it's like
thinking that.
0.2, if it's 0.2 inches off of center line, I don't know if they even trim.
They probably don't even have to trim.
Yeah, they might not even have to
They
trim.
don't even notice.
Yeah, and you're talking about trimming with aileron, right? Like setting the aileron
Yeah.
0 to a little bit right or left. Yeah,
R-
they might not have to.
Interesting.
Yeah, so let's see.
It should have, I think it's on the fuel table. Right. Nope, that's fuel weight.
Here, it's shuffling some papers. Hold on, just 1 sec.
Again, just a quick reminder for those who may just be tuning in or tuning back in after takeoff a couple hours ago. Let's see, we're up to like just under 3 hours of today's test flight so far. Rock currently flying back towards Mojave along the test corridor, completing more test cards. As soon as it starts making, of course, approaches to Mojave, we'll update on that. And that'll be obviously an object of interest. Previous flights, there were definitely low approaches prior to landing, so I think we'll expect more of that. But again, that comes after the in-flight tests are complete. So we'll keep you updated on that, but we are also taking your questions. So if you tag at NASA Spaceflight in chat, we're pulling those out and we're able to answer as many of those as we can. In addition to the normal NASA spaceflight voices that you're hearing, we've also got Grace and James, both from Stratolaunch themselves, taking questions, and they're, of course, the experts. So feel free to send us the questions.
Yeah, I found where it was. Okay, so I was about correct. The no fuel weight's close to 500, a little bit over 500,000 pounds, and fuel weight's around 200,000 pounds. So total is a little over 700,000 pounds. So our YCG today is a couple inches actually to the right. And going back to how much, if we're trying to gauge ourselves on how much we care about the asymmetry of we have pilots in the right hand and no pilots in the left. What are the other differences right and left? So we were just estimating, hey, what if there's 5,000 more pounds in the right hand fuselage than the left? And that's at a 50-foot moment arm. We can just do real quick math saying, okay, if that's mx moment around the x-axis. And so if your ailerons are, let's say 100 feet out, so twice as far as the fuselage is, then you would need 2,500 pounds from the ailerons at that arm to counter that weight. And
Right.
since you have two sides, then split that, it's 1,200 pounds, 1,200 pounds from each. And that's, I don't know what the order of magnitude of ailerons is. I'm pretty out of that loop right now, but that's pretty low. That's well within the capability of our flight controls.
Gotcha.
So long story short, nope. Rock does not care, but we have the capability to ballast the fuselage differently. We have a spot for nose ballast on both of the fuselages, so that will that'll move your CG forward, and that can also get you right and left.
There you go. All right. Sounds good. Thank you so much for that. I'm going to keep going through chat and seeing some questions. We got one here from Pierce asking how much the wiring and electronics on board. Well, I guess they don't say on board what, but I guess we can extend this to both Rock and to Talon. Basically, how much of that mass goes towards the avionics, for example, James?
Yeah, really good question. For Talon, it's a pretty small percentage when you consider things like propellant, right? The propellant mass fraction, of course, is pretty large and has a lot of propellant on board. Avionics are, they're not that heavy, maybe a few hundred pounds. Rock, on the other hand, of course, a lot heavier, a lot more avionics in rock, a lot more batteries. But I'm not sure the number on rock. I mean, I would say several thousand pounds of avionics and in wiring.
Yes.
Yes. Maybe tens of thousands of pounds.
Yes, when I did weight and balance, this was in 2013, back when nothing existed and no systems, and you have assumptions, and I don't remember how much they were, but definitely multiple small airplanes worth of wiring.
Yeah,
inside
there's a
Rock.
lot of copper. I mean,
Yeah.
I did a lot of the original wiring for avionics on rock, and some of the wiring bundles are, they're huge. They're several inches diameter,
Mhm.
300-400 feet long.
Yeah.
The wiring alone, is a big portion of it.
Yep. And just to scope how much touch labor there is. So somebody had to make all those wire bundles and tie them together. But
Yeah.
not only that, you had to route it through the airplane and support it what are your standards? There's some specs that you say
6 to 12
has-
inches
yeah.
or so.
just standard aircraft.
Yeah.
Like
A fun
rules.
fact would be how many, what knot do we tie? Maybe a clove hitch with a overhand on top?
oh, how many of those
How
knots
many
there?
clove hitches with
Oh,
overhand
my.
knots on top?
That
are
would okay.
on
let me write
rock?
it down. Is that
Using the
is that kind
standard
of-
and like the length of wire.
yeah. Okay.
I
love
love
how you
all of
fear
these
when
stats that we
Grace starts
get.
doing math. Every time she
Yeah.
starts doing math, I can tell.
And she's furiously writing down stuff over here right now.
This is
I'm like, we don't have to
later.
wonder. We'll know.
It's only a matter of time.
Oh, all of my math is order of magnitude math. Like if I'm in the right order of magnitude, that's about where I'm trying to get, not
Yeah.
random numbers. So please don't. Well, that's fine. Nobody can get any information from this feed to helpfully design another rock. This is not useful at all.
I don't
tried.
recommend it.
I tried to
He
design another
tried.
rock, but it had a bunch of slots to put Miatas in it for some reason. I didn't understand the
Yeah.
specification.
Oh, we were. We could even have those parking garages where space is at such a premium that you park your car and then it's in this little conveyor belt that
Yeah.
Oh,
what,
yeah.
what are those called? Just so that you can get another level.
Yeah, I don't know.
Yeah,
I've
you know
seen
what I'm
those,
talking
yeah.
about, right? Yeah.
Yeah.
Are you thinking what I'm thinking? Just put that on put that on rock. So that when you order your Miata, you don't have to wait for the one that you want to come out of the pack. It's not at the bottom of the stack.
Right.
If you want yours at the bottom of the stack, it just is a revolving Miata dispenser.
Yeah.
Like a
Yeah,
rotary
rotisserie.
Miata dispenser.
Yeah.
Yes. Yes.
Wow.
That's pretty great.
Exactly.
I'm speechless.
That's what we need to do. Yes. Okay, so Jim Boyd, our electrical engineer, I was seeing if he had some time to give a quick answer, think about it. Okay, because one metric that we used to have is not weight of wiring, but miles.
Right.
So we said, how many miles of wiring are?
I thought it was more than that, though.
Yeah. Jim is saying we last remember using about 100 miles, probably. Well, and that was before pylon, so probably more with
Yeah.
pylon.
So
stuff now.
easily, a fun analogy is from where we're sitting, probably all the way to like central LA-ish, right? Like 120 miles. Give or take a little.
Yeah.
But you think about traffic, it feels like that's really, really far.
Yeah. So how long would it take you to walk the length of wiring? How long would it take you to walk the length?
Average walking speed is like 2 miles per hour.
Okay, so let's say 50 hours.
Yeah.
So 2 full
Couple
days.
days.
A little bit
Wow.
more than 2 full days of walking. So if you laid out if one day when rock is done, we strip out all the wiring and lay it all out in a line, it would take you 2 days to walk from one end to the other end.
Wow.
Whew. James, that makes me tired just
Yeah, I know.
thinking about it.
Well, you need those the wheelie shoes or whatever they're called these days. I don't know.
Yes.
There we
Like
go.
that'll help.
Double your speed. Maybe even triple.
Called Heelys.
Heelys, thank you, Jack.
Yes, Heelys. Oh, please don't sue us. I don't know if Heelys is a name brand or if it's like the generic, like a sandwich bag versus a Ziploc bag.
Yeah, I think it's a proprietary eponym, so it's
Oops,
like
okay.
Band-Aid or adhesive medical strip. So we'll
Okay.
go with wheeled shoes, I guess. Wheelie shoes.
Wheeled shoes. Yes. Oh, another of our avionics engineers on rock for a long time, Mike Jaster, says like 180 miles.
Ooh.
That actually sounds, yeah. But that is the order of magnitude. We're talking orders of magnitude. So it's not 10 miles. It's not 1,000 miles.
Yeah.
180.
Yeah.
Hey.
I was hoping we could say, oh, it would go around the earth.
Next.
But that's always a fun one.
Okay. How much would that weigh? I guess what gauge, just assume some gauge wire going around the earth. We can see if
my
rock can even carry that. I think that'd be too heavy for rock. Wait.
Oh no, my TI-89 is dead too. It's catastrophic.
The horror.
The horror.
You thought it would never quit on you. Okay, honestly, the kind of math I do, and I always do it on Excel, even a dumb calculation because I don't have a calculator anymore. And I always have Excel open. Okay, so we don't know that one. Sorry, guys. Next question.
No worries. That's funny though. Oh my goodness. All right. Let's see what other questions we've got here. Oh, here's a good question here. Does Rock use a differential throttle at any point in its flight? So throttling the jet engines differently from one another for any sort of control authority.
Yeah, that's a great question. Super fun too. I don't know if we've purposely used it for like yaw trim before. Do you know if we have, James?
I don't know. I've only ever seen them increase it or decrease it, simultaneously, but that doesn't mean that they don't do it the other way.
Yeah, I know you kind of tweak one up or down because the engines aren't the same either. They're all like slightly different.
You do have to trim them.
Yeah, so the same lever setting for all of them might not equate to the same thrust for all of them. So I know there's that tweaking, but I don't think we've done like, full engine thrusts on the right and on the left on purpose to see what happens. But that is a procedure that we have, an emergency procedure for an engine out. That's just the normal thing.
Oh,
to do.
sure.
Yeah, if you have an engine out on the left side, then you like turn off the. Actually, no, you don't shut your engine down. You throttle down on the other side to make up for it. Pretty nice about having 6 engines. The more you have, the less critical it is for each engine out. Like if you only had 2 engines, 1 engine out is pretty annoying. But 6 is less annoying.
Yeah.
Right, sure.
Just as a percent of yawing moment metric.
All right, gotcha. All right, let me see what else is going on here. So it's 11:30, so we're a little over 3 hours into the flight right now. See the chase plane on the bottom left-hand side of your screen as well as both Iraq, which is carrying Talon-A. Specifically, it's carrying TA-0, which is the separation test article for the Talon hypersonic vehicle, under the wing of Iraq. And there's a citation chase plane following today, as the test flight has been going well so far. Lots of test cards already checked off. We saw some pitch captures, some NZ captures, saw some yaw captures as well. They were talking earlier about the test card about receiving telemetry from TA-0 through ROC.
Yeah, we
Does
did
that
some.
telemetry go only to ROC, or does it also then get transmitted down to like ground control?
It does both. So we send talent data up to ROC so the crew can monitor it. And we also send that data directly from Talon back to the ground station.
Right, okay.
So the
And
crew
so it's
can
not
monitor.
relaying through ROC to the ground station, it's going directly from Talon.
It's actually doing both.
Both. Oh, okay. Yeah.
Yes, parts of it go both ways. All of it goes directly from Talon. So there's some redundancy built in there with different transmitters, different antennas, and that kind of thing.
Yeah.
So yeah, short answer is yes, both.
Are there
Right,
differences
gotcha.
in quality, like rates and stuff, James, for what you transmit directly from Talon to control room or from ROC to control room, or what's stored on ROC because your data gets stored on ROC?
Yeah, typically we would log data on board at a higher rate. Kind of like we were talking about reusable vehicles versus expendable vehicles with logging data on board. You can usually log data at a lot higher rate to like a hard drive than you can pushing it over the air, just due to bandwidth and frequency limitations. So yeah, we definitely log data on board at a higher data rate. So the data that we pull off the actual vehicle hardware would be higher rate data.
Yeah, so when we were talking previously about the control room engineers and they're looking at their parameters live right now, but then they'll go home, take a nap, maybe, next day, then go look at their parameters and do some data analysis. For that, are they going to be looking at the data you pull from Talon or ROC? So they're not using telemeter data from the data, right? You get the
Exactly. We
download.
usually look at the ROC data or the aircraft data. So the high rate data logged to the hard drive on board the aircraft.
Yeah.
And it's nice having that redundancy because if there are little blips or misses in that data, you can go look at your other data source that maybe you got over telemetry and fill in those gaps if needed.
There we go. So yeah, so different test objectives that have been checked off on today's flight so far. ROC and Talon flying together. Well, not really flying together. ROC carrying Talon at an altitude of a little over 22,000 feet. That's been the higher of the two altitudes we've seen the aircraft at so far. And yeah, things going well. Currently out northeast from Mojave, out over the desert. It's kind of the normal testing corridor we've seen on previous flights as well. And this is a captive carry test, so it's characterizing how ROC flies when carrying Talon and also how Talon does in that environment. And this will set up for a couple more captive carry flights that will precede a separation test. So you guys want to kind of walk through what the separation test objectives are? Because that's going to be the next big milestone after the captive carry campaign.
Yeah. So like you said, reorienting ourselves, we're testing TA0, our separation test article. We're nearing the end of the TA0 test sequence. We did a lot of TA0 by itself and ROC by itself, and then some integrated testing, engine runs, taxi testing. This is the first mated flight. That's why we're all so psyched. And then there's a series of mated flights and then the drop of TA0. Then we go on to TA1, the hypersonic test vehicle, and TA2, etc. So that's where we are in the picture. James, you want to tell us about what happens on the TA1 drop flight?
TA1 or
Sorry, TA0. Yep. Let's not get it.
So TA0 will be unpowered during its separation demonstration. It is a separation demonstration test, so our intent is to demonstrate that we can safely separate the vehicle from rock, and it clears the vehicle in a stable, kind of safe way, right? So we want to verify and validate our predictions, which means we want to make sure that the way it falls away, right, pitching up, pitching down, yawing, or not doing those things, we want to make sure that that matches what we predicted, so that when we get to TA1 and we drop TA1, we know it's going to drop in the way that we want it to, stabilize, we light the rocket engine, and then it can go perform its mission. So this is really a stepping stone to that TA1 first hypersonic vehicle, which we plan to fly early next year, first quarter next year.
And this first test there's a lot of different test points. One is just to go find out what we don't know. Like everybody says
Right.
unknown unknowns. You're like, what does that mean? Unknown
It seems
unknowns?
redundant, but yeah.
Yeah. But there are known unknowns. There's some things that we know we don't know.
Right.
And we're going up intentionally to find out. Then there's the things that we don't know that we find out.
Yeah, along the way of finding out those known unknowns, we find out
Yes.
the unknown unknowns.
Yes. Our known unknowns are we don't know what the strain gauges are going to read on
Exactly,
Talon.
yeah.
We don't know what the flutter.
Vibration.
Yep, we don't know what the flutter response will be. We have predictions because of our analysis, but we don't know. So we know we don't know. We go find that out. And then there's other things that we might find out that we didn't know we didn't know.
Yeah.
All right. Let's see what other questions we can pull out of chat here. Let's see. Oh, here we go. Is rock fly-by-wire?
It is not fully fly-by-wire, so it does have electrically signaled parts of it, but it's primarily mechanically signaled, hydraulically actuated flight controls. So it literally has flight control cables running to the control surfaces where there are hydraulic actuators, but parts of it are electrically controlled as well to make it easier to fly. So it's kind of a hybrid. You could think of it like that. So you get the reliability, from a, more of a mechanical system and simplicity from that system, but then you get the performance of a electrically signaled system as well.
Gotcha. Getting a couple other questions here in chat. Again, I'm going to just keep reiterating this, especially for people who are just joining. Tag us at NASA Spaceflight in chat. That helps us see your questions and we can get them asked and hopefully answered here. Let's see here. Philip asking, could an auxiliary power unit or an APU be used to generate the hydraulic power needed to raise the landing gear? I believe we may have touched on this before. Correct me if I'm wrong. Do you ground start the engines on rock so there actually isn't an APU, or am I mistaken there?
You are correct.
Hey, I remembered
So
something.
if we had an APU, theoretically, yes. We use a heifer cart right now to start that first engine, and then we use pneumatic air from that first engine to start the others. But yeah, no APU. We have one in a box from 747. We might even have two. That would make sense, right?
Yeah.
Well, I would hope you have two. Otherwise, one of them was missing one.
Somebody made off.
I was about to say
There's a
something.
random APU missing here.
They just quit, took an APU. That would be pretty impressive. If I were you, I would just let them have it.
Yeah, it's like, I think I've seen it too, and doesn't it look kind of just like a big turbocharged like jet engine thing?
Yeah. Well,
That was my avionics
it's in a crate
way of
right now.
describing a jet engine.
It's in a crate right now, so you'd have to kind of like know
Okay.
which one it was in to find it. But yes, APUs can do that, but actually one APU could not produce enough hydraulic power to raise all of our landing gear at once. So no, we would need more than one APU. That's what my gear person was telling me.
Oh, wow.
I didn't ask how many APUs. We could go there too. But yes, theoretically, if we could separate the gear and cycle them only one at a time, we could, but they aren't sequenced like that currently. So you'd have to actually go in to the system and change some things, change some valvage before you could actually cycle them one at a time. And that's what we had to do for Flight 3 when we wanted to raise the left mid main gear only and not the others. But normally in the middle of flight, you can't just like hit the single gear option. That's not a thing. Great question.
There you go. All right, let's see what other questions we've got here. Oh, here is a good one. Does Rock have an autopilot system?
James is plugging his laptop. I'm going to give him a sec to get back here so I don't have to answer that question.
Okay.
James is much better for that.
It does. Well, the short answer is no. It does not have an autopilot system unless the pilots have like, I don't know, one of those maybe one of those sticks that you can like wedge on the steering wheel so it holds it where it's
a
supposed to
very
be.
analog autopilot,
Right.
where you literally just stick the yoke in a certain position.
Right. But no, it doesn't have a autopilot in a traditional sense like a 747 or something like that would have.
Yeah, okay. And what other questions we got? Oh yeah, this one we can come back to here. Asking if we've covered the fuel that's used in Talon. We have touched on that, and we talked about how the rocket motor on Talon-A is going to be fueled by Jet A kerosene, not RP1 kerosene, which is more common in rocketry, but Jet A kerosene and liquid oxygen. And I'm going to expand on that question and ask, do you know kind of what went into that decision? Was it the commonality between obviously jet fuel for the actual carrier aircraft, or was there another reason that both Stratolaunch and of course Ursa Minor, Ursa Major that's supplied the engine. A reason that fuel
competitor company called
I did not
Ursa
mean to
Minor.
diss Ursa Major in that sense. That was just me misspeaking.
Yeah, that's a good question. I don't know the engineering answer to that, but I've been around the propulsion engineers long enough to know that there is a lot of trading that goes on into designing a propulsion system. I mean, there are bunches and bunches of different propulsion system options. You can use solid rocket motors, you can use hybrid rocket motors, you can use any kind of variety or flavor of liquid rocket engines. So it was probably a trade, I would think, between performance in terms of thrust and specific impulse, possibly constrained by what the engine could use was maybe part of it, and then trading that against mass of your propellant, volume required, and how complex the system would have to be to support that, and then trade that against, okay, well, how long do we have to actually build the thing, and kind of see where where all that falls out, where that shakes out. I imagine they did something like that, but I don't have the exact answer.
All right. Yeah, it's interesting because what the design priority was it all right, we want commonality in fuel, so we're going to make sure it's a Jet A engine. I was like, okay, we need an engine that can be developed quickly or already exists, so we'll go to Ursa Major and it's like, all right, what do you have? And we'll make it work with Jet A. We'll flush out the supply chain to support a Jet A engine for Talon Ops because that's the engine that exists or whatever. It's interesting how that works out on different programs, so it's cool. All right, another question here. How many pilots are qualified? Qualified? Oh, geez. All right, it's been like a 4-hour stream at this point.
Nice. I heard that.
How many
I
pilots
missed
are
it.
qualified?
You said how many
to fly?
pilots are qualified.
I would hope
I
all
like
of
that
them.
even more. That's even better. Okay.
But yeah, basically, how big is the core of pilots that can fly rock on these test flights? Is the spirit of the question.
Okay. Well, qualified. I'm not sure what qualified. I can talk about, let's see, how many have flown rock.
Well, yeah, I guess
Let's
that's the
just talk
question. How many
about
people
that.
have flown rock is a similar
Yeah.
question. Yeah.
Okay. So pilots wise, okay, I'm 99% sure. For somebody in the chat, please add if I forgot or I'm wrong. So there's Evan, Thomas, Hooter, or Steve Rainey. The other one's in the airplane right now. Duff, aka Chris, I think Chris Garente, and Mark Gittro. I think those are the 4 pilots who have flown rock before. No more. I don't think there's any others. and the flight engineers have been 2. So there is Jake Riley and Brad Shab. So a total of 6 people have been in the Rock cockpit when it's been flying before.
All right, there we go.
So it's not a big cohort of people who've been in Rock. You jump
Yeah.
in and jump out. You just get your certification on Rock, on the weekend.
I probably made this bad joke before, but do you ever call it the Rock Pit?
Well, they're
We
going
will
to. They better
now.
start now. Yeah. So good.
Well, now it sounds vaguely kind of like dank and weird, gross. Like a cave, a rock pit.
Yeah.
Like it got stalactites and stalagmites and stuff inside.
We got like t-shirts. A lot of these could catch on. We may make t-shirts. If we make t-shirts, guys, we're gonna send you guys t-shirts.
Oh,
the
that would be
rock
great.
pit. Oh, I already have a design in my mind. Those would be very
Perfect.
dangerous inside the cockpit if you had sharp things sticking out from the
Yeah, it
bottom.
doesn't
and
sound like a
top.
good idea.
Also, they take forever. They take like centuries into millennia to
Yeah.
develop
Yeah, exactly.
stalactites and stalagmites, right? We ain't got that kind of time, James.
That's right. We got to fly by December.
We're trying to go hypersonic next year, so we can't wait that long.
Let's see here. Oh, so that was a follow-up question. We were talking about the corps of pilots that serve, and we were talking about the flight engineers and things like that. How big is the team in the control center, especially now that you have the Talon teams also on console for today?
That's a good question. James, I haven't been in there in a while. Let me see. Just from Rock flight tests, there were 1, 2, 3, 4, 5, 6, 7, 8. There were about like 8 or 10 stations for Rock, but now we've been able to decrease that because at the beginning of test, you need a lot of monitoring and you don't know how your systems are going to work. And as your system Rock gets more mature, it needs less babysitting. So I think those stations have reduced and the town stations have increased. And
Yeah.
there's some more rows in the back. Do you know how many there are?
How many? Probably 8 to 10 Talon stations now. Well, if you count maybe 6 like subsystem stations, and then we have other stations as a result of having a combined team now. So it did, overall it definitely grew. I mean, you walk in there and it's a lot busier, a lot bigger
Yeah.
than it was.
I
2 or 3
sent
years
a
ago.
quick in there to see if anybody was and could answer. So how many stations are in the control room now? Okay. The answer is millions of hundreds.
Like
Stations.
total station?
Yeah,
Too close to the mic.
millions of hundreds. No.
Oh, that's actually what he said.
Yes, that was the answer. That is not a helpful answer. I would say 20 to 30, something like that.
Yeah.
James, right?
Got it, 20 or 30.
Yeah.
So it sounds like flaps are coming down, and gear coming down.
Yeah, I
Oh,
can't see
alright.
the gear yet, but I can. Also, I don't know if it's the power of suggestion, but I think I can see flaps. But it
Yeah.
might be power of suggestion, James.
Right, sure. But okay, so starting to move
Yeah,
back
gear-
into a less clean configuration then. Does that mean they're getting to the last couple of cards, or is there cards that they're going to do at altitude with those things deployed, or?
All right, gear is coming down right now, or it's supposed to.
Imminently. Definitely see it pitched down. Rock is
Yeah.
definitely pitched down.
Yep, we're in a descent. We're descending 7,500 feet. Don't see gear yet. It might be how we're looking at it, though.
Should be down.
I can kind of see it. It's almost the shadow of a thought on the
Yeah.
screen.
See if they just fly closer to Mojave and stop running away every other turn, then we'd be better.
Flight crew, please prolong your cards by making turns twice as often as you have to
Yeah.
right now. Just so that we can have a better view. That'd be great. Thanks.
I mean, alternatively, we can just put cameras on the other side. Just saying. More cameras is also a solution to this problem.
Yeah.
But Rock is flying back to the back toward Mojave for sure.
Yep. Yep.
And hearing
Oh,
callouts that the
looks-
flaps and gear may be getting deployed. And yeah, I do see
Yeah, I think
what
I
could
see
be
his
landing
gear.
gear.
I think so. I think I can see it.
Yeah, I
in
think
kind
I
of a-
agree that the
a
landing
s-
gear are definitely confirmed down from this view.
Yeah.
And it
And
looks
so
like
are they on
Okay.
their way back to begin approaches now, or are there more test cards before that happens?
No, we are descending for approach, so we'll do a couple approaches. The normal thing with airplanes. So we'll do at least one or two, a couple approaches to land. So that's just intentional practices, and then we're
Sure.
gonna land.
Fantastic. So that sounds like they have wrapped up mostly a successful day of flight test then. All right, let me take a look at some. Okay, we're going to keep pulling questions and things like that. But as a quick update, we've got Rock on the way back to Mojave. Sounds like the landing gear and flaps have both been deployed, and as Grace mentioned there, Rock is actually on its descent to begin approaches. And so if you've seen previous coverage of previous test flights on Rock's test flights, a couple approaches before they actually begin to land. So they'll do a couple low approaches over the runway, and that's just, like you said, it's just practice for the flight crew, right? It's not really even a test objective. It's just this plane doesn't fly super often, and it's still pretty new. So from helping get the flight crew more familiar with how the plane handles, is that a fair way to describe that?
Yeah, flight crew training is one of the points. But even if the flight crew were fully trained and we just did it yesterday, we would probably still do one or two approaches just because the day is different. So if they're all trained up, you still want to do it again because your wind is a little bit different. Your I'm blanking, altitude, your density altitude. Density altitude is different. Yeah, things are a little bit different. So you'll still want to do some approaches even if you're trained up, but it is a really
Sure.
good training opportunity too. Yep. Looks like Talon's still attached, and that's good.
That's good. You know, that is at least one objective of a captive carry is to continue captively carrying it the entire time.
Didn't try to escape over the desert.
Yeah.
Yeah. I could have gotten really excited. Be like, listen, I'm a hypersonic test vehicle. I want to go hypersonic and just on its way.
It's just a racehorse. It's just like let me
Yeah.
let me at him, bro. Like this. It's like no, not yet. Let's baby steps. Let's do some baby steps.
To be fair, like you said it right after it lifted off the first time. I mean, that was as far as Talon's ever gone. Talon hasn't even flown period before, so Talon's having a good time. I think.
Woo! So fast, so high.
Fastest it had gone before that was probably just rolling between hangars.
Yeah, probably at normal walking speed, a little bit less. So what did we say that is? 2 miles an hour?
Yeah, like 2 or 3 miles.
So
per hour.
the maximum airspeed Talon achieved before today was about 2 miles per hour.
Yeah, maybe plus some wind. So let's say 5.
Plus some wind.
Maybe.
In fact, if the wind was going the wrong direction, might have just been negative airspeed.
That's true. It could. Oh well, yeah. I don't know if it was the first time we were rolling between hangars, but some of the times rolling between hangars, we had people out there like holding up shields.
Yes.
Oh yeah.
In the wind.
I think we parked.
We
parked a bunch of scissor lifts and made like a
yes.
Oh really?
Yeah.
So the area between the T hangar and the fab hangar, we call the big hangar the T hangar because it looks like a T, and the little one is called the fab hangar. We do a lot of fabrication in there. So there's some space between the two. For like however that's oriented, it becomes a wind tunnel in there. Well, on windy days, it's way windier in there than anywhere else. So you walk between the buildings and you're like leaning over so you don't get blown away. And that's the expanse that we had to push Talon across. So the Talon team had to make little barriers, make a little tunnel, some shields so that one, Talon wouldn't get like blown, but also so stuff getting blown in the wind didn't hit Talon.
Yeah.
Yeah, sure.
Guess we could have just chosen a different day, but We're pushing
Yeah,
forward
you got schedules to
pretty
meet.
hard.
We get it.
Yeah.
We got enough scissor lifts.
Yeah.
Like a tunnel.
I didn't talk to Nikki or ever. I don't know if that. I imagine that helped, but I don't really know what the
Yeah.
verdict was there.
All right, let's see here. Here's a good question here from Andy. Since on a long flight test like this, and then since the controls are all manual flying, do the pilots ever swap seats during the flight for crew resource management? So like
Ooh,
distribute the load between the flight crew.
yeah, crew resource management is a thing. Totally. They don't swap seats, but they do swap who has to hold the controls. So each of the pilots
Right,
has a
okay.
yoke. Very convenient. So they don't have to swap seats. So it's not like when you're, when you're on a long road trip and you and your buddy are like, okay, can you take over? I'm getting sleepy. But you don't want to stop the car because that would just take too long. So you kind of have the other person hold the controls. You crawl out of the front seat into the back and they crawl over to the left. No, we don't do that.
Wait, you've done that?
No,
guys?
no, like you do. I haven't done this, but like one does theoretically. We don't have to do that in rock because there are 2 steering wheels. So they do take turns, but they don't have to swap seats.
There you go.
But they don't take turns with the FE. They do not let the FE steer the plane.
Okay.
At
Yeah, what's
least
the flight
not-
engineer's primary responsibility during these flights? Are they just monitoring systems or?
Oh, great segue.
Yeah.
Great segue. What is the FE doing? So there's a drink cart, hot meals, like
Snacks.
some Perrier,
refreshments.
opening the cans. The FE's role on rock is really important because there are so many complex systems, and a lot of them, there are no controls from the ground, so there's nothing that the control room can operate on rock. If you need to do anything, the FE has to do it, or the pilots, but most of the controls are at the FE station. Some examples,
Like
James? There's
transferring fuel,
yeah,
turning different pumps on and off,
Yeah.
controlling
different
ECS, environmental control system.
Yes, changing the altitudes. Usually the ECS is kind of preset, but you can change the temperature that the ACMs are doing. The air cycle machines, there's the vapor cycle system. You can turn that on and off. There's pneumatic system controls. You can you usually don't have a reason that you need to close valves and close off different parts of the pneumatic system, but the flight control engineer would do that if there was some sort of anomaly, you wanted to isolate part of the system. So a lot of it is normal ops and monitoring, and there are things that they have to do, but then there are also a lot of off-nominal ops where if something happens, they have to know what to do, and there's
Yeah.
a million, millions of hundreds of
Millions of
switches that
hundreds.
that they have to go operate. And the FE is the one who can reach like circuit control, like some breakers. So if you need to reset stuff, if you need a breaker pulled, then
Yeah.
Then-
There are tons
yes.
of circuit breakers.
So the control room communicates with the flight crew. So if the control room is like, oh, my parameters, I don't know, this one box kind of pooped out. I would like to reset it. Can you please cycle the breaker? So
Sure.
the FE has to do that. So lots of things. There's
Yeah, well, the electrical system too is pretty complex. So you can switch between different buses, DC, AC, essential buses,
Gears coming up.
etc.
okay. So
Sounds like gear is about to come up pretty soon.
yeah.
They're gonna raise the gear again? Oh yeah, there they go. So is that another test objective that they have now that they're closer to the airport or something?
They did have a cycle in the test cards.
Yeah,
there's
part
okay.
of the test cards.
Yeah, there's another test point they need the gear up for. Let's see, what is that?
When the gear handle up, then off. Brake checks.
Okay,
and then
there's
flaps.
there's a trim shot, so I guess you want another clean trim shot.
They're getting a great view, great sight-on view of the aircraft now, though. It's flying a little lower and it's closer to Mojave now. Still got that chase plane that's been tagging along all day, doing its job as well.
Yeah, good job, Chase. One of the the main
Did we
thing, the
decide-
number one Chase thing is don't like hit the airplane. Don't get too
Right.
close to the airplane. And then it has a lot of other jobs. Did we talk about Chase today? Like, why
I
do we
don't
have
think so.
Chase?
What else is? I mean, you did mention that there were some engineers on board that were actually looking at monitoring certain things from the chase plane.
Hmm. Yeah, the other roles are pacer checks when you do a trim shot or you're straight and level on rock and you're targeting a certain speed and altitude and the pilots think they hit it. They're like, okay, we're on condition. And then Chase comes up next to them at the same altitude and
Mhm.
speed. And you kind of see what the chase airplane is reading versus rock because you've got different rock. There's like a couple different sources of input data for speed and altitude. There's, your air data system, there's GPS, there's different things. And then your chase plane can be just another verification source, especially since it's a certified aircraft, so it gets its pitot-static system checked at least every 2 years or something. So we're pretty sure that's correct. So you can check rocks against that. Chase also flies down with rock and just does general visual awareness. So you're looking for anything weird, like fluids coming out where fluid shouldn't be coming out,
Mhm.
either like fuel or hydraulic fluid or uh, things flapping in the wind that shouldn't be flapping, anything
Sure.
structurally weird. Gear, when the gear were coming up and down, that's an important chase role to confirm with the pilots, like, yep, the gear that you thought came up are up, all the doors are closed, it looks clean. So yeah, all the clean and dry checks. And then also doing wheel height calls. Chase does those, right? Right, James?
Yeah, during
Like when
landing,
you're
right?
close, yeah, during landing, they'll call you like 50 feet, you're 10 feet, you're 5 feet. Yeah, Chase has lots of jobs.
Yeah.
Number one, stay out of the way.
Right.
But it's a very integrated part of the test plan and the test cards. So when you're doing the test briefs and everything, walking through the cards, you're always, if there's a chase need in that card, there's always a brief of like, okay, where is chase going to be? Forward and up, or like aft and
Yeah. Okay.
lower? What are you looking at? Like, how are you going to maneuver to get chase to the next spot that it's supposed to be in?
Yeah, and I don't know if you said it, but one big thing that Chase is probably doing today is monitoring Talon, looking at Talon
Mm-hmm.
to make sure, it's nothing out of the normal is happening with it. But yeah, that's got to be cool flying in formation with the biggest airplane in the world.
Mm-hmm.
Probably a lot of.
Yeah.
That's a fun job.
Everybody's in chase, like, yeah, has a great time. They come back with all these great pictures. Like, look, it looks like they're
Yeah.
5 feet from rock.
That's awesome. All right, so yeah, the gear came up now, and it looks like can't tell. I don't think the flaps are down anymore either, unless it's just I can't see because it's in like the shadow of the wing there.
Yeah, it looks
Yeah.
like one of the steps in the cards was to retract the outboard flap, so that might be what we're
Okay.
seeing.
Can they actuate? So they can actuate the outboard flaps separately from the inboard flaps then?
Yes. And it's, well, kind of a misnomer. We call them outboard inboard, but the inboard set is actually, so there's right hand, left hand. Let's talk about the right hand ones. There are 4. Oh no, there's 3 inboard of the fuselage and 4 outboard of the fuselage, I think. And we call the 2 inboard of the fuselage, oh no, it's 2 and 5. Yeah. So the 2 inboard of the fuselage and the 2 outboard of the fuselage, those are called inboard flaps because they are relatively more inboard than the outboard
But they
flaps.
split the fuselage.
Yeah,
Oh, I see what you mean. Yeah.
But some of them are outboard of the fuselage. And then the set of 3 that are outboard of that, those are the outboard flaps. So yeah, there's 2 settings, inboard and outboard. But there are no angle settings. Like you said, it is 0
Yeah,
or
it's just
70.
0 or 70.
Like,
Yeah.
when you mean it, you mean it.
Yeah. Gotcha.
Yeah, and as who reminded us, those are 747 gear door actuators that we use for our flaps.
That was shout out to Hugh Shane.
Hugh Shane, thank you, Hugh. Yep,
Good friend Hugh Shane used to work on the program.
yep, we're using 747 parts, but not always in the same place.
Right. Yeah. Certainly working though.
It appears so.
And so this test is, so you mentioned something about a trim maybe test point where you want the aircraft back in a more clean configuration in order to meet that point.
Yes. Yeah, and I'm told we did complete that trim shot clean. Now we're up to. I've never seen it. Shortened like this. POPU. It's pull up, push over. Yeah, push over, pull up. I've never seen it abbreviated like that, but it is in these cards. So we're gonna do a push over, pull up.
What
So
do
like
we
a
normally
short
just write it
descent
down?
followed by pulling back up am I understanding that right?
Yeah, I don't know how quick the reversal is though.
Yeah.
I don't
Well,
know
we'll
if
have
it's
to
like
watch.
push over 1, 2, 3, 4, 5, pull up, or if it's a push over 1, 2, pull up.
All right. See if there's a. Oh yeah, Oscar with a question about the engines that are on Rock. We mentioned there's 747 engines. Do you know, like, so what's the actual? Because I think even 747s have had some different, like specific engines. Like not all airliners have the same engine all the time. So do you have? Oh, there's that pull up, by the way. I should point that out first.
Yeah, okay. Yeah, they're Pratt & Whitney 4056s.
Gotcha.
I'm
Okay.
glad you remembered that.
Yeah, I know.
I knew they were
because they're
Pratt and
on the
Whitney's. I
pneumatic
could not tell you the
system.
model number though, so that's why I was leaving it to you.
Yeah, it's 50 some thousand pounds of 50 some thousand pounds of thrust each. So it's like I think it's 360 or so thousand pounds of thrust total. He's a lot.
There you go.
Okay, yeah. So the pull, I asked Mason the push over pull up. The point of that was to get angle of attack per Mach correlation. So you sweep through, like it's an angle of attack sweep. So you sweep through angle of attack, and your Mach number changes, like aka your speed at that altitude and density and stuff. That changes, so you're getting those two numbers and getting a couple of them, so you can make that correlation.
All right. Let's see.
So the next thing we're going to do is side flips again at this lower altitude.
So that's the those like kind of yaw capture things we
Mm-hmm.
were talking about earlier.
Yep. Stabilizing at a couple different degrees of beta.
Gotcha. All right. Another question here. Does Rock have its own custom approach pattern, or is it a same approach pattern as the rest of the airport would use?
I don't know if this quite answers the question, but I'll give it a hack. So I think it's the same. GA airplanes fly in a clockwise pattern for 30. So every runway has its own, like whether you fly clockwise or counterclockwise to the approach, and that depends on what you're overflying. So it's not always the same. Like on 8, it is counterclockwise, and on 30, it is clockwise, because that overflies you on the airport and not the town. So Rock does the same thing. It approaches, it's clockwise. It's much bigger though. So
Yeah.
I guess that's how it's
I
different.
was gonna say on final. Well, to get on final, they go way further out.
Mhm.
I think
Yeah.
it seems like
Yeah. So they might not, make a perfect, like usually you think of it as a perfect rectangle. It's, 100 feet offset, however many 100 feet offset from the runway, and you have your normal points that you make. You turn crosswind, you turn downwind, then you turn base. But Rock I actually don't know if they like do the downwind base final. They might do base final, but yeah, the
Yeah.
final is real long.
yeah.
Gotcha. Yeah. All right. Game, keep chat. You can go ahead and keep questions coming here. They're going through the last couple of test objectives for today's flight, but they are making their way back towards Mojave for low approaches and landing. They're in those last couple steps now that they're back at a lower altitude. Looks like down around What does that say? Oh, my feed keeps refreshing. But down to a lower altitude, they were up. They started at like 15,000 feet for a little bit, and then they were down to, they went up to
Yeah, 22,000.
22,000. Yeah.
And now we're back down to 7,500.
Yeah, now down to 7,000.
Yep. So did we complete the side slips? We might still be in the side slips. Let me see. Yeah, we're still in the side slips.
So sorry, did you say you finished the side slips now?
Nope, we're still in the middle of doing
Still
those.
in
There's
those,
a
okay.
couple, there's a couple angles to capture.
I'm just keeping an eye on the flight radar and stuff, and the Rock's got some company in that area of the desert it's in now. Some Air Force T-38s in the area, I think. Yeah, there you go. This is that part of the country where there's just lots of really cool airplanes in the air.
Rock's way out there now too. Look at that.
Yeah. Very cool, though. All right, let's see. See if we get some more questions coming in here. So Niraj asking, how many rock test flights need to be done at this point, or are they done with? So this is flight number 8 total for Rock. First one carrying Talon on a captive carry. And then we mentioned there's a couple more captive carries coming up after this before the separation test. Is that right?
Yeah, a couple more in this series of captive carry, and then the separation test. And then a couple with TA1.
Yeah.
And then TA2.
A very similar series. TA1, and then the TA1 flight, final flight, will be our first hypersonic flight.
And then TA2.
Yeah.
The difference with TA2 is we will do multiple hypersonic flights with TA2.
Yeah, TA2 will be our first reusable hypersonic vehicle. So
Yes.
TA2 will come back and land.
Now that is the first vehicle that's, again, you're going to come down and land. Is there pretty high confidence that when that comes around, you will be able to refly it, or is that going to depend on after it lands doing a bunch of inspections to determine whether any changes need to be made before you reuse that vehicle?
Yeah, well, like any aircraft that you reuse, you have to do some kind of maintenance on it, have some kind of maintenance plan. So the intent is that we do inspections, do some amount of limited maintenance as required, and then reuse it. So most of the vehicle, actually all of the vehicle is reusable. So things will be inspected, maintenance done as required, and then we can go back out and fly it again.
Yeah.
There you go.
Yeah, pretty high confidence that we will be able to fly again, but always depends on what you find after the test.
Yep.
Sure.
Always, even with Rock, after every test we have a post-flight, even though we've flown it 7 times now, 8th time today, there's always post-flight, just to make sure there's nothing unexpected that came up.
Sure. Got some cool shots there of Rock off in the distance with some of the Mojave infrastructure in the foreground. Rock has turned back towards the west and now flying back toward Mojave once again. And so potentially still wrapping up the last couple of test cards there on its way back for approaches and landing. But still flying at around 7,000 feet altitude. And obviously we'll expect that to come down. What's the field? I gotta check the field elevation for Mojave is 2,700, 2,800 about. So little under 5,000 feet above the ground. Rock being 7,000 feet above sea level, of course. But yeah, flying on its way back. Any word on the yaw captures?
It's looking like we are still in side slip capture.
Okay.
Next up is beta sweeps.
And so, what exactly, when you say a beta sweep, can you, for people who may not be familiar, can you walk us through what that looks like?
Yeah, beta is yaw angle. So you're like, well, we just did yaw captures. What is beta sweeps? It's different. So yaw capture is when you go out to a beta angle, a yaw angle, and you stabilize there. You hold it, and then come back. A sweep, you go out and through it. So and it's let's say okay, the actual card says beta sweeps wing level, 2x degrees both directions. Yeah, the capture, you were trying to stabilize there, and the sweep, you're not.
Okay, so you're sweeping through, of course, hence the word, the different angles, but you're not stabilizing at one.
Yeah.
Gotcha. All right. What else do we have? Any other questions? Let's see.
Okay. I asked Mason if he could illuminate any, and he was helpful. So beta sweep, they're going out through that angle and seeing how much overshoot there is. So that's a flight dynamic thing. It's like some airplanes will overshoot a lot, like, and then some are super damped and they just will stop. And Mason, I think, just said it was called a deadbeat. Now that sounds wrong. Hold on. Nope. Nope, it's
That was
deadbeat.
right.
Yeah,
Deadbeat.
deadbeat was right. That sounds like when it's
So,
like like very damped, so you don't overshoot at all, it just
Yeah,
stops.
it just stops.
Yeah. But in other axes or other airplanes, you look for how many degrees until it stops. Like if
yeah,
you're
okay.
going for 5 and then it overshoots to 7 or so, then you say overshot 2 degrees before it like stops itself and came back. But if it stopped at 5, then apparently that's called deadbeat.
Now, is that a good thing if it stops at 5?
I imagine it's what you want. I think
Yeah.
it's more predictable.
Right. Sounds like
I
it.
don't know if overshoot is necessarily bad, but if
Yeah, I mean,
like
the biggest thing is probably just characterizing it so you know how the
Mhm.
plane handles,
Right.
right?
Yes.
And then you could compensate if needed, I
Yeah.
guess.
Yeah, I guess I would like prefer like perfectly damped, not under damped, which is a lot
Yeah,
of a lot of overshooting, and then it'd probably be hard to capture what you
Right.
want because you put your inputs in and don't uh they don't stop perfectly. They kind of go out, and then you have to put in the opposite input, and that might be too much. So you might
Mhm.
be chasing it a little bit if it's under damped.
we do have another question here, basically asking, with such a novel design, was there, delays or challenges with getting Rock basically, from regulatory agencies approved to fly even as an experimental aircraft? This is obviously a one-off airplane that is, like you said, novel. It's different from most of the other stuff that's approved to fly.
Yeah, so we do get a experimental airworthiness. So it's an experimental aircraft. So we do have to get a type of approval from the FAA, but it's experimental. So it's not a, like I think it's like Part 23 or an aircraft that could carry passengers.
Yeah, it's not a certified airplane.
Not a certified.
But
aircraft.
we use Part 25 rules as guidelines. So when we were building, I don't know about Talon. I think the analog would be Part 23. That's more small airplanes, but Part 25 is what like the 747 used in big commercial airliners. Is those are all the rules that you design your airplane to. So when we're, calculating loads, saying, okay, what load cases do you have to use? Like how bad is how many G's, like landing loads, what's your required descent rate, that kind of thing. We tended to use Part 25 pretty closely as a guideline, but we took exception to it where it made sense in Rock's case because we're
Sure.
kind of a different use case. We have much more uh, many more eyes on the systems for each flight than a 747 has, for example. And the pilots
Okay.
who fly it have many more hours. Um,
Yeah.
and practice on this airplane and simulators and stuff. So it's just kind of different, but in general, we try to use Part 25.
And do these test flights that you're even conducting today, does that feed into any sort of approvals for future flights or anything? Like, are you still informing certification things at this point, or is this kind of how Rock will operate for the foreseeable future? Like, I don't know how that really works.
Yeah, for the foreseeable future, there are no plans to certify rock differently that I know.
But you are, of course, I mean, we've seen a lot of the test objectives today have been characterizing how Rock handles when it's carrying Talon. So that's still that's informing how the aircraft behaves and how you can be prepared for operational flights. But it's not a certification thing. It's just a familiarizing the crew and all the engineers and everything about how the system works.
Oh yeah, for sure. No matter how rock or Talon are certified, we always want more information so that we can operate more safely and so we can validate all of our analyses and stuff like that. So
Right.
just because we're not going for something official doesn't mean we're not trying to collect all the data and learn everything that we can about the airplane.
Sure.
Yeah, so the big new thing today was carrying a Talon. So every flight we do something a little bit new. That's the whole point of going to do it and gathering data. So the new thing this flight is Talon captive carry. And while that's not a huge percentage of weight, so it's not a big, weight carrying envelope expansion or anything, it's just new stuff. So we want to shake it out, check out what the signals are doing.
Gotcha. All right, still, so you get Rock as it's flying back toward Mojave right now, flying pretty much due west after going out, and still holding around 7,000 feet. But when it came back with the gear down and the flaps out, and then retracted those for some testing, it looks like it might be descending again as it is coming back towards Mojave. Any word on those test objectives that they were looking at on the way out there and how that's progressing?
It looks like we finished up those test objectives. On to the next card now, which are angle of attack sweeps.
All right, then we're gonna keep an eye out for the gear coming out and stuff like that. Obviously, that'll be. Would we expect that to happen before any of the low approaches, or will there be low approaches perhaps with gear up?
I'm not sure offhand. I'm going to check the cards here, but it could be. They could do it with gear up. I
Yeah, they
think.
did gear, that's right, gear down at 15,000. This is geared up at
Yeah.
500.
Yeah, you're hearing Mason there, so it'll be geared down.
Yeah, I think that is a difference.
Gotcha.
Yeah, also so the last AOA sweep was at 15,000 feet, I think. So we talked about the point of doing an angle of attack AOA sweep, and that's to correlate the AOA per Mach. But why are we doing it again? It's at a different pressure altitude.
Yeah.
So we're at 7,500 feet now. Flaps are coming out.
All right.
Yeah, we're hearing flaps are supposed to be coming out right now.
We'll keep an eye on it. Again, 0 to 70 real quick. Now here's a question. This will come into play on the future flights, of course. Does Talon have any sort of flight termination system should anything go wrong after it starts its flight away from Rock?
Hold on, let's pause on that. James, sorry, which card are we on? Okay. All right, hold on.
Yeah, no worries. Yeah, keep an eye out as they check on the test cards. But you can definitely see Rock getting closer back to our cameras and flying west closer to Mojave. And they said that the flaps should be coming out soon. So let's take a look at that.
Yeah, did you see the flaps come out, James? Flaps and gear are supposed to be coming. I don't see gear yet. I'm
Yeah,
not sure
definitely
if
no
I would be
gear.
able to see flaps.
It's hard to see flaps.
Okay, flaps are now.
So yeah, you should see again. And again, when we talk about flaps, for those who are not, if you're not a plane expert, the control surfaces on the back of the wings, basically. And of course, the purpose of those is to increase drag and lift so that it can land, the aircraft can land at a slower speed than it cruises, basically. Oh, there's a great shot as it kind of banks toward the camera a bit. That's cool.
Oh
See the
yeah.
Stratolaunch logo too.
Yeah, that's cool. Yeah, earlier, James, we were talking about yeah, takeoff and more lift with more speed because you can't change your wing shape. Well, that's what I said. No, I forgot. Well, we don't have like a morphing wing, but flaps are basically like morphing your wing. Yeah, that's what
Yes.
flaps are.
Yeah.
So they change the shape of your wing. They give you more they give you more camber. More, it's like curvier. So if you're looking at, Hershey bar wing picture, it's more curvy. So that's flaps are a way to have both options. So when you're in cruise, you want it to be not so curvy, and then for landing, you want your flaps down. You've got a curvier wing,
Yeah.
so you can make lift at lower speeds.
It's kind of interesting. I'm curious if anyone online knows why Talon is shaped the way it is, with like a flap on them.
Hmm. Is this a rhetorical question, like an interview? Like you want to anybody comment, or you
I want to
don't?
see what I want to see what people say, because you look at Rock's wing and it's like a nice big airfoil, but you look at Talon and it's pictures on the internet, pictures on our website, etc. It's a different shape. So it looks like gear just came down.
Yep.
Oh, yep, gears down.
And fun fact,
So,
we settled on the shape of the vehicle back in 2019. We haven't changed that shape of the vehicle since. So we've had a lot of confidence in the shape of the Talon vehicle. We call it the OML, or the outer mold line. So
okay,
that
yep.
shape you've seen, our design engineers decided on that back in 2019.
Wow.
There you go. Talon will have, of course, for powered flights at least, will have, control services so it can, it's not a morphing wing per se, but it'll, steer itself during its flights, right? It's not like a static shape.
Sorry, was that a question about Talon?
Yeah.
It will, yeah. So it has flight control surfaces, so it's a maneuverable hypersonic vehicle.
Does that thrust vectoring or no?
No, control authority is from the flight control surfaces.
Yeah, okay. Gotcha. Checking in on Rock, looks like it's starting to descend a little bit too from 7,000 originally. Kind of flying a right base for runway 30. So should be making a right, from this camera, you'll see a right-hand turn to line itself up with the runway. And we should hopefully expect some low approaches here shortly. But you can definitely make out that the flaps and the gear are all down.
Yep. Next step is approaches, and I hear we're actually planning to do quite a few before we land.
Okay. Well, we'll get lots of up-close views then. Sounds good to me.
I'm not complaining.
Yeah, exactly.
Do them all day. We have so much gas. Come on, pilots. Our chase.
Go for another loop.
Our chase plane. What did we decide? Pebble or
roll? Yeah.
Yes,
Pebble
they
or
will run
roll.
out of gas. They'll run out of gas before Rock does.
Yeah.
Oh, yeah.
Oh, wait, no, I saw a good one too. Somebody said something about Chase being called Kevin Hart because it's chasing after Rock.
That's pretty good.
So thank you, whoever suggested that.
I like Chad is good at those kind of things. We appreciate that. But just a great view of Rock right now, kind of flying between Mojave and Edwards Air Force Base also. Kind of, it's all in that same kind of airspace.
Actually, read the logo. Look at that.
Yeah, seriously.
We've been staring at like a few muddy pixels, like way off in the distance, and now we can almost see into the cockpit.
Yeah, if I maybe stretch my imagination, I could almost read the tail number.
To like squint down to 2010 if I were to try that.
Yeah, they're okay. So you can almost count all 28 wheels tires that we were talking about earlier.
All 28 tires.
Almost,
Perfect.
yeah. And then there's even more doors than tires, right, James?
Wait, really?
34.
There are, yeah. Some gear have
34.
There's like 4
gear
doors on. Because the doors are very complicated.
Yes, you think it'd be an afterthought. Just okay, the gear is the hard part. It's integrated. It can retract and extend. All right, the doors are just slaps them on, make sure they close. No, the doors. It's a patchwork quilt of multiple doors.
It's like all time sensitive and sequenced where they have to close in the right order at the right time.
Huh.
Yes. Gear doors made up of 34 moving panels.
Wow. Are those also stolen from 747s or?
Those are custom in-house panels.
Oh, really?
Sure.
Yeah, I think most of them were. I think most or all of them.
Yeah.
I think there were none from 747 because our OML is different from the 747.
Yeah.
Our outer mold
okay,
line.
yeah,
So
yeah.
so their gear doors wouldn't, be the right shape. But
Right, that
we
makes
might
sense.
have taken some of the internals, like the linkages and whatnot. We might have taken some of those from 747.
Sure.
So yes, more doors than wheels, more wheels than
Gear.
gear, more gear than engines, more engines than
Fuselages?
fuselages.
But more fuselages than one.
Yeah. Oh wait, no. Where do flaps go in? Flaps are 14, so more wheels than gear. No, more wheels than flaps. More flaps than gear.
There you go.
Yep.
Nice.
This is like a Johnny Cash song.
Yeah.
Does he have a song about landing gear wheels?
No, he has a song about like piecing together a car by taking out like a headlight at a time from the factory. Like a wheel.
One piece at a time.
Yeah,
You did
one
it
piece
off
at a
to the
time.
dime. Yeah, you got it.
That's it.
I'll have to look up that song.
Yeah, it's a good one.
Sounds entertaining.
All right, so according to flight radar, Rock is down to under 4,000 feet above sea level. So that's getting close down to field altitude for Mojave and is now pretty much well lined up with runway 30. Same runway it took off from about, that was like 4 hours ago. And the beginning, there's that runway shot head on.
Talking about
On
lined
its
up.
way. Yeah, you can tell it's lined up because, well, here we are. And this will be
Yeah,
the first of
long
likely
final.
several low approaches. A long final. Yeah, we did talk about that earlier, how it does take a nice long final approach path.
Do
And
people
look at
call
that.
long final when you're on the radios? You call short. You're like, okay, I turned base. I turned final. Now I'm on short final sometimes.
Yeah.
Do people
I guess,
call?
I mean, if you're
hey
far
guys, I'm
enough
on
out,
long
it's got to be
final.
long final.
Yeah. Really long.
Really long final. Yeah.
You can
Oh,
see
shout out
Talon
to Layla
bring it down.
Kelly. It looks like she is listening.
Oh yeah.
This is James Kelly's
My-
mom.
My mom, Lily Kelly, saw that
Hi.
all the way from Mojave. She's back in Mississippi.
Wow. Yeah,
Glad you tuned
I
it.
think I saw a question earlier about whether we have a designation of super heavy, or
Oh, yeah, we were talking
heavy,
about the
super
heavy or
heavy.
super.
Man, I don't learn because we talked about this last time about what the differences are and
Well, I think what
Oh,
it
do you
actually
change?
is
Okay.
rock super heavy experimental.
Okay.
Wait, yes, but is super heavy an actual official title? Is it a military term or do air traffic controllers actually use it for anything? Like what is it actually? And last time we talked about it, I think we educated ourselves and I forgot.
Right. I remember listening to you guys talk about it.
And you don't remember? Okay. Well, okay, so they're approaching. Watch this.
Yeah, should get some audio back coming in now as well. This is just a low approach. Expected to just be a low approach, not a landing yet. Nice. Very smooth. Amazing at that altitude. It's still kicking up dust off the side of the runway, by the way.
Okay, so this is 100-foot approach. It looks really close to the runway, but remember, the wingspan is 385 feet. The distance between the
Right.
two fuselages is 100. So take that, turn it 90 degrees. That's about the distance that they were going to from the runway.
Again, a great view of Talon underneath that now as well. Nice. So that is the first of, and you said that we're expecting several low approaches, is that right?
Yeah. Oh, this is a good shot. Okay, it was.
It was. You mentioned it. Jeez.
Enhance.
Yeah.
Zoom it, enhance.
Waiting on a camera to reacquire it. I think it got too close to the cameras.
Yeah, so super heavy. I don't remember our last conversation. But at
Yeah, I
one
mean,
point
there
we
are
were
definitely civilian aircraft. I think it's the A380 that goes with the super instead of a heavy at the end of their call sign. And we were talking about how obviously Rock is an experimental aircraft, so I'm not sure it has to specify like heavy or super in all of its ATC communications. But as far as the wake level that it creates, was wondering which
Yeah.
category it falls into.
Yeah, and I was wondering, is that the only reason why we have those designations so that air traffic control knows how to like route airplanes for wake and
Yeah,
how
yeah,
long
it's
to
the
wait
the
after an
separation
airplane comes
after
up?
it for a takeoff and landing, so that other airplanes don't get too
Yeah,
negatively affected by wake turbulence. Yeah.
that makes sense. It's not the only thing though, for whether something's super heavy or not.
I mean, could it be like a runway weight limitation? I don't know.
Not sure. Or maybe how tightly they can turn. If they're like, tighten up your pattern, you're like, I can't, I'm a super heavy.
Yeah, maybe I don't know. There might be other considerations. I know the biggest thing, of course, is like if you listen in on ATC, you'll hear caution wake turbulence. There's a heavy in front of you or whatever.
Yeah, yeah. Once we were, I don't know if I haven't actually called this to the tower, but it was super experimental heavy. Like the parentheses is around super heavy experimental.
Yeah, that's what Scott was saying.
Super experimental is not a
Super experimental.
Yeah. The first flight ever might have been super experimental. Now it's just experimental.
Yes, we have been downgraded or upgraded.
Well,
Depending
yeah,
on
I
how
would
you
say
look at it.
that's an upgrade. That means you're farther along in the development, obviously. But yeah, now back on the downwind leg of the pattern, so flying parallel with the runway but in the opposite direction.
Oh yeah, so I guess this will answer the question that we'll see if I was right earlier about what pattern rock flies. So
Yeah, we'll see on this leg how long of a final it takes.
yes, but they are indeed doing a clockwise.
Yes.
Clockwise
A
pattern to
right-hand
30,
pattern,
so
yes.
right-hand pattern. Oh, right, of course. Can tell I haven't flown in a while. Yeah, doing a right-hand pattern.
Well, if they
Just
let
like
you fly
everybody
the
else.
rock, we wouldn't have, you'd have plenty of time.
Yeah, same as everybody else. Probably a bigger pattern. Probably higher.
But I gotta love the Mojave wind turbines in the background as well. Yeah, looks like it is just about past the end of the runway now. So like right now it's just past the beginning of the runway, just going in the opposite direction. And so we'll see how long it extends this leg before it turns back in for another final approach and another low approach. And definitely let us know when you hear which one's going to actually be a landing.
Yep.
But we'll expect a couple low approaches before then.
Yep, a couple more low approaches. Plenty of fuel.
All right.
Thinking about the super experimental comment, wasn't the first flight on like the day of the Mojave airport or spaceport experimental
Yes.
fly-in? It was like
Oh,
we
yeah.
flew the most experimental possible thing
It
on the
was, we
experimental
sh-
fly-in day.
We got like an honorable mention. Or
Did we?
Something
Okay,
like
I was kidding about that, but I thought we should have. They give out some awards every year for best new build experimental,
Right.
and best like test sequence or something like different categories. We should have got
I think
best
no one
like
made something.
most experimental airplane.
Maybe it was Tanner made like a special little plaque.
I feel like if
We
you got
gotta-
honorable mention, if you actually did get honorable mention, that's kind of amazing.
Yeah.
Like it's almost so hilarious. It's like, okay, I'll allow it.
Well, what's hilarious is we didn't get the first prize. Like, come on, we didn't get a prize. We got honorable mention. Okay,
Yeah.
all right, guys. Cool, bro.
But yeah, looking at the map, it looks like Rock is taking about as long of a final as it did last time. Still hasn't turned in for base to final yet, so another longer approach. But yeah, one low approach already done. If those are may just be tuning back in, I know we kind of tweeted out that it's coming back for landing, and we'll get some really good views here. We already saw one low approach over runway 30, and Rock's currently still on an extended downwind, waiting for it to turn back for another approach. Are there any Talon captive carry specific test points that they're looking at during these approaches?
Talent specific. In a way, all of them are. Like, we wouldn't be doing this test flight if we didn't have Talon attached.
Sure.
Because we've already done all of the things. We've done the pitch captures, the NZ captures, all the stick wraps. Like, we've done that already without Talon. So this is just doing basically everything we've done before, but again with Talon attached. So in a sense, they're all for Talon. But
Gotcha. Okay.
James stepped out of the room, so put it all on him. We'll see what he says when we get back.
But yeah, no, I see what you're saying. Like, everything they document on this test flight has to do with how the aircraft behaves while carrying Talon. So
Yes, that's the difference for today from other previous flights. Now there's good data that we will get for like rock information and rock only, but it's all of the cards that we wrote are because Talon's attached.
gotcha. But yeah, definitely back on base now, turning back to Mojave for another approach. Some really awesome camera views. It's almost like it is a beautiful aircraft. It just looks so different from every other one that you've ever seen. And
In a
it's
lot of ways,
awesome.
Isn't it?
It reminds me of Starship. It really does, just because one, it's so huge, the way that it moves is distorted by its bigness.
Yes.
The same thing happens with Starship. I suspect the same thing will happen with SLS as well. And then the other part of it is just how unique it looks. I mean, again, Starship is sort of a unique rocket in a world of all different types of rockets with a weird belly flop thing. Rock is a very unique aircraft, even amongst the aircraft designed by Scaled with this sort of dual fuselage design, of which there's been a couple. There's been like, what was it, Voyager and like Proteus and of course, not Cosmic Girl, Virgin Galactic's carrier aircraft. So
yeah,
there's-
White Knight 2, White Knight
Thank
1.
you. Thank you.
Both of them. Well, actually, no. White Knight 1 wasn't dual fuselage. That was on
Yeah.
centerline fuselage. But I think the most interesting for me was Boomerang because not only was it 2 fuselages. Well, I guess it wasn't really fuselage. Nobody sat in it, but it kind of was 2 fuselages, but they're different sizes.
Yeah, that one
So
looks.
that
one
was
looks
really weird to
amazing.
me. I was like, how does that work? Like, there's one engine on one of the fuselages and one on the other quote unquote fuselage, but nobody was sitting in it. So it was more like a pod, but a biggish pod. It looks like 2 fuselages.
Oh, and I don't know if we came down definitively on one side or the other, but I did just turn my radio on and I heard the tower talking to Rock. Rock refers to itself as Rock 01, and it is called by the tower Super Heavy. Rock 01 Super Heavy is how the tower refers to it. So Super Heavy indeed.
There you go.
It's official.
Yep.
I still like Super Experimental though.
Yeah,
Or
I do
super,
like that.
sorry, Super Experimental Heavy. That's the best possible combination of things.
Not anymore, apparently. It's been upgraded. You definitely, don't want to take off right after Rock takes off on the runway.
No. That's got to be a consideration for releasing Talon, right? I mean, it should fall away kind of well ahead of the wake turbulence. Like, is there any sort of expected effects from Rock's engines on Talon, or is it designed so that Talon will fall away and start its flight without ever interacting with Rock's wake, basically?
Well, I don't know about the engines. The entire separation analysis is, I mean, it's obsessed with what the rock effects are on Talon versus Talon free flight. So much effort is put into characterizing that. I'm not sure how much of a role the rock engines played in that. Do you have any idea, James?
I don't think they played a large role. From what I can remember, I don't ever remember them being mentioned in that SAP analysis.
Mm-hmm. But it is definitely all of the aero effects of rock itself, not including the engines.
Talon falls away pretty quick, and I think gets out of any of those effects.
Yeah, but there was a lot done to substantiate that. There was
Got an interesting question. Oh, go ahead.
Yeah, I think maybe you were getting to the question about the fuselages, like the space between.
Yeah, go for it.
Yeah.
I was?
No. Now I don't remember what it was, but
It was asking about
Rock's coming
basically
back too.
Oh yeah, we'll come back to it.
Yeah. So this is also a low approach. That shot.
That's awesome.
Love that runway
Shot was
shot. So good.
Was that too loud for y'all?
Nah, it was great.
Louder. Feel the thrust. 360,000 pounds. Actually, I don't know if they have all the engines pushed up or takeoff. They definitely don't need it.
Yeah.
Not sure if they do.
All right, low approach number 2. But yeah, circling
There you
back
go.
to that question, Grace, about any weird pressure zones between the 2 fuselages that cause any interesting effects or anything like that.
Yeah. Yep, that's the question. So I wanted to get to that because it ties in really well with what we were talking about, that separation analysis, and whether the engines played in. And James and I are like, I don't think so, but Rock itself does a lot. And interestingly, the fuselages don't play a big role. It's more of the center wing. And I guess if you just look at distances, that makes sense. Like Talon is pretty far from the fuselages, and
Sure.
it's pretty close to the center wing. So yeah, based on CFD, it showed the fuselages aren't a huge effect. Also, they're flat panels. The flow is like pretty constant between the two, and the effect is really from the center wing, not the fuselages. So it turns out that the separation analysis we did and the wind tunnel testing we did, we didn't even model the fuselages. So Talon was in the wind tunnel, and then we did have a rock center wing model in it to vary the relative positions of the two, and that helped us place Talon. So we, wanted to see if we should mount Talon a little aft of nominal or forward, or we picked a nominal and then say aft or forward, up or down, where is the best according to what the effects are from the center wing. And so we had both the center wing and Talon model in a wind tunnel. And I just learned this from Andrew McComas. I asked him this question. He's the same engineer who answered our Bronco tail question about deep stall. So he said that we moved the center wing, actually, instead of moving Talon. So in the wind tunnel, we just moved the center wing around, which it's effectively the same thing. We're trying to find their relative positions, but in an aircraft frame of mind, I'm like, yeah, you move Talon around because the airplane is where it is, but in the wind tunnel, they actually move the center wing around instead. So yeah, they use CFD and wind tunnel data to quantify the effects of rock on Talon.
All right, gotcha.
But no fuselages included. The center wing just spanned the entire wind tunnel. Yeah, stopped at the walls of the wind tunnel.
Yeah, that makes sense. I guess that's what would be considered far field, so the airflow doesn't impact.
Mm-hmm.
All right. The other question I wanted to come back to, and of course this is relevant as the aircraft goes through low approaches and prepares for landing. How much gas does the rock hold, and does that exceed any sort of maximum landing weight? Like, obviously there's the maximum takeoff weight, maximum landing weight. Do those even come into effect, or is rock kind of built to fly no matter how much weight you strap to the thing? Like, what are your kind of limitations for that, and what is the fuel capacity?
We do have a max landing weight. It depends if you're carrying payload. So round numbers, empty rock is 500,000 pounds. It's a little more than that, but 500,000 pounds. We can carry 300,000 some pounds of fuel. Let me convert that to, well, it's about 6 pounds per gallon, I think, right? So then that's like 50,000 gallons of fuel. But in pounds numbers, 500 for the airplane, 300 for fuel, so that's 800 total with no payload. Our max landing weight is 1.1 million pounds. So if we take off with full fuel and no payload, we can land immediately. We don't have to fly around to burn gas or dump it or anything. It's all good. But our max takeoff weight is 1.3 million. So if we did have like full payload and then gas up to 1.3 million and we took off, we would have to fly around and burn fuel or dump it or dump the store before coming back. We'd have to lose 200,000 pounds.
Yeah, I gotcha. There you go. All right, so Rock now back on the downwind once again. 2 low approaches in the books. Any word on how many approaches they're expecting to keep doing here?
Yeah, I think we're gonna do another one and then land on the 4th, or maybe we'll do 2 more and land on the 5th. I think
Sounds like one more.
land on the 4th. Yeah, but as a pilot, you always reserve the right to. You
Right,
will
yeah,
always do a low approach if you don't feel like landing that time around.
Exactly.
Especially when you're not crunched for time or fuel or cranky passengers trying to get off your JetBlue flight. Like, there's no rush with us. You can come around as many times as you want until it like looks real nice and then put it down.
All right. Rock is usually flying these patterns a little bit above 4,000 feet, it looks like. And ground speed looks to be about 150 knots for those who may be interested. Coming up on the point where they'll make the turn for a back for another approach, and sounds like at least one, maybe two approaches. Also depends on, even when they go for landing, they can always turn that into a low approach. That actually comes up. A lot of people ask us about, for rocketry, wet dress rehearsals and like static fire attempts and launch attempts, where a static fire attempt is a wet dress rehearsal until you actually light the engines, and a launch is a static fire attempt until you release the rocket. Well, a landing is just a low approach until you actually land. So can always hold
That's a
off
good
if
way to
it's
put
not
it.
looking great. Yeah.
Yeah. Uh-huh.
But yeah, we'll expect to see that turn real soon here.
How about from this angle?
Nice.
So it's coming. I like this because we have like cameras on either end, so it's going towards
Yeah.
one camera, away from the other one, then away from. It's really cool to have the two geographically separate shots like this.
Yeah, I think it's starting to make that turn now. There it goes.
Look at this. Usually, like aircraft spotting the rock is like a 2-for-1 special because you get sort of 2 aircraft for 1, and it's 3-for-1 today.
Yeah.
Got Talon underneath the center there. Look at that.
We're giving you all an extra deal here. It's BOGO aircraft.
Buy one, get two free?
Yeah, new bonus hypersonic, like.
Yeah, another side-on view. Again, this is turning back, still using runway 30 at Mojave. This will be a third low approach. And this is concluding a 5+ or 4+ hour, I guess, test flight. It was the first captive carry test flight for the Talon-A, and the vehicle in tow today specifically is TA-0, which will eventually be the separation test article. So this one won't actually fly on its own, but it's helping Stratolaunch characterize the carrier aircraft as it flies with Talon-A under wing, and that'll set up for the TA-1 hypersonic flight and the TA-2 hypersonic flight and landing. Well, not a hypersonic landing. Landing at hypersonic sounds problematic. Hypersonic and then slowing down and then landing.
That would be thrilling.
That would require a
Almost-
very long runway.
Almost as thrilling as a rock going hypersonic.
Right.
I don't want to think about like the shock waves of a rock going hypersonic. That sounds like problems.
You know, we should put a piece of, just for legacy, put a piece of rock, a tiny one, even some ground up carbon dust from rock
In
in
Talon.
Nice.
Talon.
Yeah.
Yeah. So
There you
part
go.
of
So rock
can
did go hypersonic. See,
Yeah,
I like
just
that
like-
idea.
Like
I was
the
gonna
say-
wing. Go ahead, Jack.
Oh, it's a really bad joke. I was going to say if rock ever makes a shockwave, you have to call it a rock wave. Okay, now Das, say
No.
what you want to say.
No. Yeah, it will continue our legacy of, I guess, piggybacking airplanes. We have some like splinters of spruce goose inside of rock.
Oh, there
you
we
go.
do,
Nice.
Oh,
we do gets it from what or where. But I wonder if spruce goose did that. So it's like a chain of a chain of airplanes. So then if we get some rock powder into Talon, there's like by second what is it called? Your degrees of separation.
yeah.
Oh,
Second
yeah.
degree of separation. Spruce goose has been on Talon going hypersonic.
Well, it's funny because, like, if you think about it, I mean, Talon's going to have the mass and volume constraints to carry sensors and things on its research missions. So clearly, you've got room to put a little piece of rock in there. It's just a mass simulator for a sensor.
Right. Yeah, James. Can't you guys afford just a little,
Yeah.
like 2 grams or something?
I'll talk to the
Yeah.
team, but I think we can.
Okay.
I think we can do that.
Okay, thanks.
A small fraction of the payload
Yeah.
capacity.
Yeah. Your team will charge by the pound. Be like, okay, Rock, you guys owe us $2.50.
Right.
All right, so
Lined
back
up there
on
again.
a final
Yeah, go ahead.
approach here. Yep, lined
Yep.
up again. Another long final, if you will, but
One of the engineers got back to me with a actually useful answer instead of millions of hundreds of who is in the control room.
Uh-huh.
Yeah, okay, so there's a total of 27 people in the room, 6 rock stations, 7 talent stations.
gotcha.
So, yep.
I was close. I thought 6 Talon. That makes sense though.
Mhm.
Again, this is another expected low approach. Be the third such low approach, and potentially the last one before landing. We'll see.
Oh, I love that. Yes. Rock is, it is the proud parents swinging the hypersonic baby between them. That is exactly
Maybe not
the
too much swinging.
sentiment.
We want to minimize the
Okay,
swinging.
Yeah.
not too much swinging.
Wasn't there like a flutter test or something where you're trying to gauge how much that was happening?
Not that much
She's a
shaking.
very sensitive baby.
The baby, yeah. No shaking babies.
Right.
We have the baby instrumented, so we will know if you did.
Nice.
I think that counts. It looked like Michael kept some piece of the aircraft in. Oh no!
Oh,
No,
you jinxed
Michael!
it to us.
No, I jinxed. Oh gosh!
Oh.
Totally jinxed it.
It was
shouldn't have
going
said
so
anything.
well.
So
It was
close.
going so well.
Uh,
Oh jeez.
so those shots of the under Rockwing, like when you're looking up at Rockwing over the approach end and also over the departing end, those are great places to watch the rock flight test. If you're in Mojave in person, you can get there on public land. It's not on the airport. You just sit there with your car. There's always a few cars sitting out there. It is the best view ever, and you can see rock. It looks like it's 10 feet above your head. It's so loud. You could like feel it in your bones. It's so cool. Have you been out there,
I
James?
can
Yes, I was.
I can
Yeah, I
testify to
got
this.
lucky. I was out there for the very first flight.
Yeah.
Not to brag,
Yeah.
but yeah, that was pretty amazing. I've been out there for 2 or 3, I think.
I'm sitting at the end of 30 right now on the approach end, and rock just flew over me. And
Right? Tell us about it.
for,
Uh-oh.
Uh-oh. Maybe the connection at that spot isn't great.
Yeah. It's too
The
good of a
robot
viewing
voice.
spot. Yeah.
But all right, rolling back around for a another downwind leg. This could be setting up for a landing attempt. We'll see.
Yep. Yep. Could be landing.
Nice. And again, it seems to have been a pretty successful day of flight test, right?
Yeah. Got through a bunch of test points. Got data.
Yeah,
Hmm.
we'll see what the data looks like.
Yeah. We came back. Talon still attached. I was never worried about that.
No,
Yeah.
it's pretty. If you've seen how it's attached,
Yeah.
it's not going to come off.
Least of our worries. Yes, there was a lot of flying today. What time did we say we took off?
8:30.
We're a little bit before it was like 8:20 or something.
8:20. Okay.
Wow.
I'll find the actual time. Hold on.
Oh,
It
so it's been
was
4.5 hours.
What's the records?
Okay. Flight. Oh man, yeah. It's a flight
Takeoff
3
was
that seemed
8:22.
interminable. It was either flight 5 or flight 7 that seemed.
It was like 5.
I think it was 5. I think it was flight 5 that was like 5 hours long. It was 5 plus, so I don't think we'll break that record today.
That's okay.
Do you guys remember? I mean, talking about 5 hours.
I do think
big
it's
deal.
been long. I think we've had flights longer than today's. Yeah.
Yeah, on rock.
Yes. Although this is Talon's longest flight for sure. So there's for
Oh.
what that's worth.
Yeah.
It is.
That's setting the bar pretty high.
So many firsts. Fastest for Talon, highest for Talon, longest flight for Talon, highest number of Gs for Talon, lowest number of Gs for Talon. Unless there's some really gnarly cracks in our asphalt when we were pushing it over. Those are some Gs. I don't know. 1.1.
I did that
1.1
asphalt analysis.
Yes. Did you?
Yes, I did.
How many Gs is that?
It was enveloped by the vibration it would see in flight.
Okay, I mean, I would expect that. I would hope so. That thing's going to go
Yes.
hyper. Well, okay, not TA0. TA0 is not going to go hypersonic.
Yeah, there are actual engineering documents for environmental testing that will tell you what to test to for transportation components.
Yes, yes.
So when
that's so
the
cool.
when the mailman, I won't name any names or companies, but when they throw your box around, you can test for that kind of stuff.
Yeah,
Oh,
and there's
yeah,
little
yeah.
shock excel, like pretty cheap, right? Shock excels you throw into your
Yeah,
box so you
yeah,
can,
exactly.
and it records so you can see what the maximum number of G's it's seen.
Yeah.
Mhm. And on our on the engine box, I think there were some that were directional, or there was some sort of indication
Yeah.
that would like color. I forgot what kind of device it was, but it would show
Yeah,
whether
it's
it
almost
had
like a
been.
tiltometer.
Yeah,
right?
yeah, but like a permanent one where
Right.
there was like a witness mark if
Right.
it had been tilted past a certain angle.
Latching orientation sensor or something. So yeah, you could tell if things that are sensitive to orientation, you could tell if they were turned upside down or turned on their side.
Gotcha. Alright, so again, this is another downwind leg. Rock flying alongside the runway at Mojave should be turning around for a potential landing attempt here. And again, what will basically happen is pilots will begin the landing approach, and if for any reason during the approach or when they're about to land, they want to call it off and wait and do another loop around, they can do that. But they've done 3 low approaches now and are into the window where they can actually go ahead and proceed with landing now. And this wraps up the first ever captive carry for Talon-A, which appears to have been
Okay,
very
yeah.
well.
So this one, they've just called. They're going to do a go around. Just
Okay.
practice, plenty of fuel. You know, I guess the passengers haven't been getting too cranky yet. Can go for another.
I don't know. Did
try.
anyone ask Talon?
True.
This is Talon's
Talon
first
might
ever
be-
flight, dude. I don't know how much longer they want to be up there, you know?
Yeah. Have separation anxiety from its hangar. So take me back home.
As long as the batteries stay charged, we're good.
Well,
Yeah, there you go.
Oh, okay. Well, okay.
Fun fact: the batteries are charged from the carrier aircraft, so through that connection, through what we call the umbilical, it's not only data that goes through there, but it's also power and electrical.
Yeah, the rock carrier craft, what we called the 2 parents holding the hands of they were the proud parents of baby hypersonic. Yeah, it does provide a lot of things to Talon, like care and feeding. So James said signal, power, also LOX and GN2, so liquid oxygen and nitrogen, gaseous nitrogen. And we do that so that Talon doesn't have to carry. So it's all about Talon, yo. So
Right,
it
yeah.
reduces weight on Talon. It makes a lot of sense to keep feeding that stuff to Talon before it drops so that Talon can minimize its weight. Since weight is a critical thing for Talon and not quite
Yeah.
for Rock yet.
Yeah, it's kind of like we've talked about for rocketry. You want to offload a lot of complexity and a lot of mass from the rocket to like the launch pad as much as you can and stuff like that. But the for Rock and Talon, it's kind of offload as much mass from Talon as you can onto Rock and as much complexity, because Rock can definitely take a lot more mass margin and stuff like that than Talon can.
Yeah. Yep. Exactly. And then taking it even further, there's the trade between Rock and its GSE, the ground support equipment.
Sure.
So there's Talon versus Rock, and then there's Rock versus GSE. So we're like, okay, how much of it do you want to build into the airplane versus how much do you want to tow along? And
Sure.
that's the APU trade. That's one
Right.
of
Yep.
the like GSE versus not sort of things. And one of the pieces of GSE that we ended up putting on the pylon that everybody is always super psyched about is there are 2 winches in the mini wing, and that's what we use to attach Talon to Rock Wing. So we could have used there are a couple of different ideas about different ground support equipment to like push it up from the bottom or to winch it up from the top using different structure, but we made the trade and decided to put that GSE inside of the carrier airplane and just fly it around.
Yep. There you go. Turning back around and now heading toward Mojave once again. And this is now going to be another low approach.
It's coming right for us.
Once again, it is coming right for us. We do have a question about what kind of timeline does Stratolaunch have for the next captive carry?
Yeah, so captive carry series is now through end of year. We're anticipating drop flight of TA0 by end of this year.
All right, and you mentioned several captive carries between now and then, right?
Yep, yeah, this is the first in a series.
Gotcha. Well, I know a lot of people will be paying close attention because seeing Talon get to fly free, albeit briefly, on a drop test will be a big milestone, and then of course hypersonic is the big one. And you said TA1 is going to get its own set of captive carry tests, right?
It will, yeah. So we'll go through a very similar series of tests with TA1 that we're doing with TA0 right now. So few captive carries. Well, actually, we'll start before that. We'll do vehicle level testing with TA1. We'll finish vehicle level testing. We'll roll TA1 over to the big T hangar, mate it with Rock, and start doing integrated testing. And once we're through that, we'll go through the same sequence, go outside, do EMI, EMC testing, engine runs, taxi testing, and then build up to that first captive carry again, and then on to hypersonic flight after that.
Sounds exciting. All right, lined up once again with runway 30. Another low approach with both Rock and TA0 under wing. And we'll stand by for that awesome jet noise as well as it gets closer down. Here it is. You're gonna get this runway shot, this head-on shot, which is just so cool. It also shows really well like the inputs that the pilots are making.
Hangs in
some
the
other,
sky above the runway forever, it looks like.
Yeah, absolutely. It like Jack said, it like the size distorts
Yep.
how fast it looks.
Yep. And this looks like a go around.
Yeah.
Oh, it's so cool. I can hear it like through the feet, but we can also hear it just from outside of
Oh
the
yeah.
James just said it's rattling the walls.
Yeah, it is. It shakes the whole building.
Wow. Yeah, the houses here in Cape Canaveral area get that every once in a while too, but from a jet noise, I mean, that's even more, that's awesome.
Yeah, it's really cool down there at Cape. I watched STS-135, the last shuttle launch at Cape
There
Canaveral.
you go.
I watched a few launches there, but being, across the water on
Yep.
whatever the island is or whatever the area
Merritt
is
Island,
there.
maybe?
Yeah, maybe. But you see it go first, right? And then you
Yes,
hear the
yes,
thunderous sound
Yes.
kind of coming across the water.
Uh-huh.
Super cool.
Oh yeah, the
But
water
for
must-
planes,
the water
like
must be
like for
so
rock
cool.
here, you can get a lot closer to rock than you can to a rocket
Does
launch.
carry better over water?
I guess there's just less stuff in the way, so
I saw a launch
maybe
from
that way.
Vandenberg. I think it was a Minuteman.
Oh, yeah.
It was at night, so it was
Oh,
spectacular.
that was cool.
Yeah, everything was dark, and then you see this like huge orange plume, and then you see it, and then you like hear it and feel it after.
Yeah.
It was so cool.
I always wanted to do one of those time lapse photographs, so you get like the big laser trail, of the rocket engine.
Mhm.
It's really cool.
Can anyone hear me?
Alright. Yep, we got you, Jack.
Am I a robot?
Nice.
Yeah,
sound
we
good to
can
me.
hear you.
Hooray.
How you doing, Jack?
Yeah, Jack. So you're out there. How you doing?
Yeah.
You've been out there all morning.
Oh, I'm just running around trying to get some cool shots. I'm doing good. It's a good day for a test flight. Like I was saying this morning, it's really nice and beautiful out. Absolutely beautiful aircraft, and a little bit of history being made with Talon getting its first flight today. So I'm in a good mood. I don't know if you can tell. I'm in a very good mood. I have
Well, we're glad.
I have some ridiculously cool pictures I'm excited to share with everyone when I get a chance. But right now, the thing's in the air. Things are still happening. Joy.
Yeah. So that's another low approach. That was the fourth one back into flying downwind. I keep wanting to say downrange. Downrange is a different thing. Downwind and making its way down for another low approach. I'll keep checking if there's more questions and stuff coming in during these last couple approaches here.
Question.
You see it. Oh, go ahead, Jack.
This will be for Grace and James there. What, like, do you guys have an internal, how should I put this? An internal version of rock, paper, scissors that's like rock, pylon, talon?
Oh my gosh, Jack.
All right, I'll mute myself. I'll mute myself.
We
I'm
do
gonna
now.
mute you. We do now.
Yeah.
Well, okay. Let's talk about that. Which one would you? Okay, first, what would the symbol
Yeah,
be?
well, which
for
one
rock?
beats which one,
Rock
though?
would be
That's the
this one.
question.
Rock would.
Did you
Wait,
just make
rock,
wings?
pylon, talon.
Rock would be
Rock-
rock, and rock beats everything. It's not a very fun game, but it's accurate.
It's not very fair.
That would be a short game.
I think Talon could outrun Rock, though. I think that would be
That's
the only way that
true.
it would
Okay.
win.
Okay, so Talon can beat Rock in speed. Rock would beat Pylon in, I don't know, weight. And Pylon would beat Talon in amount
By
of
dropping
locks
it?
carried.
Yeah, Pylon has like maximum endurance because it can carry a lot of weight, maybe.
Mhm. Well, I don't know. Rock can carry 200
Rock
Miatas.
This is sounding more like an RPG or something than a a role playing game where you have to track your
Yeah.
stats.
Yeah. How...
Rock's a character, Talon's a character.
They do have their own characters just because, the nature of the design and also the
Yeah.
people that worked on them.
Yeah, that's true.
Hey, Rock about halfway through the downwind leg again. Any word on this will be another go around or if they're getting ready for landing?
Or just if you dropped Pylon on Rock, Rock would be more okay than if you dropped Talon on Pylon.
You're talking
Grace
about
is still
just
doing the math.
dropping them and smashing.
Yeah, just smash it. I mean,
Just the smash effect.
Yeah, Rock can smash both. So yeah, that doesn't work because we need Rock to lose in one scenario. I can't think of any way Rock loses, but I'm biased.
The
Rock's
Talon
like-
outrunning Rock, I think,
Yeah.
is a valid
Okay.
argument.
Okay.
I just want to say
'Cause
thank you,
again-
Grace, for indulging my stupidity. I really
Oh, was
appreciate it.
it?
I don't think anybody has ever as much as you, so thanks.
No, that is a fault of mine. I take things too seriously.
Well, I mean,
This is a serious question.
we're already developing game rules.
Yeah, might as well.
There's going to be a rule book.
Finish what you start. Yeah, we're not quitters.
All right, getting ready to make another turn inbound here. Oh, we did have one question coming in here as well, because we were talking about the mass margins earlier. We were talking about the landing weights and stuff like that, but we were talking about the Rock. What about Talon? What kind of payload capability as far as mass goes does Talon have? It's got to be a much tighter mass margin.
Oh yeah, Talon payload capability. We can carry payload in multiple bays. There's 2 or 3. There's a couple bays internal to Talon that we can carry different things depending on like where customers want it. I think one's in the nose. There's one kind of further a little back.
Yeah, almost anywhere inside the vehicle we can carry a payload.
And then there's like you can externally mount payloads too when
Yeah.
you want them actually exposed to the air in that hypersonic
Yeah.
environment, testing TPS and stuff. So yeah, there's external mounts, there's internal mounts, there's a couple of different bays. Basically, whatever you want.
Yeah,
There you go.
there are a lot of different options.
And as you mentioned earlier, there's also obviously definitely room with Rock to carry larger vehicles.
Yes. Yeah, definitely larger in weight and in volume.
Mm-hmm.
Can see it
All right.
doing the big
Yep,
turn
there's
there.
the turn. Yep.
Yep. I thought I was super clever I figured the banked plane would fit in the little box as it did the turn. Of course, the nose sticks out as soon as I say that.
It's a large plane, to be fair.
It is a very large plane.
But yeah, so yeah, checking back in with Grace and James. Any word on whether this is a landing attempt?
I think they're all go-arounds until one is a landing attempt.
Well, yeah, so
How's that?
we know that, but you know.
Yeah, this one's a landing attempt. We'll see.
Okay,
know.
gotcha.
You get
It
down.
is a
and-
potential landing.
Yeah, it's super nice. Yeah, I would put her down. It's not go around. Why not? We have time. We have fuel.
Got nothing but time and fuel.
Hmm.
It's not like a rocket engine. Turbofans give you a little bit more leeway as far as burning your fuel.
Yeah, we've got 300,000 pounds of it. I mean, capability. All right, how much fuel do we have right now?
Yeah, did you even, is it even fully fueled at the beginning of today's flight? I mean,
We didn't. We definitely don't.
right.
We had about 200. Yeah, we had about 200,000 pounds of fuel.
Yeah, I think it was 205. What we started with?
Yeah.
Yeah, 205, I
Yep.
believe.
And I
So about a
think,
2/3 fuel load for the flight total.
yep. And then a few cards ago, I think we were at 100. We had 100,000 pounds of fuel left. Yeah.
But obviously, you're also going to land with a pretty healthy margin, so. All right, should be lined up for what could be the last approach here, an actual landing. But pilots at their discretion can decide whether they need to go around again for sure. But again, this is kind of the last step in a very long day, but successful day of test flight with not just Stratolaunch's Rock aircraft, but also now the first ever Talon-A vehicle underneath. This is setting the stage for a separation test before the end of the year. And then the second Talon vehicle, TA-1, will be the hopefully the first one to go hypersonic.
Yeah, first flight of TA-0. We're probably gonna see the first landing soon.
Very exciting.
Come back, yeah, do all our
Did
inspections.
TA-0 land if it's just being carried by a plane that lands?
Okay. Let's see. Captive carry landing. Yeah, I guess we wouldn't call it a landing.
Well, wait, by that logic, like if you're skydiving with somebody like tandem, you're not really skydiving, you're just sort of attached to them, right? Is that
Yeah,
what we're
I
saying
guess.
here?
Yeah, I guess I wouldn't call you a skydiver, just like we're not calling Talon an airplane yet. It's not. It hasn't flown, it hasn't glided. It's not a glider, it's not an airplane.
Well, okay, to be fair though, Talon has definitely contributed lift. Talon has contributed lift to today's flight, surely.
Actually has it. It's mounted a little bit nose down, like it's mounted nose down on purpose to
so
not make lift
on purpose, so it doesn't do that?
Yeah, at high enough speeds it will make lift, but I don't think our speeds today have crossed that threshold where Talon's making lift.
Probably has. I mean,
Yeah, it's probably making lift, but not more than its weight. So really, like overall, is it?
It's only reduced how much weight Rock has to carry by having an airfoil. Yeah.
Sorry, James. Sorry, it is an airplane. I'll call it an airplane right now.
it's not an airplane, it's a rocket plane.
Okay, it's a rocket plane. It's a rocket plane. So a skydiver doing tandem is called a skydiver. Okay.
Building hours on Talon.
All sounds good to me. But here we go. Let's see if we can set her down again. Runway 30 at Mojave. It has been a gorgeous day for flight tests as well, I gotta say. Here we go. Approach number 5. Now over 5 hours into today's flight. There it is. And touchdown. That'll be 5 hours and 7 minutes of flight time today. Rock has touchdown on runway 30.
Nice.
It was awesome.
Perfect. Look at Talon just perfectly above center line.
Well done.
Check that out.
Congratulations to the Stratolaunch teams on another successful test flight today. That is the first captive carry of Talon-A in the books.
Woo! Yeah, good job, team.
Yeah.
Talon, manufacturing.
Thanks to all you guys out there listening too on the Strato team.
Mm-hmm.
Yeah, thank
good
you to
job,
everyone
everybody.
who tuned in, but especially, I mean, if you worked on this thing, congratulations to you. But thank you everyone for joining us for a long day of test flight here.
Seriously, congrats. It's been a long time coming, right? Like, first flight was back in 2019. I'm sure this has all been in the works many years before that even. So for those of you that have worked your tails off on this program for so long, congrats. It's an awesome, huge day. Hooray.
Thank you. I know everybody, the man hours put into this.
Yeah. So much time.
2013. Yeah, okay. So I spent the better part of my 20s working on this.
Oh, I did too.
You did too, yeah.
That's how I graduated.
I guess not a terrible option. We could have been out partying, doing other stuff, but instead, toiling away on our computers,
Yeah.
looking at charts.
Yeah.
Well,
Writing
look,
work
all that
orders.
work has definitely paid off so far, and I think we're all looking forward to the next steps as well. But a big thank you to Grace and James for joining us from Stratolaunch and keeping us updated on how the flight was going and answering all of our in-depth questions about how many Miatas Rock can fly and things like that. Thank you
Yes,
both so much.
And narwhals. Thank you
And
guys. I
narwhals.
always have so
Thanks,
much fun.
guys.
Did you, James? This is James's first time.
Yeah, no, this was awesome.
Good.
Yeah. Fantastic tonight. This was really cool.
Yeah, and also a huge thank you to Stratolaunch for partnering with NASA Spaceflight and helping make this stream possible. Happy to partner and bring live coverage of these test flights. Looking forward to rocket-powered coverage of Talon in the future. But I think this is our cue to go ahead and start wrapping up our coverage. I do want to go around the horn and thank the NSF folks as well. I know we had a couple people operating on the back end. Both Das and Michael Baylor were pushing buttons and pulling levers as they do, and I think we got Das on comm. So Das, thank you so much for your support.
Absolutely. It's always fun to see the rock fly, and we had some awesome shots today. So thanks again, Stratolaunch, for working with us on this.
Yeah, for sure. Also had a couple other people on commentary from out in the field. We had Mr. Jack Byer. And Jack, good day of flight test for you?
Any day of flight test that's successful, that you gather data, that everyone comes back safe and okay, is a good day by me. So what a perfect, absolutely awesome, amazing day. Hooray!
Absolutely. Also had Pauline Acklin out there in the field. So Pauline, thank you so much for all of your support today. And we also had a couple other people on studio comms. You had myself, Thomas Burkhart, as well as Chris Gebhardt was on comms earlier as well. So a big shout out to the entire NSF team and the Strato
Is Michael
team.
right? Sorry about that. Is that yeah.
Yeah, we do have a
Rock?
little it was a little Easter egg of air traffic behind us there, maybe going to a nearby Air Force base or something, but that was pretty cool as well.
Just don't mind me. I'm just flying here. Oh, thank
Pretty
you. All
weird
the
that you
camera
have a
shots
plane
were...
that could,
Go ahead.
just a plane that can make the C-17 look small is a bit weird.
Yes. Thank you. All the camera shots were so good.
Oh, I'm glad.
So good. All
Happy.
the views. Yeah. And that drone footage at the beginning.
Oh yeah, the drone footage
Yeah.
of Takeoff, that was pretty cool too. That was a cool trick that we had.
Mm-hmm.
But I think that'll do it for our live coverage. So thank you everyone who sent support and questions our way, and we really do appreciate all of that. And that'll wrap up our coverage for today. Stay tuned for future aerospace coverage here on NASA Spaceflight. But on behalf of the entire NSF and Stratolaunch teams, I think that'll do it. Signing off for now. Thanks for watching.
We have liftoff. Propulsion continues to be normal.
Chamber pressure looks good. Doubling up.
Water towers can fly! Yes!
Tango Delta nominal. Flight is outside SCE off. Bring in SCE off.
Yikes. You bet. Concur. We don't need any more of these.